conceptualize and organize this vibrant pioneering conference. A special thanks to you, Dr. Hemant Kagra, Senior Professor Management, who led this effort from the front. I'm sure that we shall have many more editions of this conference here in the National Academy of Indian Railways in the years to come. I wish you all a very productive conference with exciting and encouraging discussions and a fruitful exchange of knowledge. Thank you and Jai Hind.
Thank you, ma'am. Thank you for the encouraging inaugural address. And with this, your best wishes are the air beneath our wings and will certainly soar higher. Thank you. And now we'll begin the formal proceedings of the conference. The first session is the keynote address, and for that, may I request Dr. S.R. Chakravarti, Professor IIT Madras, to please come on the stage and deliver the keynote address. And while we are getting prepared for that, I would request two things. We all know that we all are very busy, but may I request all of you to please put your mobiles on silent mode. And starting with me. And the second thing which I wish to mention is that the proceedings of this conference on Hyperloop are being broadcasted live on YouTube. The link is available. We will shortly share it. We have already shared in the group. Otherwise, we will share it, and the recording will be there. So, people who have your friends who have not been able to join physically here, you can please inform them that they can join vicariously. Thank you. While the switching over takes place, let me introduce our keynote address speaker. Dr. S.R. Chakravarti is Professor of Aerospace Engineering at the Indian Institute of Technology, Madras. Dr. Chakravarti works in the areas of propulsion and combustion and researches on different aspects of combustion in gas turbine and rocket engine. He wears many hats. He is the lead co-founder the E-Plane Company, a startup aiming to make hybrid aerial vehicles for vertical takeoff and landing, which can lead to air taxi operations. He is director of many companies, many startup companies. Director of Agnikul Cosmos, which is a startup to make launch vehicles to launch micro and nano satellites into space orbits. He is the director of Aerostrovilos, a startup to produce fuel-agnostic micro-gas turbines for hybrid electric trucks. Of X2 Fuels and Energy, a startup to convert any kind of waste into crude oil. Faculty mentor of the Team Avishkar Hyperloop student team at IIT Madras, and is now part of Tutor Hyperloop, a startup company to commercialize the technology. Advisor to New Trace, which aims to make green hydrogen at an affordable cost soon. He has over 80 peer-reviewed publications to his credit and presented over 200 conference papers delivered in many keynote, plenary and invited lectures in national and international universities. He has been awarded many times, the most prestigious being the Hall Prize for the Best Undergraduate in Aerospace Engineering, the Young Faculty Recognition Award by IIT Madras, the Charlie Hansi Argent Award by the High Energy Materials Society of India, and DRDO Academic Excellence Award by the Defense Research and Development Organization twice. Today, he shall be speaking to us on the introduction to Hyperloop technology. How do you do it, sir? So many hats, so many things. Thank you. Thank you, sir. Over to you.
Thank you so much, Dr. Hemant. Good morning to all of you. Very pleasant morning today at Vadodara. First of all, all, very thankful that this particular event is being organized by Nair. It's one of those things that is very much needed because we need to kickstart on the Hyperloop conversation in this country. So I'm very, very glad to be here, and thank you so much for getting me to be delivering the keynote address. So although we are actually talking about Hyperloop technologies in this talk, these technologies are actually fairly nascent as far as, of course, we are actually putting together a few different technologies from different areas, but still, as a concept, Hyperloop technologies are still actually nascent. So I will be covering quite a bit of the economics of it, why should we be doing Hyperloop, all of those things before we actually get down to technologies. Many of you will actually be familiar with a lot of these technologies, many of you are actually working on these, so this is meant to be like an overview, not exactly getting very deep into anything, just to try to keep things as simple as possible. So the thing that's been mentioned by in the introduction, it's called the fifth mode of transportation. I remember the time when, the first time we appeared on TV, I think NDTV was covering us, and my father was looking at it on TV, and he asked me the question, does it fly or does it go on land? And I didn't have an answer to the question, and the reason for that is actually the fifth mode. It doesn't get slotted into any of the other modes. So we could then call it the next big thing, because so see why that is the case. It minimizes energy losses to add drag and friction, and typically what we're looking at is capsules traveling in a vacuum tube and speeds upwards of about 1,000 km per hour. And why that is the case, we'll actually see why we need to have those kinds of speeds. This is typically speeds greater than an airplane, and with the frequency of metro trains. So this is a combination that we are talking about, which is the reason why it's actually the next big thing. And the feasibility and the scalability of the concept have been demonstrated on multiple occasions, but still at the research stage, or let's say developmental stage yet. So three important points in the watermarks of Hyperloop. 2013 is when Elon Musk released his Hyperloop Alpha white paper. 2017 is when the SpaceX Pod competition accelerated the growth of this ecosystem, large number of startups emerging out of it. And 2020 is when we had the first human test of the fully functional setup by Virgin Hyperloop 1. Just to give you an overview, there's a graph that I actually made myself. We are essentially having two axes here. One of them is to look at the wheel friction on the x-axis, which left-hand side is where we have wheel friction, and the right-hand side we have no wheel friction. On the y-axis we have air friction, going vertically up is no air friction, going vertically down is air friction. So that basically divides us into four quadrants. The first quadrant is actually where we would say no air friction, no wheel friction is what the Hyperloop is. On the third quadrant is actually where we will have the normal trains and the high-speed planes, which is suffering air friction and wheel friction. And in between, you could actually look at a maglev trains which have no air friction, but no wheel friction, but still have air friction. Of course, nobody really bothers about the fourth quadrant, which is the second one, that is having rails in a vacuum tube, because wheel friction exceeds air friction most of the time. So the first thing to tackle is the wheel friction and not the air friction. So nobody bothers about that one. So this is actually the trajectory of technology development from where we are in the left bottom to the right top. That's how we are where we are today, right? Just to give you a sense of what we could actually do in India, I think in the last 10 years, there have been several studies that have been done on what could be typical routes to consider, like a Mumbai-Pune route, or a Mumbai-Delhi, and so on. Sitting in Chennai where we are, we have always been looking at a Chennai-Bangalore route, which is actually a pretty busy route as it is, and pretty soon I think it could actually become a corridor that you could probably call as a Changalur, so that's a combined corridor. So we want to eventually look at that strip as a metro, and then look at Hyperloop as a intercity metro, as I just said. So right now, if you have to actually take about 5 to 6 hours, of course the Vande Bharat is making it like a 4.5 hours, but still counting to decrease it further to about 3.5 hours, a 350 kilometer journey. A airplane actually take about 2 hours with the security check in and out and all that stuff. Whereas we want to actually say Hyperloop should take about 30 minutes from middle of the city to middle of the city, not to an airport that's very far away. So the intercity metro that we are talking about should be sustainable. So that's another thing that we want to point out, which is there is always this mental notion that if you're actually going to get a better comfort or a higher technology, you need to pay a price for it in terms of either money or that costs you on the purse, or that actually costs the planet, right? Or both, right? Many times it's actually more expensive, and many times it's also actually not very sustainable. What we're trying to do with Hyperloop is to actually break that logjam. We basically say that we want to be able to make it faster, cheaper, and greener. So if you now look at the right-hand side, where we did some quick calculations on what could be like a 340 kilometer distance, let's say a Chennai-Bangalore corridor. So these are the numbers that you can say. You can probably look at having a pod that runs every 2.5 minutes with about 38 pods in about 18-hour trip, which is capable of a throughput of about 64,800 passengers. We looked at how many passengers typically transit between these at the upper class, which is like looking at all the flights, all the upper class trains and the Volvo buses kind of thing, and it was coming to around 32,000 in about 2019. And of course, then the COVID hit for about 2020, 2021, so the numbers shouldn't be very different as of today. So what we essentially say is it's possible for us to actually develop a system that will double this throughput by the end of this decade, and that's essentially what we want to be thinking about, and do it in a potentially carbon negative manner, because there is sufficient real estate over the Hyperloop tubes for putting solar panels that can generate enough electricity for taking care of the needs of the transportation itself. So if you want to compare this with the other modes of transport, think about it. On a weekend, actually buses cost about 1,200 rupees to take this particular corridor, and it takes about 6 or 7 hours. Trains take about the same time, with about a max cost of about 1,500 today, and flights cost about 2,000 to 3,000 rupees. And we should think about actually having Hyperloop do it in about 30 minutes at a cost of about 1,500 to 2,000, 2,500. So this is roughly what we are thinking about. High-speed rail today, I think, is costing about $27 million per kilometer, and other international Hyperloop developers are quoting about $20 to $40 million a kilometer, whereas what we think we can actually do this should be around $5 to $7 million a kilometer. So that is, and this is also borne out by what has happened with the Vande Bharat, the Train 18 development, which actually halves or roughly 1/3, makes the cost as 1/3 of what is the international cost. So it is quite possible to develop things very frugally. We've also seen that happen with ISRO, developing rockets at about very, very low cost. So that's exactly what we should be thinking about doing. Look at the energy, primarily, I think the more important thing to look at is, for Hyperloop, it's actually about a 8.3 kilowatt hour per passenger 100 kilometers, whereas it's actually about 30. So there is a factor of about approximately 4 that you will be reducing the energy consumption simply because you are reducing the wheel friction as well as the air friction. And as I pointed out, that you can eventually use the real estate that's available over the tubes for putting solar panels that can at least produce about half of the energy that would otherwise be consumed. Just a quick brief history of how we are getting over here. As we had pointed out before, but these are like more specific data points. So Virgin Hyperloop was actually formed in June 2014 as an offshoot of all these competitions that have come up. SpaceX Hyperloop competition announced in 2015, and then we have 2017 where Virgin Hyperloop actually began tests on that Hyperloop test facility. And subsequently, we have had a number of startups that have emerged from these student teams like Hard Hyperloop or Celeros, and a lot of other ones like Swissloop and Transport in Canada and so on. And that's the kind of thing that we're also beginning to see in India over here. And throughout this day, we will actually see more of that play out very nicely over here. In the next several slides, we'll actually be discussing what are the options that are available for Hyperloop to take passengers as well as freight, and that's one of those things that we wanted to bring about because very recently, I think like about 6 months ago, Virgin Hyperloop, first of all, I think very recently, last month or so, Virgin Hyperloop changed their name back to Hyperloop One because Virgin pulled out of Hyperloop, but I think for the purpose of what we're talking about, Virgin Hyperloop will stick around for some time. So the name change was much more recent, but I think earlier this year they actually pivoted from doing passenger to cargo. And by the way, they also actually slashed their staff by about half. That was actually unfortunate. But that was sort of like a belated, what should I say, realization that you probably should be thinking about freight instead of passenger first in order to actually shore up on safety standards and develop the technology with freight rather than with passengers. But in my opinion, Hyperloop is actually a lot more suited for passengers from an economic perspective when compared to freight. But we will actually look at where are the niche freight markets that we can probably target to begin with, and then progressively get to passengers. And again, what are the niche passenger markets, right? So for example, many times we think about having a passenger segment that's actually only about a 10 kilometer or 30 kilometer from like an airport to the middle of the city and so on. That's actually too short for Hyperloop when compared to, is there a problem? I'm just going to go, yeah, okay. So, yeah, that's a, so many times you're actually better off thinking about Hyperloop over a much longer distance between cities instead of actually within a city or so. And similarly, there are niche freight corridors that makes more sense with Hyperloop. So, so on the passenger side, let's actually look at the passenger side first before we actually get into the freight part. So it essentially provides a radically different travel experience. We will talk about what that experience has to be in a little while later. All right, passengers will consider it only when it's significantly faster and at the same time cheaper. Right, so that's the reason why it needs to be faster and cheaper and also greener, right, going forward. And you need to have a reliability, frequency of service. Every 2.5 minutes, you need to have a pod that is customized, as in like on demand. So since I also actually do these air taxis, we have this dream that you need to get from your home to the Hyperloop station by an air taxi within about 10 minutes from wherever you are in the city, and then get down the escalator into a platform. On either side, you have a pod that's leaving every 5 minutes from each side of the platform, but every 2.5 minutes for a passenger to get in. So it's actually on-demand transportation. You don't wait anywhere, right? Just go there, the pod is there, you just get in. Within 2 minutes, it's going to go away and go to the other side, and then you climb up the escalator, you have a taxi waiting to take you. So this is the India of tomorrow that we want to be actually thinking about, right? So that's the experience that we are looking at. So it should be a seamless ticketing, and all the interface should be done right away. Now, one of the benefits essentially brings the world a little closer by drastically reducing the travel time, right? So another kind of a dream that we can actually think about is it possible for us to actually have a Hyperloop that actually runs from, let's say, London to Jakarta through India, right? So can we actually have such a long Hyperloop tube that will connect things, because it's supposed to be faster than airplanes, right? Is it possible for us to actually do one long, landmass connection from one end to the other? So these are things that will actually probably happen through the rest of the century, perhaps, right? So it's currently the fastest mode of travel that is by air, which is pretty expensive and also not so frequent, right? So you don't really have airplanes that are taking off every 2.5 minutes to the same destination, right? So you will have busy airports that are actually having flights take off within 1 minute, right? Like I think the Bombay airport is probably the most busiest airport with a single runway, but that is still not actually taking people to the same destination. So what we're talking about eventually is connecting. So in some sense, if you think about Hyperloop, it's more like the fiber optic cable of transportation, whereas airplanes, like particularly the VTOLs that I'm talking about, are more like the mobile phone, if you want to look at the analogy there between communication and transportation. Whereas, of course, the conventional trains are more like the conventional landlines, where you need those lines. So we want to essentially have these fiber optic cables that is having pods that are running every 2.5 minutes between the same origin destination pairs. So this will actually be a huge infrastructure for Hyperloop, including tubes and Hyperloop terminals. But when you're now trying to put that infrastructure, the question that you have to ask is, what is the cost-benefit analysis, right? So if the benefits are far outweighing the extra infrastructure that you have to put in, then you want to do that rather than say it's actually very infrastructure heavy. So what are the challenges for the passenger Hyperloop? There are several tests of the Hyperloop system that have been done, even with passengers. Still, there is considerable need for research that's required to improve it and make it economically viable. The characteristic properties of Hyperloop are actually huge capital, risk profiles, and the long financing period. So this is one of those problems, right? So how we actually finance this, and what are the kind of rate of return that you're going to get out of these financing? Then safety systems in the vehicle to be provided for emergency situations. What we're basically doing is you're now having a vacuum tube that's running about the 350 kilometer. You're kind of creating a space-like ambience, right, within Earth. And that's an artificial atmosphere, or I shouldn't say atmosphere, that's the wrong word, artificial ambience that you're actually creating that doesn't suit human living, right? So then you will actually have to have vestibules that are connecting you to the stations and the pods, very similar to how the space station gets docked with rockets that are taking people and cargo. So those are all like the similarities with what we do in space technology. And in that sense, how do you deal with emergency situations, right? And for all the talk that we talk about space technology and astronauts going there, we are still talking about like a handful of astronauts who have actually been there to space, if not millions of passengers, right? So we've still not really conquered space technology to the level of confidence that's required for you to apply to a Hyperloop situation. Perhaps doing Hyperloop will actually give us more confidence to go to Mars and all those places, right? So these are cross-pollination of technologies from one realm to the other that we would like to explore in the future. So the amount of acceleration that's involved, no external views, we'll talk about those right, in the next few slides. It's not as if like these things cannot be alleviated. We can actually have spring-loaded platforms and we can have synthetic views and all the stuff that we would like to think about. Before we get back to that, which are the technological aspects, right? So let's actually quickly also look at the freight Hyperloop part of it, because there is increasing interest in thinking about Hyperloop for freight, because that's something that can allow for developing safety standards without having to put humans at risk, and at the same time see if we can generate some revenue in the process. This is essentially the purpose. So we have to actually go in search of which of the freight that will actually make sense for Hyperloop, right? In a bit more contrived manner perhaps, but let's explore this, right? And then see in the next few slides where we are. So the point essentially is that it will actually be valuable for fast transportation at cheap tariffs in the age of e-commerce, right? And I'm going to actually hold on to this e-commerce a bit for quite some slides to actually focus on where Hyperloop will actually be very, very important. So the scale of systems currently being developed cannot displace conventional modes like train. We will make these comparisons between air, train, buses, and water for freight, because freight movements are actually a lot more common in other modes of transportation that they have managed to get that going at a much cheaper rates than what you think about Hyperloop. So as research progresses, pods with high capacity will account for higher passenger and freight demands. What we really have to think about for freight is it possible for us to look at a 20 feet container or a 40 feet container with about 20 tons of cargo, right, 20 to 30 tons of cargo that can actually be pushed into a Hyperloop instead of actually having a pod with about 40 passengers, right? A 40 passenger pod takes a payload from not more than about 4,000 kgs, whereas we are talking about suddenly about 4 to 5 times, 6 times more payload is as such, and then the pod correspondingly, and so on. Just to do a quick calculation, if you now think about a 7,500 kg per pod, right, and then the haul capacity during the night time is 6 hours. So while we're getting the 6 hours, we're essentially conceptualizing if it's possible for me to actually do an 18-hour passenger transit with about 64,000 passengers throughput in an 18-hour period. Can I use the remaining 6-hour period in the same Hyperloop corridor for freight, right? Actually doing overnight freight. And we can still actually have about 1,080 tons of capacity. Just for a comparison, the railways basically does about 2,200 in the same with a medium freight train. So it's getting comparable. It's about half, right? So it's not something too bad. Question is, what are the costs we're going to pay, and are there people who are willing to pay that cost, right? That's the next question that we have to ask. So what are the benefits over here before we actually think about what are the problems, right? So the freight part actually will drastically reduce the time, and consumers want faster delivery, and businesses want a more efficient supply chain. And e-commerce is exactly what I was coming to say, and this will go on the next few slides as well to point out that e-commerce actually has this kind of a demand, and I'll show you some data there. Right, so e-commerce companies will look for growth, and the customers expect rapid deliveries. Freight Hyperloop, both parties are better off. Lower shipping costs than airplanes for sure, and it's 8x cheaper than airplanes and only 1.5x more expensive than trucks, which is reasonable. And the 1.5x is actually pretty important for the purpose of e-commerce because of the data that I'm going to show you next. Greater efficiency to the warehouses, to the faster movement of goods, and will have the businesses cut on costs. They will reduce finished good inventory, and therefore the need for bigger warehouses will actually be gone. And this is quite important because one of the things about Hyperloop is because it's actually a string of parts, it has to be automated, and that automation essentially means that there is a reliability of the supply chain. So you know that this part is actually going to arrive at this particular time. So that means you can actually plan everything around it, right? So there is a safe shipment of goods. The freight Hyperloop is susceptible to harsh weather conditions. You don't have to worry about rain or snow, and so on. Now, what are the applications of Hyperloop? E-commerce, as I was talking about, right? Can deliver the shipments quicker than freight Hyperloop and reach a larger consumer base because you can actually now start looking at perishable items like food can be transported quickly through the freight Hyperloop. So even as it is, like for example, if you're sitting in Chennai, you get the Tirunelveli halwa coming from you overnight from Tirunelveli by train. Think about a very hot Tirunelveli halwa coming in about 30 minutes from Tirunelveli to Chennai. That's the kind of thing that we should be talking about in the future. Right? So very similar, such applications. The freight part will come handy during medical emergencies like shifting patients, medical equipment, immediate life support, and resuscitation of critically ill and injured patients. Let's say, for example, there's an earthquake in a particular city, right? Is it possible for you to rush emergency supplies from another city? Quick transportation of organs and organ donors towards the recipients during emergency situations. Quick transportation of doctors from one hospital to another. Live animals can be transported when they need immediate life support, and lots of such things. So it's spare parts for aerospace industries. Right? So lots of these kind of new use cases will actually emerge for freights, which are all primarily on an emergency, safe, secure transport and dedicated. Right? So these are the three or four very key aspects of freight where you have those needs will be served by Hyperloop. Comparing this with air, truck, and so on, right? So air actually it becomes more comparable with Hyperloop. So any air transportation of cargo is something that we can actually target with Hyperloop. Truck is actually a lot more difficult to do because trucks have got it down to fairly bare bones, but still we can say that with trucks it's possible to say it's about 1.5 times more expensive. Rail is actually very, very difficult. Right? Rail freight transport is actually something that is very difficult to beat with Hyperloop. But water, yeah, I think although ships and transports that are cheap, they're very time consuming, so that's the point that we can score over. So what are the economic opportunities of Hyperloop? The e-commerce sector, as I pointed out, this is what the data is. The global same-day delivery market is actually around 4.6 billion USD and is expected to grow at about 20%. Right, in the next 5 years. And according to a study, over 75% of online shoppers desire same-day delivery, and 40% online shoppers are actually willing to pay extra for the same-day delivery. But only a little over 50% of companies offer same-day delivery due to technological difficulties. This is actually the opportunity that's available for you. If you now say the night 6 hours is going to actually allow me to give like overnight delivery from, let's say, somebody actually clicks the buy button at 10 p.m. and I actually get the stuff when they wake up at 6 a.m. Right? That's the kind of thing that we would like to see if we can do with Hyperloop. So what is the further economic opportunity over here? Can directly impact the society. I think that the second bullet is actually pretty important. From a hard Hyperloop study that actually says that if Amsterdam were connected to Groningen and The Hague in particular regions such as the Ruhr area, there would be an additional GDP of about 275 billion euros for the province. That's a growth of about 121%, right? So that this analogous situation can actually happen anywhere. And Hyperloop industry also provides huge job opportunities. The Pune-Mumbai Hyperloop could create about 1 million new jobs in the Maharashtra region. And the Pune-Mumbai project would actually reduce greenhouse gas emissions by about 150,000 tons annually. Right, so these are benefits that we can actually get out of Hyperloop. What are the challenges to freight Hyperloop? It's not as if like they don't have any challenges at all, right? Significant testing is necessary still. Limitations in size, weight, because the weight requirement suddenly balloons if you're thinking about like standard containers, right? Or at least about a 20 feet container is actually a half standard container. So that's something that we have to suddenly embrace, and that's a little bit more difficult when compared to doing passenger pods, but passengers inside actually is the more bigger challenge there. So the current developed tube diameters in the pod designs would be unable to accommodate traditional road rate and sea cargo containers, so you'll have to actually have enlarged tubes and so on, enlarged tubes. Even if you actually increase the tube size from, let's say, about 4 meters to 5 meters, you're actually increasing your cost by another 50%. That's actually not very good. So new containers would be needed, incurring additional cost, or if you're actually using new containers, then there is like a transfer from this to that, and that's going to be bad, or you have to actually be able to design your Hyperloop for existing standard containers. So, due to the lightweight design of the pods and the sensitivity in calibration for magnetic levitation, balancing the weight of any contents will also require careful loading and weight distribution. Right? So these are things that we'll have to go through. So in a current airplane, for example, if people are walking from back and forth, nothing really happens to the airplane, but that's because it's actually fairly massive. But if you had something similar happen in a Hyperloop, that's not going to be, that's going to be difficult, right? So you can't load one side and keep it vacant the other side and so on. So this is something that I wanted to highlight here. There is a significant sustainability aspect to Hyperloop. Hyperloop have actually been designed to be sustainable mode due to their zero emissions and low energy consumption. We are trying to do all these things completely electromagnetically, as opposed to having any form of chemical propulsion here. So the electricity to run the Hyperloop is proposed to be generated using solar, and solar panels can be fitted onto the Hyperloop tube and the other infrastructure. Additionally, wind energy could be used, and we can actually target something like a zero carbon footprint for the entire system. Use of such, of course, we need to have the grid integrated because solar and wind are intermittent, and we have to still have like a continuous power and so on. So that's a grid management that's required over there. But fundamentally, if you think about how much you're generating versus how much you're consuming, we can look at net zero carbon. So renewable is something that's big on for Hyperloop there. And if all passenger flights from short to mid-range distances are replaced by Hyperloop, we could actually cut back on a significant percentage of pollution. That's something that we have to keep in mind. So finally, coming down to safety and comfort. And safety and comfort are crucial factors that have had little progress as of now, and that's typically because mostly we focused on the technology first and then get to the safety and then the comfort and so on. While traveling at such high speeds, even a minor error could lead to catastrophic results, and outside pressure being well below the atmospheric pressure only adds to this concern. Here again, I think we should actually take comfort from space tech, where there is, it is again one of those things where a minor error can actually make you lose a lot of money mostly, but a little bit of risk in life. Sorry to say, but still, I think we have lost a few lives of astronauts, but most of them actually have been safer. But the overall statistics that we have is actually very, very low over there as far as human travel is concerned. That's what I was saying. But if you look at the technology as such, right? So for you to go to space, you need to not only get the exact injection velocity, but also you have to actually get it right there. So there are many times in most technologies, if you're not performing well, you actually have to pay the price in terms of a poorer performance, right? So, but in space technology, you have to actually get two things right. You have to get the speed and the location right, and that's the reason why it's what it's called as rocket science, right? And that is there, and we have done it. So if we can do it there, is it not possible to do it here? Is the question, but the stakes here are much higher. That's the thing that we will have to keep in mind. So comfort of passengers while traveling at high speeds and accelerations, especially during turns, and that's another thing. So very soon we should actually be starting to think about focusing on turns rather than just straight runs. And turns is something that's going to make it very uncomfortable for passengers. Seats of Hyperloops have been designed with maximum comfort so that the passengers are not allowed to move around and get jostled during this. So let's just come down to what has happened so far. And recently we have seen in 2020 the first human flights done by Virgin Hyperloop. It's supposed to start, Virgin Hyperloop is supposed to start its operation within this next decade, but still they have now gone back to doing cargo before we can actually get to passengers again. And the first route they have planned is about 270 miles between Los Angeles and Las Vegas. In India, they have actually been thinking about a Mumbai-Pune corridor and so on, but that's again been indoor plans. So what are the different failure modes of Hyperloop that we have to think about? And what is the thing that we have to do about this? So this will actually tell us what should be the technologies that we have to develop correspondingly. The failure of the propulsion system requires you to actually have a backup system. So in fact, my thinking, and this is something that we will also see in the next few slides, my thinking is actually we need to have three propulsions, right? So one of the propulsions should probably be a propulsion on the track, because, and I'll elaborate that a bit later, but we also need a low performance propulsion on the pod that will actually overcome a drag, the aerodynamic drag as well as the magnetic drag. But you also have to have a third level of propulsion which will get you on wheels and then go on wheels if there is an emergency. So unless you have actually about some 3 levels of redundancy in propulsion, it's going to be difficult. And the failure of levitation essentially is taken care of by the third propulsion mechanism of getting down on wheels and going forward, still to the next nearest emergency exit. Failure of brakes, and brakes is something that's something that we're worried about. You should typically need to have contactless brakes, but you also have to have a backup with contact brakes as a redundancy. Failure of vacuum, it essentially means, so many of these things actually, so if you have a propulsion failure, you have a levitation failure, you have a vacuum failure, they are not exactly catastrophic. It's just simply going to get you back to reality. We have been going around without vacuum, we have been going on wheels so far, so we kind of come back to saying, okay, this is back, we are, momentarily we are set back by about a decade, let's say. Right, that's what the situation is. It's not going to be exactly catastrophic. What's going to be catastrophic is collisions. So if you have collisions that are happening, that's what we really have to worry about, right? And of course, you also have these problems about, in case of fire, what happens, in case of natural disasters, air conditioning inside the pod, maintaining the oxygen level. Many of these things actually have been figured out in airplanes. So that's what I said, we have actually automobile, railway, aviation, and space. Like all these different areas, we have technologies that have been developed that can move into Hyperloop to synthesize all of them together. Now, this is one major concern that people actually express. If I'm going inside a tube, I have no idea where I'm going. Am I actually going to get dizzy? Am I going to have a psychological problem? And all that stuff, right? My quick question is, psychological problem for 15 minutes, it's okay. Right? So let's not just exaggerate that too much, right? But now, this is exactly where synthetic windows is very important, right? Now, what would synthetic windows actually give? Provide synthetic windows will give you this artificial feel that you're not going at very high speeds at all, right? So you actually have synthetic displays pretty much real time. So for example, the other day I was actually talking to a startup in Bangalore that is doing real-time displays of animation, right? And real time with about 11 milliseconds delay, which essentially means that if you have cameras that are on the tube that are looking at the far side, the far countryside, is it possible for you to actually relay that on the screen as if it's a synthetic window, while you get to see something that's very far, which means that it moves very slowly relative to you. You get this feel that you are going very, very slowly, right? So this is very important for you, right? I mean, you're moving very slowly, but in about 15 minutes you're in Bangalore from Chennai. I think that's an amazing experience. Good. So that takes us to what kind of startups have been around, and just have been listing about 4 or 5 over here. And what are the kind of technologies they are developing towards this? Propulsion, levitation, braking, vacuum, and we also want to actually put the funding, right? So we want to actually show that in India we can do these things very frugally. So there is leading reduction motor and electric aerodynamic is what is being done by Zeliros for propulsion. Hyperloop is doing linear electric magnetic engine. For levitation, many of them are actually doing passive magnetic versus active magnetic. And Cellulose is developing redundant braking systems, and a Virgin Hyperloop actually had a 500-meter long facility, and Hyperloop TT transportation technologies has about 320 meters is the plan, and Hard Hyperloop has about 30 meters. You look at the funding that they have, they are actually in the hundreds to tens of $million, whereas the student team that we have at the bottom, right, at IIT Madras, Avishkar Hyperloop, is actually developing some of these technologies at a lab scale, right, not at a full scale yet, and we've been doing it with very, very less money. And I'm pretty sure if there are a lot of other student teams, you're probably doing it with much less money than this even, right? So that's actually the strength of what we do in India. I'm very, very proud about that. So no marks for guessing. A lot of efforts in Europe, primarily because it is seen as like a green transportation, and Western Europe is big on green. Not as much North America, but North America is also like an advanced thing. We're not really seeing a lot happening in Asia other than in India. Right, that's something that we want to actually see is a good opportunity for us to take a lead on, right, in this part of the world. And the reason why we want to do that is if we actually do this in India, it gives us a very good opportunity for us to spread this across a large parts of Asia, in Southeast Asia, the Middle East, and so on. And increasing, so I used to think that if you now look at how many people actually trust Indian technology, it actually spans from London to Sydney with a big hole in India, because in India, Indians are the ones who actually don't trust their own technology, right? Whereas I think a lot of Europe, Australia does. Americans actually think everybody is aliens anyway, right? So we don't have to worry about that. So let's actually look at what we would say about the propulsion, right? We want to do magnetic propulsion. So the point essentially is when Elon Musk proposed the idea and ran the competition, he was actually silent in the propulsion, saying, you guys can figure out what the propulsion is. And the reason why I actually became part of Hyperloop team is the first Avishkar team was actually founded by aerospace students. And aerospace students came and said, the Germans are actually doing some compressed gas, and that's like a gas dynamic thing, and you're an aerospace professor, can you help us? And pretty soon I said, that's not the way to do it, I think we should do magnetic. Right. So I think it's important to actually embrace a magnetic propulsion electromagnetic propulsion option, as opposed to anything that is the usual, throw stuff out and then move forward kind of propulsion or anything on wheels, right? So linear induction motor on the pod, or you can have a linear synchronous motor on track and linear switched reluctance motor on track. So you now can actually think about like two levels of propulsion. This is what I was talking about a minute ago, right? On-track propulsion is something that I would personally take very seriously, because right from the time I studied my 9th standard, which is like in the early 1980s, right? We used to have the first law of motion, the second law of motion, the third law of motion, right? This first law of motion, the second law of motion that directly gets down to F equals ma. And the third law of motion is, every action has equal and opposite reaction, which you apply in some problem solving. But the first law of motion is actually a statement that we just mug up so that we can vomit it out in the exam and then get marks and go away. Right? It never really applies with the first law of motion. Right? But here is an opportunity for us to actually think about the first law in action. You give it a kick, and then you don't have any other force that is stopping it. It just keeps going on and on. Right? That's exactly what we want to see if we can make use of. And that's exactly why Hyperloop becomes extremely power saving. Right? You just do one-time operation, and then you just keep going after that. And we'll talk about how to maintain the vacuum in a cost-effective manner, all those things during the forward motion. But the fundamental idea here is you give it a kick, and then as the pod keeps moving forward, there is going to be a minor aerodynamic drag, and then there is going to be a minor magnetic drag to overcome, right? So is it possible for me to actually have like a limb on pod, which guzzles much less power, so my battery pack that's required for it? There are a lot of people actually who are also thinking about contactless power transmission, right? And now contactless power transmission is actually an amazing thing. I don't see anything wrong in doing that, right? So I personally would actually like contactless power transmission for me to take an electric plane and then get like a mid-air recharging happen and all that stuff. That's all, realm of the future. But those are all okay. But when a pod is going so fast, right? I don't know if we can actually do contactless power transmission across, right? We will have to count on batteries on board and use the batteries for very, very limited power, right? And use it for the limb to just overcome the drag, right? And levitate. And we'll talk about the levitation in a bit in the next couple of slides, right? But the point essentially is, it is important to actually have two kinds of propulsion. One that gives you the big kick that can take you several tens or hundreds of kilometers, but just to have to overcome the drag, you want to have an onboard propulsion, right? And the third propulsion that I mentioned was actually a backup when levitation fails and you get down on the ground. You want to still move the nearest emergency exit on wheels, and that's the third propulsion that you want to have. So here we actually have comparisons of these different ones on what is low on infrastructure, what is high on infrastructure, and so on. And the LSRM actually, in some sense, is actually similar to LIM in terms of the low infrastructure of construction and so on, but also actually low efficiency and all that stuff, right? So the on-track propulsion reduces the pod weight and requires only 2% of the track to be covered. So you just have like 1 kilometer or less, right? To be maybe a couple of kilometers of this track that is having this. So many times when my students come and tell me something new that they want to do, the first question that I ask is, are you putting this on the track or is it on the pod? And how much of the track is actually getting cluttered? Because anything that is actually put on the track is going to go for hundreds of kilometers, and you want to have as clean a very simple track as possible, right? So that you can keep the cost down. So always one thing that I want to emphasize with my students and entire audience is keeping the cost down is actually the biggest thing that we always have to be striving for, right? And that's what the technology is all about. So just have to have about 2% of the track covered over here, and that's what the on-track propulsion is. But the on-pod is actually a lower fixed cost, simpler system, but there are heating issues on the pod. Heating is actually a pain in Hyperloop, right? Many times you can actually count on convective cooling, but you hardly have any air that will actually help you, right? So how do you do this? Like radiation? No, right? Not much. Right? The temperature differences are actually so small, right? So I think these are problems that we'll have to really work on. So the types of propulsion, we talked about the LIM and the LSM and the LRM, who are actually doing these things and so on. While we talk about propulsion in the same breath, we need to talk about braking, right? Because, think about this. We are doing a 400-meter long tube, mainly because that will allow us to get to certain peak speeds of about 250 km per hour to 300 km per hour before we can brake within a safe distance of clearance, right? So we want to, we have 400 meters distance. I want to brake and come to a stop with around 250 meters or 300 meters. I still want to have about a 100-meter buffer so that if there is any error, I'm not going to lose my pod, right? So braking is actually super important, number one. Second, so this is going to dictate what is kind of the peak speeds you can achieve in a given length of tube. That's a key thing that we want to first of all think about from a technology development perspective. More important for the braking technology itself is the contactless braking that's required, because when you're now going at those high speeds, there is no way you're going to actually be able to hold, touch, and then stop it, right? You have to actually have contactless braking. So we've been developing things like eddy current braking for contactless, noiseless, less wear and tear, and so on. You can also actually think about regenerative braking. That's something that is being done in automobiles, and see if you can actually adopt that so that you can save further on 30% of the kinetic energy and reduce the total energy requirement further and make it more greener. Let's talk a little bit about levitation again. So there is again three options, which is electromagnetic suspension, and electrodynamic suspension, and hybrid electric. So the idea here about electromagnetic is that it can actually levitate and then it can start moving forward, whereas electrodynamic is actually repulsive, whereas electromagnetic is attractive. So you have to essentially get your attractive or repulsive forces to work in such a way that you either levitate above from a track below, or actually have suspended from the top and then levitate from the top, right? And in the case of electrodynamic, it essentially means that as you keep moving forward, you actually create a relative magnetic field, that you induce a relative magnetic field that causes this this repulsion to happen, and therefore the electrodynamic suspension depends on your movement of your pod, which is an interesting thing, right? So the hybrid EMS actually consists of both permanent and electromagnets, whereas that is not the case with the electromagnetic, right? And then the permanent magnets pulls the pod towards the track and sticks onto it, and the electromagnets produce a magnetic field that opposes the field of the permanent magnets and hence levitating off the track. So this picture actually is very good in terms of telling you what will be the power consumption with these different implementations. So the electromagnetic suspension, as I said, can actually allow you to levitate in a static manner, but as you keep on going forward and forward, the drag force, the magnetic drag that you're going to incur will actually keep increasing with the velocity. Because fundamentally it's allowing you to just levitate right there, right? But if you now keep going forward, the amount of magnetic drag that you're going to get will be more, and the power that will be required to overcome that will be more. Electrodynamic is exactly the opposite. You have an initial increase in drag at very low speeds, but as you keep going forward, the drag actually drops. The problem essentially is the electromagnetic has been tested on maglev, whereas we need to have a lot of work that is still to be done on electrodynamic suspension for any takers over here, right? And let's actually focus on the tube. And the tube is something that's actually a very big thing. It's actually the elephant in the room as far as Hyperloop is concerned, right? No other technologies require a vacuum tube to run from place to place, and that's what's going to cost about 70% of the total Hyperloop cost. So anybody who is actually trying to look at bringing down the cost of Hyperloop, levitation could be sexy, pardon that term, right? Electromagnetic propulsion and all those things could be really great. You think that you're doing a great job, you can get a beautiful pod, all of that stuff. No, you have to actually get down to the tube being extremely inexpensive, right? That's what it's all about. So in our case, for example, this is what's actually saying we will be able to do a 5 to 7 million because we just bring down the cost of the tube a lot. That's what we try to do. Now, what does the tube essentially do? The tube, you have to think about how the tube works, right? You have a certain pod and you have a certain tube. So there is a cross-section of the tube, the cross-section of the pod. And then what is the gap in between, right? So this is the annular gap in between, or let's say the blockage ratio that the pod provides. Now, what is the pod speed is going to actually tell you what will be the speed of the air that's surrounding the pod in this gap between the pod and the tube. And that is what is going to dictate what will be the aerodynamic drag, provided you have sufficient air. So, smaller the tube, greater will be the air that is going around. Therefore, you need to bring down the pressure inside that lot. Right? Now, bringing the pressure inside the lot is okay for a smaller tube, not okay for a larger tube. So you see all these things are now coupled with each other. So the question then is, what is the pressure, what is the vacuum energy, what is the aerodynamic drag loss? So this is the combination that we have to actually tackle. Am I tackling the aerodynamic drag? Am I tackling the vacuum energy? Right? These are the two things that we will have. So one goes this way, the other goes that way. So there is an optimum sweet spot pressure somewhere between 100 to 2000 pascals. In fact, it will be a little bit narrow, like about 200 to 1000 pascals is actually more like it that we will have to tackle depending upon the tube size versus the pod size. Now, we have tried multiple different material combinations of these tubes, for example, steel tubes, concrete sealants, and composite tubes. My dream has been, is it possible for us to actually have natural composites, like for example, take coir and then waste plastics and come up with, just think about it, right? So you generate so much waste plastic, now all of that waste plastic gets converted into Hyperloop tubes, you're solving two problems in one go, right? So, but I try to push that with my students, and then the students got back to me saying that that's all pipe dream. Sorry, that's fun. So we actually then went back to something that is very mundane. A steel tube essentially has this thing about what is the thickness of the tube versus how many stiffeners that you put so that the skin does not buckle, right? And buckling typically is actually the biggest mode of failure in these tubes because it's actually a compressive stress that they're going through. Concrete sealants, concrete essentially has the problem, actually it's porous, so you need to have like a liner that attacks the leaks. And composites, of course, there are multiple possibilities of CFRPs or GFRPs, and as I said, like even natural composites with coir and so on. Right. Thermal expansion in vacuum systems. So we need to have things like bellows or rubber pads that will allow for expansions of these. It's a very standard thing in railways, right? So in the railway lines, we have these gaps that will allow for these to occur. Similarly, we need to worry about this for these tubes. And but the good thing, what I feel good about Hyperloop in the Indian context is many times the Western world in the 20th century had perfected a lot of precision engineering. If you think about the high-speed rail, it's all actually about precision engineering of the rails as much as the Vande Bharat Express cannot really reach its maximum speeds because the rails actually have to be done more properly. Precision engineering is how the West has always ruled over the rest of the world, right? We need to be actually looking out for fault-tolerant technologies, right, in terms of design. And that's exactly where Hyperloop is actually very nice, right? It's okay to actually not have an exactly circular tube. It's okay to have dents on the tube here because there's no contact. Right? It's okay to actually have a aluminum rail that is a bit wavy, right? If I actually have a stable levitation system, that waviness will actually perturb the system and get it back to its original. If we're thinking about like an air gap of let's say 5 mm, this 5 mm becomes 4 mm somewhere, it's okay, right? And if it becomes 3 mm somewhere, it's okay, right? It will come back. So the contactless nature of Hyperloop allows for you to actually have imprecise rails and imprecise tubes, and that's actually the forte of Indians, right? We are all very imprecise people, and we still want to actually get our job done, if you think about it, right? And that's exactly why Hyperloop is actually such a nice Indian technology for me, right? So, again, in the case of vacuum, you would want to actually have a divide and conquer approach. There is like a one-time evacuation that we want to do where we want to spend a lot of energy on vacuum, but is it possible for you to actually have a separate set of smaller vacuum pumps that will actually just maintain the vacuum? So the flow rates are very less, the delta P is very, right, is maintained to be the same. So I can actually have maintenance vacuum pumps that are much less energy guzzling when compared to the total evacuation pumps that I will have to use only for maintenance once in a while. Let's just talk a little bit more about aerodynamics for getting into the next slide, right, for the sake of completeness. So even at around 99% vacuum, right, there is still some drag, sort of very similar to what happens in space. You go to 400 kilometers, you will still have drag, right, so it's very similar. So there is something called the Kantrovitz limit, and that essentially creates what's called as a thermal choking that occurs because of the air that gets pushed in the annular gap. And that's what we're trying to reduce over here as much as possible. So there is some numbers thrown in over there. I'll talk about a little later. Now, what can we do if we are actually not getting over here? Then this proposal here is to actually put a compressor. So you don't really have to have a total vacuum over there, but you now have a small compressor that will compress onboard the air and then push it out. And that's an onboard compressor that has actually been proposed earlier. And this will actually push the speeds up to about 1200 km per hour and avoid the choking problem and so on. So this is a step-up technology. In my opinion, we probably will have to get there only much later. We shouldn't be doing this in time soon because anything on the pod is actually more expensive, right? So we want to see if we can keep the pod as light as possible. Communications and control is again a big problem because you have these pods that are running very fast and then you have a stationary atmosphere around. So there is risk of electromagnetic interference, but none of these things is something that has not been done in other contexts like space technology and so on. Telemetry is something that people do all the time and so on. So we need to actually have a what's called a Faraday cage that will get this electromagnetic interference out and then do this communication and geolocation. Finally, I think just to stop where I think we're doing good time here, just talk about a few slides on what we are doing at IIT Madras that probably merits my position here as a keynote speaker. Right? So at IIT Madras, we are actually about to set up with significant support from the railways for setting up this Hyperloop Center of Excellence, the world's largest academic Hyperloop testing facility. Now when I say this, what we really mean is we will actually throw this open for everybody to come and test what they want to do, right? So essentially it's a technology test bed for Hyperloop. So we want to have the full stack of technologies that are developed for Hyperloop at a subscale level of 2 meter diameter over about a 400 meter length. And this, I believe, will actually be the longest such implementation anywhere in the world that is available for open to everyone else. Otherwise, all the others are actually being used by their own, for their own purposes. So if you now think about a couple of competitions that are held around the world, the SpaceX competition that happened between 2013 to 2019, that was actually a 1 mile long vacuum tube, but they shut the competition by 2019. The European Hyperloop Week that's been happening around is a 150 meter long open air I-rail track, right? That's a poor, substitute for a vacuum tube. And what we want to do is, that's actually a sitting duck for us to say, hey, we can actually do much better. We do a vacuum tube and suddenly we can actually say we are global leaders in Hyperloop. Right? What does it take? So that's exactly what we're trying to do, right? So we want to essentially win this situation that we will do this global Hyperloop competition with a 400 meter long vacuum tube with a custom track. Thankfully for us, we have a new campus in which we have a straight section of about 450 meters. So we have an operating space of about 25 meters on either side. So we target about a 400 meter long tube. And we expect to do this by next year. And from then on, we can actually say we will do the Hyperloop competition in a much better way than what Europeans are doing. So our goals for next year are to do this 400 meters, run a completely contactless pod, which essentially means that there will be levitation, there is magnetic propulsion, there is contactless braking, right? And this paves the way for a very rapid competition. We will start setting the standards, right? And of course, we will continue to participate in the European Hyperloop Week and so on. So what is the bigger vision? What is the bigger roadmap? The first phase, of course, is this 400 meter construction for 2 meter diameter. But going forward, and this can be done, this is plan to be done at the Discovery campus of IIT Madras, and this will be done by the students here. Whereas going forward, we want to see if we can get down to commercializing this, very similar to a lot of other startup companies that are beginning to do. And this is also something that we have to do with a startup company and putting the industry consortium together. And the target here is it possible for us to actually have a 4 or 5 meter tube with about typically a 10 kilometer distance. Now, you could start with like a freight as a use case, but ultimately we need to have a customer that allows us to do testing of progressively higher and higher speeds. Because freight at the most will probably require not more than about 150 kilometers per hour, right? Whereas passengers, unless we are actually going to a minimum of 600 kilometers per hour, we will not be able to overtake planes. Planes fly at even higher speeds, but they go to airports that are outside the city, and by the time you get back to your home today, it's actually a mess. So if you're able to go from middle of the city to middle of the city, right, at 600 kilometers per hour, then we have a winning proposition over planes. And for us to be able to get to that distance, that speeds, we need to have a distance of about 10 kilometers and a supporting customer base that will allow us to do freights and for revenue generation, but at the same time test for higher and higher speeds to get a passenger use case. But the phase 3 should actually be by the end of the decade, where we start looking at passenger lines of the order of about 350 kilometers in 30 minutes, kind of a implementation. And as it is, the startup at IIT Madras that is actually trying to do the second phase is trying to put together an industry consortium. And this industry has been supporting Avishkar and the sponsorships so far. So they have been asking what is it in the long run, and then this consortium is now possible to put. And then they could actually form an SPV that now does the full-scale implementation of 350 kilometer plus between cities. So just that takes us to just an announcement about the startup that we have. That's also something that we're doing at IIT Madras. All of these things are sort of like a process that we start from the student team, go to the commercialization, and then to the practical implementation. That's the reason why I have this particular slide. And thank you very much.
Thank you, sir. Thank you for a very, very enlightening keynote address. I'm sure that this has enlarged our appreciation of the Hyperloop technology and its applications. Any questions, please? Sir, would you please allow a couple of questions? Any questions, please? Yes, please.
You said that
Take the mic. Please take the mic.
good morning, sir. Sir, you said कि what 18 hours during daytime it will be passenger traffic and for 6 hours the freight traffic. Whether this system is maintenance free, whether it will require maintenance, then how it will be carried out, that you are not presented in your presentation.
Yeah, I think that what I meant was actually a concept for utilization of the same infrastructure, right, which essentially means that it's possible for you to design your infrastructure for both passenger and freight, right? So the tube should not bother about whether it's a passenger pod or a freight pod, right? Now, I'm not very sure what the maintenance requirements will be on a daily basis, right? What I expect is that there will be breakdowns, so we need to actually have compartments where we can say, I will actually seal this side, seal that side, I can evacuate this and then do my maintenance there. But the vacuum, so very important, the moment actually you get this Hyperloop tube, right, try to preserve the vacuum as much as possible, don't lose it, right? So that's the reason why when a pod comes and then it actually docks on the station, you need to have a vestibule between the station and the pod so that the rest of the vacuum is still there. You don't try to actually evacuate the tube at all, right? So the kind of maintenance that I'm envisaging is not something for the entire tube all the time, right? It should be maintenance free. Whenever there is a problem, you have to actually attend to only one particular section where you may have to evacuate that, attend to that, and then get it back up, right? This is the way I'm thinking.
And one more question, I think there will not be any junction like metro rail.
Without a visa, there are people who are actually thinking about junctions.
Junctions also are present.
That's doable.
Okay, thank you.
Thank you, sir. Ladies and gentlemen, please hold your questions. We have a plenary session wherein yes, we will allow one more.
So thank you very much for a very enlightening presentation. What I understand is that Hyperloop is essentially maglev in a tube. Maglev we've already reached speeds of close to 550 kmph and it could be even more. Now the USP of Hyperloop more than the speed is the frequency and the other associated benefits in the sense that you're going from city to city, you don't have to waste so much of time waiting and all that. So essentially speed is just one issue. Even if we are moving at 600 kmph and we are able to give all the other benefits of middle of the city to middle of city, increased frequency and all that, then we are better than trains anyway. So instead of investing so much into a vacuum technology, and you know how difficult a vacuum is to maintain, why could we simply not go for maglev?
Correct. In fact, I was going to actually interrupt your question right in the middle to point out that it's not just maglev, but maglev in a vacuum. And the vacuum makes a difference. Actually, that's exactly the point. Right? So the problem essentially with speeds is when you're now starting with even like just anything greater than 0 speed, the first thing that hits you is the wheel friction. Right? So that's the reason why the quadrants that I talked about, nobody bothers about implementing the case where you have a wheeled rail in a vacuum. Nobody does that. Right? The reason for that is the biggest problem that you have is the wheel friction. That's the reason why people actually go for implementing the maglev. Now, the moment you actually do the maglev, the wheel friction is off. You think that you can actually go at higher and higher speeds, but look at the power that you will guzzle. Right? So the question basically is, am I going to actually spend my money in overcoming the air resistance now, which is the next biggest enemy for me, or can I actually eliminate it by actually having vacuum? And that vacuum is actually a one-time cost because I'm not going to evacuate this every time. I evacuate it and then I have to actually only maintain the vacuum. Right? The maintenance of vacuum is much less expensive when compared to one-time evacuation. So all that you said plus vacuum is actually super important. That's what is going to bring down the cost. And only when I bring down the cost can I actually run pods as frequently as I am imagining. That's exactly the point. Otherwise it will be as expensive or more expensive than planes.
Thank you, sir. As I mentioned, ladies and gentlemen, please hold your questions. We will be having a plenary session and then we will be addressing all the questions. Thank you, sir. A big round of applause for Dr. Innovation has always been a hallmark of India and Indians in particular. So then, what best next but to have the research groups from our eminent educational institutes to come up and present their research work in front of you. And for this next session, I start with Avishkar Hyperloop, IIT Madras. May I invite the group from IIT Madras? Please come. The Avishkar Hyperloop group was formed in 2017 and currently has 76 members. The aim of the group is to develop indigenous Hyperloop technologies in India and be a global leader in Hyperloop segment. And today from this group we have Vibhor Jain, who is 4th year undergrad student in civil engineering and is the ex-team head of the team, currently working on the 500-meter tube project of Avishkar, as what Dr. Chakravarti had mentioned. And then we also have Shrit Suresh, who is a 3rd year undergrad student in mechanical engineering and is current team head of the Avishkar group. Let's hear it for Avishkar Group team.
Hello. Hello. Yeah. Good morning. My name is Shrit Suresh, and we alongside Vadodara are here representing Avishkar Hyperloop, and we'll be talking about our work, progress, and plans for Hyperloop in India and Hyperloop technologies today. So Avishkar as a team is a student team, completely functioned by students, and started out in 2017. And we are currently 76 members strong. And we are not constrained to only a single discipline, engineering discipline, and we are very interdisciplinary. And are also not confined to just BTech students. In fact, we have many MTech, PhD, and MS students too. And the team started out in 2017 and initially competed in the 2019 SpaceX Hyperloop pod competition in California, in which we clocked in the top 10 out of 1,600 plus teams, and gave us an opportunity to interact with Mr. Elon Musk. And moving forth, we had various other designs and had made many pods throughout the years. And about 2 years ago, also started out with the tube aspect of Hyperloop, which we hadn't focused before that, and had made various designs and testing and validation of data for it. And it is acknowledging that the Indian Railway Minister had granted us funds of about 8.34 crores to enable us to build a 400-meter long vacuum tube at the IIT Madras Discovery Campus. So now, Avishkar Hyperloop from the start has always focused on building scalable Hyperloop technologies. And it was this pod, which was built in 2021, which we proudly have named Garu, that made a huge stride towards that goal. So it had contactless propulsion, contactless braking, semi-active suspension, in which you could change the viscosity of as per you change the current, and then you also had an in-house built inverter. And after this, we have our most latest pod, which is named Pod 5.0. So this Pod 5.0 was designed by keeping in mind the concept of levitation. So to accommodate levitation, we also changed our track. That is, we walked away from the usual I track which people use, and we designed a custom track and built such a track to test our pod eventually. And for levitation, we are using something called we are using the concept of electromagnetic suspension, and which will be explained in a short while. And then this pod too is equipped with contactless braking, contactless propulsion, and in fact it also has an in-house made battery which is capable of giving a discharge current of about 400 amperes. So moving on, this is our entire layout of the pod, and as you can see, there is the chassis. We have an in-house built primary battery pack, we have an inverter, and DC-DC choppers for levitation, our EMS coils, and our linear induction motors. So as I said, we walked away from the usual I-track and had built and had done a custom-made design for custom-made design track, and this track has a central aluminium T-beam which is for supporting our propulsion and braking mechanism, that is our linear induction motor and our eddy current braking, and has peripheral F-beams which has ferromagnetic material which will interact with the levitation coils to achieve levitation. So now going one by one through all our subsystems. So first up we have a propulsion module. So for propulsion we use something called the double-sided linear induction motor. So our linear induction motor is a rotary induction motor which you cut radially and stretch it out. So it too uses triple phase current and is a self-starting motor. And our motor has distributed windings in them. And in fact, to support our linear induction motor, we have built the in-house made primary battery pack and an in-house built inverter to provide triple phase AC for our linear induction motor. So next up we have braking. So for brake, we never want any type of contact between our track and our pod, and the entire thing of Hyperloop is to be completely contactless. So we should be having contactless propulsion, contactless braking, and to levitation. For contactless braking, we have used something called the eddy current braking, in which we used permanent N52 grade neodymium magnets arranged in a hallback fashion. Now we do this hallback fashion so that it doubles the magnetic field on one side and nullifies it in the other side. And so when actuated, the magnetic field of these magnets interact with the central aluminium T-beam which we spoke about in the track, and that eventually creates a drag force stopping our pod. So and other than this primary braking mechanism, we have also moved into and trying to implement something called regenerative braking. Regenerative braking can be achieved with our linear induction motor. When you obtain negative slip values for the linear induction motor, you can get back the energy and store it somewhere and use it for some other use in the pod itself. And these both mechanisms, that is a propulsion mechanism, linear induction motor, and a braking mechanism of eddy current braking, can be tested with this disc test setup. So this disc test setup, as you see in our track, we have an aluminium T-beam which interacts with the propulsion and braking modules. So similarly, this disc is also made of aluminium, and this interacts with the linear induction motor and gets propulsive forces which makes it rotate. And the RPM of this wheel gives us a good idea of the power output of the linear induction motor. At the same time, you can also equip this setup with our eddy current braking and check the amount of opposing force the braking systems can provide. And next up, the flagship subsystem of our team is levitation. So for levitation, we are using a concept called electromagnetic suspension, in which we produce a DC current to a coil, which interacts with a ferromagnetic material and generates attraction force, which enables levitation. So to test this levitation system which we have made, we have built something called, we have right now built something called a 1 degree of freedom levitation test setup to test levitation in a single degree of freedom, and it is only in the last week that we were able to achieve levitation in this setup. Thank you. And next up is the embedded systems. Now, embedded systems' main job is to synchronize all the subsystems and establish a communication between the running pod and the base station live, and is to send data acquired from the sensors and other parameters like BMS data. So next up is a high power system. So this is the subsystem which powers literally everything in our pod. So our high power subsystem has basically 4 equipment. So one is the primary battery pack, the secondary battery pack, the inverter, and the DC-DC converter. Our primary battery pack is, and all 4 of these are completely in-house built. In fact, the primary battery pack is about 300 volts and is able to give a discharge current of about a peak 400 amperes, and it is completely in-house built, made from about 350 lithium-ion cells. And the secondary battery pack is a much smaller battery pack for powering much smaller things like our PCBs, our sensors, and our actuation system for braking. And then moving on, we also have an inverter. Our inverter is to convert the DC current from the primary battery pack into triple phase AC for our propulsion module, and we also have our DC-DC choppers which are used to give varying DC for our levitation module. The levitation module will use active control so that it can vary the forces based on the distance between the coils and interact. So we will always need to control the current sent to it. So this is taken up by the DC-DC chopper. So next up we have the chassis subsystem. Now for building the chassis, we had been through multiple iterations. We had done material research, space optimization, and had run many simulations before we reached our final iteration. In fact, our first iteration was about 140 kilograms, and then as we did multiple iterations, we ended up on about 45 kilograms. And next up, we have aerodynamic subsystem, which will be taken up by Vivo. And
yeah, thank you, Shil, and good morning, everyone. So, just wanted to highlight one of the things in the chassis subsystem. As you can see on the right side, we have a aligned molder with a variable air gap. This variable air gap is basically to adjust the variability in the track. So, coming on to aerodynamics, we have been working on the full-scale aerodynamics part, in which, as Professor Satya explained about the blockage ratio and the Kantrowitz limits. And we are actually trying to test what the simulation results match with the actual reality. So here is a wind tunnel test which we conducted with a 10 centimeter diacrylic tube inside a wind tunnel. And we had these pressure sensors protruding out of the pod, which actually proved our simulations to be accurate. Moving on to the most important subsystem in terms of the costing. So infrastructure is something which we started working on about 2 years ago, and this is a major cost taking subsystem. So, like one of the designs which we finalized after working for 1 year is a steel tube which is in a shape of a fuselage structure from airplane. And in this design, we have completely decoupled two major loads, which are the vacuum loads and the pod loads. So this is first initial prototype of 3.6 meter and 1 meter diameter tube, which was just of thickness 2 mm. And we have tested this prototype out at approximately 100 Pascal initial pressure. And the leakage rate we obtained were absolutely phenomenal with 1300 Pascal per hour leakage rate. And so the reason behind manufacturing such a prototype was to establish a manufacturing process, assembly, and various other testing procedures. To validate the design which we have filed patent for, we actually tested this prototype and got deformation from LVDT sensors. So we actually did 3 types of tests. One is the LVDT deformation test, other one is the strain gauge test, and the third one is the vacuum test. So to validate that, we have been doing non-linear buckling finite element analysis. So one of the major important aspects while buckling of a tube is the circularity or the ovality issues of the tube. And we have developed this LiDAR testing setup to measure the circularity of the tube. Because as the tube is in vacuum, the most important failure is buckling. And a tiny bit of manufacturing defect might lead to a catastrophic failure. So, to test out our methodology of manufacturing a tube, like the simulation results and all the things, we have also manufactured a 1.6 meter and 0.6 meter dia tube, which we stated a pressure for buckling. So, we have buckled this tube inside our campus at 39.28 kilopascal. The simulation result shows that the tube might buckle at 42 kilopascal, and we have been getting quite good results. As you could see, the lobes on the right hand side are actually matching with the simulation results. So based on these standards and carefully optimizing the standards to a specific factor of safety, we are going to manufacture 2 to 3 more prototypes as listed below and test our final simulations before going ahead with the 400 meter project. So apart from the tube, we're moving on to the track standards. from the initial days when the SpaceX Hyperloop pod competition started, the standard for Hyperloop track has always been an I-rail. In the SpaceX competition, the I-rail was added along with a sub-track for levitation on the below portion. And the ESW track, that is the European Hyperloop Week track, is also an ID. So what we want to do is to develop a consensus on Hyperloop track standards by consulting various other teams and industry experts, also learning from high-speed rail and mango. So currently what we have developed, as Shrid mentioned, we have customized our track based on our requirements, which supports electromagnetic suspension, linear induction motor and eddy current braking mechanisms. So on the right and left side of the track, you could see these F-shaped sections, which are basically to support electromagnetic suspension. The F shape is to reduce the drag even more instead of a flat beam. And in between the F shape and the flat beam, we have a stainless steel section, which over here, which actually reduces the transmission of flux, magnetic flux from the F track to the other beam. So we have tested this track inside our campus, and we have also designed this track for a load of 2000 kg, which is basically for our future references. So these are just some of the videos of a pod run on a custom built track. So we have achieved a speed of 6 meters per second on this 20 meter track. We have a 30 meter track, but we are actually using 20 meter track for safety purposes. So milestone ahead. On the tube, we have already cleared the land which we have been provided, and we are ready with the construction. We are starting the construction as soon as possible for the 400 meter tube, which is 2 meter in dia in the Discovery campus. This will be an open Hyperloop testing facility, which will be open for any team or any startup whomsoever. And we are also planning to host a global Hyperloop competition in the coming year. So we have been receiving support from Indian Railways and other pod sponsors as tube sponsors like Bharat Benz, Hexaware, ANSYS, L&T Technology Services and Tube Investments India. Yes, thank you so much for your time.
Thank you, Hugo, and thank you, Suresh. Ladies and gentlemen, we'll now break for coffee, and on the other side of the break, we'll be continuing the session with the presentation from Vegapod Hyperloop team, which is from MIT Burnt Peace University, Pune. Thank you. We will meet back at 11:30. I would request the Vegapod Hyperloop team to please be ready with their presentation.
Yeah, that's why we started a different subject.
So it's possible that the students will be interested in doing I want to see some of the things that I cannot actually impress upon the students. So I feel, well, I'm only an advisor. Advice comes for free. Many times answers. So
Let's discuss on topic.
for example, the work on the cube is actually what I am. Unfortunately, when I'm doing it,
Yeah, you please do it right now because after that your turn is on third. First one. Acha, you are being better, but then please load it now. Yes, immediately.
इंटरनेट है ही आप अब लॉगिन करके लेकिन सेव पहले से मीन्स लॉगिन करके ही रहे टाइम वेस्ट पानी 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 निकला भाई I will check time box गूगल पे भी चले पैसा भरवाना अरे पानी के लिए राकेश आ गया बोले नहीं है क्या 700 बॉटल मंगवाई ना भाई 700 तो कल कितनी आई 5 पेटी दी बस ये बिजनेस को पकड़ो भाई जाते जाते करके जाए इतनी पेटी थोड़ी होता है सब नहीं है यार पानी ये आपका तकलीफ हो रही है बिजनेस में ये पीछे है आपका बिजनेस में नवा वाला एडमिशन में कीजू भी भाई सब हाँ ये इनके इसमें रख देना पड़ेगा। इसमें तो खाया अरे इतना तो है नहीं, अरे इतना जब तक खत्म नहीं होता है ना, सुन तो मैंने खाया नहीं ना, आधी बॉटल है तो आधी बॉटल बाद में रखना चाहिए ना। चार लग जाए वजन ये 6 મૂકી દે ને પછી આપણે જઈ એક બી ના હોય તો મગજ વાંચતો તો મૂકી આ 3 નું બસ નાના મૂકી જે તો 4 લાગે ને તો 4 તારી જેટલી છે એટલી પાછળ લીધા પાછળ છે ઓય આને પર એક મૂકી દેજો આને પર એક બી નહીં તો અંદર તો ખાલી છે हो गया रोगिन आपका लिंकी टाइप शूट करना ठीक है कैसा लगा रेलवे का सिस्टम अच्छा लगा बहुत एडवांस है सिस्टमैटिक सब कुछ सिस्टमैटिक है ना यस इसको सेव कर बराबर खाई છે ને ઓ લાગી રહ્યું ઓ લાગે ખાય ને કઈ ગયો પણ ઓલો કેન્ટીન દે નલ્લા ચલો ભાઈ હળો લા નલ્લા જોડી બોડી બરાબર हमारा घर ये ले गया तो देखो नहीं अरे आस्थाना तेरा प्रोजेक्ट ठीक है केवल के वेरी गुड है और एक वखत रिस्टार्ट करવાની ચાલ આવો કેટલા બાકી રહ્યા રિચાર્જમાં નહીં 405 નહીં કરતા 405 ની જગ્યા છે ને બીજું કરવાનું છે 405 રહેવાનું હા એ નહીં થાય એટલે લોગિન જ નહીં પડ્યું એ તો એની જગ્યાએ છે ને 409 નું મૂકેલું છે પછી હમણાં રહેવા એ 12 સાલ પછી જોઈશું सही है ना आज तक के पैसे नहीं लिया आज 405 में से कर लिया पैसे नहीं भाई साने ઊંધું कर दे हां अब बे बाकी ने नाश्ता देखो वो लोग आ जाएंगे फिर हम लोग नाश्ता करेंगे यहाँ पे भाई आणि खाली आम ઊભું કરી દે ને એટલે તું કેબલ નહીં ખેંચાય. ના ના બરોબર કોમ્પ્લેક્સ છે નહીં ખેંચાય નહીં ખેંચાય એમ કરવામાં છે ને બેટરીને માર પડે ગ્લાસ નો ચોકલેટ તો ખાઈ લે કે એનાથી દે બસ 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 ખેંચાય છે અને એકા ચોકલેટ આપશું કરા માર કરે બેઠો છે જોજો એ ભાવેશ તું ભાવેશ तू जा रहा मेरे को तो सामने बोला कि वहाँ देख के आ रहा मैं तो गया फिर आके तारा एक चॉकलेट मैं कहता तू आओ तो नहीं हो कहना आया
इधर ये स्कैन ये भी रख रखा है बार कोड किसी को पैसा जमा करना हो
नहीं वो लेने के लिए कि देने के लिए
लेने के लिए
क्या लेने के लिए
वो उसमें मदद करो उनकी टेक्नोलॉजी में
अच्छा नहीं करनी है बंद सुनो तुम इधर खबर पड़ी है इधर सिस्टम सुनो ना और नवी ट्रेन की टेक्नोलॉजी का खबर है बुलेट करना बनना होगी ट्यूब में अंदर एलन मस्त है हां समझ ये चीज क्या बोल रहा है हम रेलवे वाले के अपने को नॉलेज में इनको नॉलेज है आईना के अब वो जो पीछे अपने रेलवे वाला है अपना काम अलग है सनसेट कॉफी क्या तुमको भी नॉलेज नहीं है खाली यार इस बार चॉकलेट का वो कागज को आप कर दिया टूट नहीं रहा आ दो डायरेक्टली मैंने मेरा व्हाट्सएप लॉगिन करके लिंक किया आ दे ओए आम नहीं तो मैं आऊं हेलो टॉयलेट पे सांगे आ दे ती बार माइक चेंज हुआ ना यार याद है कि कोई आप मामला में करू तो कर ले याद પછી મેં આવો એટલે લઈ કરી ગયો प्रेजेंटेशन हुआ इनका ऑनलाइन है सर यानी ड्राइव में से
अच्छा ड्राइव से चलेगा
वो ड्राइव से
क्यों फिर ऐसा दिक्कत करेगा
एक्चुअली वीडियो है तो वो पीपीटी फॉर्मेट में वीडियो नहीं आ रहा
अच्छा ठीक है
वो साउंड भी है इसमें आपका
नहीं साउंड इट्स ओके सर साउंड करेक्टली वाला चलेगा
अच्छा ठीक है देन प्लीज लिमिट योरसेल्फ टू 20 minutes
Sir, including question and answers or
there are no questions and answers will be in the plenary
okay, sir.
ठीक है
हमारा क्वेश्चन आंसर नहीं है बस
अब नहीं अब हम
वो लास्ट वाला सेशन
क्योंकि वो टाइम क्वेश्चन की वजह से दिक्कत हो जाती है अच्छा दूसरा मैं क्या बोल रहा था हाँ ये क्या
ओके कॉलर माइक दे देंगे
तो विल गिव यू कॉलर माइक विल दैट बी
या तो हैंड माइक बदल देंगे
हां कॉलर माइक अभी दे दो यू कैन पुट इट ऑन बट somebody else will also be able to do it. So Abhishek can do it from there and you can do it so ये
मैं कॉलर माइक
नहीं हैंड माइक
दे देंगे
because anyway navigation slide navigation पर Abhishek will do
वैसे भी वो तो है नहीं क्वेश्चन आंसर तो है नहीं सर माइक
हाँ
डन यस लेट मी खाने में बोलते
टेक्नोलॉजी कॉस्ट इफेक्टिवली कैसे बोल सकता हूँ उसको is not the only challenge of Hyperloop, but building it cost effectively is the challenge. So we at Hyperloop aim to build our system as cost effective as possible.
उनको भी ट्रिपल कोड करना पड़ेगा फिजिबिलिटी स्टडी में मतलब
जी डबल कोड नहीं करते
तो एक ही बात
फिजिबिलिटी स्टडी अपनी डिटेल वो चीज मेक इट पब्लिक
ठीक है तो तू कर मैं नहीं
just working on
अंदर चला ये रहा माइक माइक ये रखा है पॉडियम पर सिर्फ बात होता है इससे आ रहा तो इधर में क्या है नंबर लंच में जो है अभी उस पे अरे तरुण पोडियम पोडियम को दिखूंगा बस थोड़ा नीचे बस
All from Avishkar. Delhi. You are all students.
अब कब हो जाएगा तो कहीं मत करोगे
Which stream? It is electrical and mechanical sort of.
ખબર પડી હા અવાજ ઓછો હોય તો બી ખબર પડી જાય એમ નીચું કાન તો થોડો અવાજ ઓછો બરાબર ને હા
माइक लेके वो साइड खड़ा रह सकता है ये साइड से पोडियम से बोलूँगा तो माइक से होता है ट्रांजिशन पे हाँ मैं पोडियम से बोलूँगा अच्छा दे रहे क्या को ऊपर बोल रहे हो क्या संचित बोल रहे हो नहीं लगने वाला सर ये संभाल सॉरी सॉरी
हेलो हेलो
Please settle down. We are about to start. So before going for the coffee break, we were actually listening to the research in India on Hyperloop systems, and we had the Avishkar Hyperloop group from the IIT Madras presenting. Ladies and gentlemen, you are in the conference on Hyperloop transport systems, an Indian perspective in the National Academy of Indian Railways, and this is Sardar Patel Sabhagrah. Next, I would like to invite the young and bright engineers from Vadodara Hyperloop team, MIT World Peace University, Pune. Please come. The group was formed in 2018 and currently has 40 members. The aim of the group is to make Hyperloop a reality in India. So today, from the Vadodara Hyperloop team, we have Purnesh, who is a third year student of Robotics and Automation Engineering, and who is the current captain of the team Vadodara Hyperloop. He joined team Vadodara Hyperloop in 2021 as a braking engineer and was the braking lead for the team at the European Hyperloop Week. And with him we have Sanchit, a third year student of Mechanical Engineering, who is the current vice captain of the team Vadodara Hyperloop. He joined team Vadodara Hyperloop in 2021, same as Purnesh, as a stability engineer and was the stability lead for the team at the European Hyperloop Week. So over to you, Purnesh and Sanchit. Thank you.
Thank you very much, sir. Hello and a very good morning to everybody present here. We are Team Vadodara Hyperloop, the official Hyperloop team of MIT College, Pune. So MIT College was Vegapod was established in 2018 and currently we are having 40 members from diverse departments of engineering, right from mechanical to electrical to electronics, which help and who work together on a common goal to make Hyperloop a reality in India. Talking about the team, currently we have 8 technical departments in our team, from infrastructure to structures that consist of the chassis and the aeroshell, stability, braking, electronics, propulsion, power system and levitation. The following technical departments which I will be explaining later in this presentation. Our business team consists of finance, logistics, sponsorships and partnerships, events and social media and marketing team comprising of designing, media production and content writing. Jumping right onto the topic, our current endeavors which we are working are designing and simulating a new sub-scalable pod for the upcoming competition at EHW 2023, working on contactless stability systems, going contactless braking using eddy current braking system, researching and improvising our new LIM, that is the linear induction motor, working on environmental friendly materials and trying to implement those materials in our upcoming pods to make it more eco-friendly and a sustainable pod, working on feasibility studies and working on reports that propose major cities, Hyperloop routes and corridors.
Thank you, Purnesh. Now, since the inception of the team in 2018, we have a list of achievements that we are proud of and would like to tell you all. So the first one is our first prototype named as Bose, which we manufactured in the year 2020 and 2021, between the year 2020 and 2021. So in the coming slides, I shall explain about this pod. And apart from that, while simultaneously making it, we also made the first permanent track in India, a 50-meter permanent I-beam track for testing Hyperloop prototypes on a college campus itself. The next is, we also took part in the European Hyperloop Week 2021 edition held in Spain, Valencia, Spain. There we presented our commercial feasibility report and we were amongst the top 5 teams to get shortlisted and also got great reviews from experts appreciating the amount of research and hard work we have put in. The next one is, we also advanced through the SpaceX competition which was held in Hawthorne, California in the 2019 edition. However, we advanced to the pre-finale round. However, we could not go there due to some circumstances. And the next one is manufacturing a linear induction motor. So, Hyperloop is based on certain principles like levitation, contactless propulsion, vacuum technology. So, making such a linear induction motor was one of the major aims that we had in mind, and accomplishing it in 2019 was certainly not less than a dream come true for us. So, we manufactured the linear induction motor in-house itself, like cutting the silicon sheets, stacking them with epoxy, using copper wirings to wind them around the core, and then testing it itself. Everything was done in the college itself by our students. And finally is the selection in 2 competitions known as Canadian Hyperloop Conference in 2022 and the European Hyperloop Week also in 2022. So in the Canadian Hyperloop Conference, we were also called as keynote speakers. This is the European Hyperloop competition which was held in Delft, Netherlands. Talking about this competition, I would like to tell you all something, because as in this competition we went with the mindset that we want to be competitive with others and we want to stand among themselves, amongst others. However, we came to know that every team, although they came with a competitive approach, more than that, they had a collaborative approach towards the Hyperloop technology. So together we could foster the development of such a technology in entire world and bring the world more closer. We not only participated in the demonstrations, here you can see our pod, then we also participated in round table conferences, panel discussions, and also there was a flea market where each of the teams from all around the world, US, UK, from India, Avishkar and us, we both teams represented India at the national level for this competition. So we participated in fairs on the last day of the competition, and overall it was a much engaging atmosphere. Now talking about some of the media coverages that we have received, these are this year's media coverage. Before going to the EHW, we were mentioned by Indian Express twice, and also a leading regional newspaper known as Sakar in Pune. And there they mentioned us that Megapod is representing India, which was a very proud moment for us for the time being. Next is the, as I mentioned in one of the earlier slides, about our first prototype that we built during the course of the year 2020 and 2021. So this is the one, Bose, as its name, inspired by the great scientist J.C. Bose. So here in this prototype, we wanted to demonstrate all the basic technical aspects of a Hyperloop that can be integrated into a small prototype and that can be tested. Because of Bose, we got a direction to work in the Hyperloop technology, and each of us got filled with a passion to work in the Hyperloop space. So here, I would like to explain the departments in the next slide. So as I said, this was a first prototype. It composed of a carbon fiber chassis and a carbon fiber aeroshell. Also, apart from that, we had friction braking using pneumatics, spring BLDC integrated spring suspension, a lateral suspension, as well as we could cruise up to a top speed of 108 kilometers per hour using this prototype. And also the most important thing is we had wireless communication through which we could control a pod while sitting in a radius of 2 kilometers. So this is the pod run.
Next we have Vikram. Vikram was a second generation pod. This was made with 3 aims in mind. First is being cost effective. As Professor S.R. Chakravarti stated in his earlier presentation, that developing a technology is a key aspect, but making it cost effective is equally important, and we are with the same opinion and we are focused on that as well. Our second goal was safety, and third one was building a contactless propulsion system. Talking about the departments more specifically, so structures which consisted of aeroshell and chassis. So our chassis was made up of carbon fiber composite chassis. So basically it was a sandwich of 8 carbon fiber layers at 0.45 orientation, and after that there was an aluminum honeycomb core. After that, on top of that, there was another set of carbon fiber which made it a very rigid structure. I am very proud to tell you that we manufactured this totally in-house, which made it under 85,000 rupees. So that is a very huge deal. Next is the aeroshell. Aeroshell was made by keeping a streamlined design in mind, and such that there is a complete covering through the body, and the pod is safe under any circumstances. These are some quick pictures where it is shown that we have made our chassis all in-house and our aeroshell to reduce the cost. Next is the braking. This system consisted of 4 pneumatic actuators, which could give a force of 296 Newton per actuators. These were controlled through proportional directional control valves and could give up to a deceleration of 5.4 meters per second and could bring a pod from 75 kilometers per hour to 0 kilometers per hour in just 35 meters. Next is the stability. On the left side of the screen you can see a front suspension system that was using a bell crank and a damper system which could absorb the shocks easily. And on the right hand side we can see that there was a novel tension spring design for our lateral stability. Our electronics was based on a delocalized architecture with a central master VCU, and which was connected to normal VCUs through CAN protocols in a star topology, so such that even one VCU fails, the system won't come to a stop. Due to the lack of time, I am just going fast. Propulsion. So propulsion, as Sanchit earlier mentioned, the importance of a contactless propulsion system. We manufactured our own propulsion, our own LIM in-house, which made it cost effective, as well as we could test successfully our LIM and match our simulation results accordingly. Power systems. Our power systems consisted of two packs. That was, one was high power systems that could power the linear induction motors with 250 volts of capacity, which was consisting of 10 battery packs of 25.2 volts lithium polymer batteries. We also added a switchgear to this system, which could provide us protection with all the major electrical problems that could be caused, consisting of IMDs, contactors, MSDs, relays, fuses, etc.
Now talking about something that we have been working for quite some while in 2022. So this is a commercial feasibility study that we have done in Megapod Hyperloop in the year 2022, and we shall make it public soon. So talking about why Mumbai-Pune. So Mumbai-Pune is one of the most advanced economic corridors of our country. The amount of traffic that goes daily is around 3 to 3.5 lakhs, and the amount of cargo is also about 18,000 tons per day. So also many of our railway dignitaries would know that booking a Deccan Queen or a Pragati Express ticket is so hard nowadays. So that's why I think that building a Hyperloop in such a region with either being cargo or freight is something which is the need of the hour, and that's why we did a feasibility study. Just to give some hints from it, I would like to say that the cost per passenger per kilometer of a railway is 5 rupees, whereas for a Hyperloop it's only 1.4 rupees. So that's a major advantage also. Although the initial investment is quite high, I think that the return on investment would be very high on such a project, and once the report comes out, we would like to, for feedback options, we would like feedback also, and we would like to help railways also and bring their expertise also in making Hyperloop in this region a reality. So I thank you, Professor. And now planning something for the big. So our future plans, as I would like to mention, is first a fully contactless pod. So as Purnesh mentioned, we are trying for contactless lateral stability. But apart from that, making it completely contactless is something which Hyperloop is based on. So magnetic levitation would be something that is on our bucket list, and we would like to work out on it. Second thing is the scalability of our pods. Although the pods are made using a view that they should participate in student competitions only, but after a certain point of time, we need to go into the feasibility aspect and sustainability and scalability aspect also. And the other two things that one thing that no one has explored from any team around the world is use of renewable energy resources to power either the propulsion systems or to power the electronics or auxiliary devices. So this is something that we are thinking of, and we surely will have in the coming future. And last but not the least, the vacuum technology, which we all have heard from now. It is something which distinguishes Hyperloop from a maglev. So we have started working on making concrete tubes, iterating different column designs, pillar designs, and which one would be the most effective and most feasible one would be considered by us for building and for our further prototypes. Next is the last, I would say that the sponsors. We consider them as our extended family, as because of them we could not reach where we are. So let it be technical support or monetary support or even guiding us at some critical stages, helping in logistics, bringing our pod from Netherlands or Canada, be it anywhere. Because without the support of these sponsors, we would not have reached where we are. Concludingly, I would like to thank Professor Dr. Hemant Kagra and all the railway dignitaries here for organizing such a wonderful conference. And I thank each one of you all for lending such a patient here. Thank you.
Thank you, Sachin, and thank you, Purnesh. Please take your seats. A big round of applause, ladies and gentlemen, for Vadodara Hyperloop. Moving north, we have now the energetic group from Delhi, IIT Delhi, Infinity Hyperloop. May I request the presenters, Abhishek and Aditi, to please come on the stage. Infinity Hyperloop, the group for Hyperloop research in IIT Delhi was formed in 2021 and currently has 25 members. The aim of the group is to empower this world with another mode of transportation technology, and hence they intend to develop an autonomous, scalable pod and develop new technologies to facilitate the commercialization of the Hyperloop system. Quite a noble thought. And today we have Mr. Abhishek Kumar, who is a fourth year undergrad student in electrical engineering and is the team head. And with him is Aditi Samdarshini, who is again a fourth year undergrad student in mechanical engineering and is also the team head. Over to you, Abhishek and Aditi.
Thank you so much, sir. So, good morning everyone. So, first of all, I would like to thank Nayar for inviting us to such a wonderful conference and letting us present our ideas in front of such an intellectual audience. So thank you so much for having us over here. So I'll quickly introduce myself. I am Aditi Samdarshini, and today to represent Infinity Hyperloop, I am here along with Abhishek Kumar and Ashish Kumar Meena. So last year I and Abhishek founded this team, and currently we are heading this team, and Ashish is head of propulsion department. So moving on to the next slide. So as I said that we started this team last year in November 2021. So we have recently completed our 1 year, and basically this makes our team youngest team in the country. But despite being the youngest team in just 1 year, by sheer hard work and continuous work, we are at this stage. And so like first of all, I would like to tell about the competitions. Like in just 1 year we are able to complete the design, and in January we will be shifting to the manufacturing phase. So as we started, there was a lot of challenges, since in November we started and in January 2021 third wave of COVID came and we had to shift in on the hybrid mode basically. And another challenge was to convince the deans and director that this idea will work, though it costs too much. And IT Delhi is again facing a different constraint, that is the space constraint, and Hyperloop takes a lot of space. So it was quite a big challenge for us to establish the team, and along with that we had to continuously work on the technical part. So in this 1 year, our focus was to basically keep establishing the team, and we just wanted that the technical part should not stop. And for this, we needed a team. So the biggest challenge was to get a team of people who are equally enthusiastic about the subject as us. Basically, it should not be just our dream to make this pod or to bring Hyperloop technology in India at the commercial level. So we were able to get 25 enthusiastic engineers who were equally passionate for the ideas, and through all this finally we are here at this stage that we have completed the design and will be soon shifting to the manufacturing phase. So yes, so the most important thing when we establish a club or a team or anything, the most important three things are vision, mission and values. So we started this club with a vision to basically revolutionize the transportation system of India. And along with that, Hyperloop is such a major technology, and it consists of so much of research work that this, if young engineers of India will work on this subject, they will ultimately develop the hands-on experience that an engineer has to have. So that was the vision, to basically get the best engineers out of the best institutes of India. And finally, our mission was to develop an autonomous scalable pod. Basically, obviously the first target is the competitions, but what our teams believe is that we don't want to focus just on the competition. As many things are just standardized in the competition, as Avishkar said, that at IV. It is not that in the commercial level we will use that I-beam track only. So we have to think beyond the competition, and for that basically we are focusing on the commercial level, and our team is working on two verticals. One is to develop the pod for the competition, and the second is to run research projects side by side which will focus on the commercial level problems and solve the commercial level issues. So this is our mission basically, from the competitions to go up to the commercial level and develop the subsystems which are scalable up to the commercial level. Now coming to the values, so these are basically the values: diligence, discipline, hard work and learning, due to which we were able to cover all this tough journey in 1 year. And yes, so these are the values of our club.
So yes, moving towards the department, we have divided our team into the two major verticals, which is business and technical. In business, we have the major pillars such as publicity, event and sponsorship, and many more. So in events, we managed to have webinars, seminars to spread the awareness of Hyperloop in India along with in the world. So in technical, we have divided it into two major pillars, which is mechanical and electrical. So there are the 7 departments in our technical team. So one is propulsion, in which we aim to design and manufacture the linear induction motor, and right now we are at the manufacturing phase of it. In navigation and control, we are integrating the IMU sensor along with the wireless communication. In power system, we are aiming to develop a 400 volt DC with a discharge current of 200 ampere. While the brakes, we are designing the 80 current braking. Moving to the chassis, we are completed our design of a monocoque chassis and in phase of manufacturing it. And in vehicle and dynamics, we have designed a simple suspension system of it, and in phase 2 design the lateral control module, which is known as LCM. While in the aerodynamics, we are taking the real life parameter that will help to commercialize and develop our cell at commercial level. So for the sake of time, we will discuss 3 major stakeholders, which are propulsion, brake and the levitation system. So I will go with the propulsion system, which aims to develop a linear induction motor. So these are our simulations and the results from the console software. So on the first image on the left hand side, we can see the on the y-axis we can see the magnetic air flux density, and along with the x-axis we can see the length. So we can say that how the magnetic flux density is incorporated in the track with the air height. So as we increase the number of slots in the linear induction motor, the curve will come to more sinusoidal approximated. On the right hand side is the console simulations of how the magnetic field simulations will act through the surface of the linear induction motor. On the bottom of the page, we have developed a DQ axis model for our induction motor that will control the thrust and the flux of our linear induction motor. So these are the specification and the CAD of our LIM. So right now we are focusing to build a small prototype which is power rated of 1 kilowatt, and in coming future we will develop by taking the learnings from a small prototype of about power rating 30 kilowatt. So I would like to read out few of the specifications, like we are targeting the efficiency of 65% and the maximum rated voltage 270 volt, and the maximum thrust force that it can produce is 200 Newton. So on the right hand side we can see our CAD model of our double-sided linear induction motor, and along with how we are going to attach it with chassis. So these are the manufacturing and testing of our linear induction motor. So on the first, we have cutted the metal sheet into the various small pieces, and by using the laser cutting technology, we have built the stampings of our stacks. And on the image, there is our respected Prof. Krishna Raj, which is helping us in creating the windings. And on the right hand side of the page, we are seeing that how we are testing and getting the mathematical model parameter out of the testing. So now moving to the brakes department. So there are the 2 major stakeholders. One is to build a frictional braking, and other one is to have the 80 current braking. So we have researched on the various materials of the permanent magnet, which includes SMCU, NDFEB, Alnico and ceramic on the basis of magnetic cost, operating temperature, corrosion resistance and magnetic strength. So by comparing all these 4 materials, we have come to that pneumatic magnets provides the greater strength and is easily available. On the right hand side, we have developed a mathematical model and simulated it in the MATLAB software, while we have used the mathematical parameters of the console software, and we are getting the same result. So on the left hand side there is the CAD of our brakes which shifts towards the I-beam track as we actuate our linear actuators. So the technical specifications are we are using the brake pad actuate against the top edge of I-beam, and we are using the actuators while the brake pad materials are organic brake pads. Over to you.
Okay, now coming to the levitation. As we said that we are working on two verticals. First was working on the prototype of the pod, and second is on the commercial level. So this was the commercial level project. Since we are not implementing levitation system in our pod, but here we were looking upon the commercial aspects of the levitation system. So basically we came up with this tubular model. So on the commercial level, our idea was that rather than implementing the levitation system on the pod, if we implement it on the tube itself, so this will basically reduce the weight of the pod. So we did this project under Professor J.K. Dutt, and here we came up with this model. So the picture shown on the right top of the slide, so this is basically the levitation units. It has 4 coils in it, and there is gap height sensor placed on each of the coil. So what the system does is, it judges the position of the pod inside the tube and sends the signal to the control circuit that we have designed over here. This control circuit changes the current in the coils, and basically that changes the electromagnetic force acting on the pod, and that keeps the pod exactly between the tube. So such magnetic levitation system can be installed all over the vacuum tube, and this will ultimately keep the pod levitated inside the tube. Plus that will also not add up to the weight of the pod. But again we will have to do in cost benefit analysis over here, that how much cost the system will be adding, and how much weight we will be avoiding on the pod. So our next 6 months we will invest on this, and we'll do basically the testing of this model. So till now we have done all the simulations and testing on the software level. So these are some results of it. We did in MATLAB simulation and all. So this slide shows that, and in the next 6 months our target will be to shift from the software to the physical level. Now coming to the future goals. So our future goal is basically to make each subsystem scalable and commercially implementable in the Indian ecosystem. So here are 3 departments listed. So in the first pod itself, we are targeting these 3 departments to be scalable up to the commercial level. First was linear induction motor, as I talked about the levitation system. And in aerodynamics also, we are considering the parameters which a commercial level pod will face. We are considering the velocities and all which a commercial level pod will run at. So these 3 departments we are currently targeting, and slowly we will move on to all the departments that each one of them are scalable enough at commercial level. Next is to analyze the socio-economic impact of Hyperloop system. Basically, we are fortunate enough that our director Dr. Rangan Banerjee has worked on the project which was implementing Hyperloop technology between Pune and Mumbai by Virgin Hyperloop. So he already has experience in that side, and he has suggested us to work on this. So next we will be picking up a project under him. Basically he will be guiding us through this to analyze all the socio-economic impact and how feasible it is to implement this technology in the Indian ecosystem. Next is to develop a control system to handle the disturbance created in levitation system by movement of passenger across the pod. This is again a project we will be doing under Professor J.K. Dutt. So currently he is helping us out for the levitation system, and once we are done with the designing of that levitation system, then we will move to this project under him. So as there will be movement of passengers inside the pod, so that can cause an instability in the levitation system. So the control circuit should be robust enough to handle all such movements. So this will be the next target in the levitation project. And the last is pressurization and depressurization of vacuum tube. As Professor mentioned that we can't lose, when the pod stops at terminal, we can't lose the pressure, all the vacuum we have created. So again we have to work on that how we will maintain that vacuum, and whatever depressurization takes place, how we'll make sure to pressurize the tube again. So these are some future goals which we'll be working further. So yes, that's from our side. Thank you.
Aditi. Thank you for an excellent talk. Coming back to our own Amchi Mumbai, let's welcome the Nirman Hyperloop group from Thakur College of Engineering and Technology, Mumbai. Please come.
Hello, Chico. Hello.
Sorry for the delay, ladies and gentlemen. So talking about Nirvan Hyperloop Group, the group was formed in 2018 and currently has 60 members. The team's primary objective is to bring a perfect mobility solution. Nirvan Hyperloop has been one of the fastest growing teams, which is evident through its participation at every national and international competition every year. They are optimizing the technology and releasing a better version of themselves with an eye on innovations and improvements in the concept. You don't ask much, do you? First speaker is the team lead, Ayush Agarwal, who is a student of final year mechanical engineering, and the second speaker, Upkar Chaurasia, the propulsion lead and a third year undergrad pursuing electronics and communication engineering. Ladies and gentlemen, put your hands together for Nirvan Hyperloop, Kashi College of Engineering and Technology, Mumbai.
Good morning everyone, I am Ayush Agarwal, team lead of team Nirvan Hyperloop, and today we are very grateful that Indian Railways gave us this opportunity to present over here. So Hyperloop, traveling a 50 minutes journey in 5 or 10 minutes, that is what Hyperloop promises. A pod which can travel at the hypersonic speed with the help of electromagnetic motors. This is what Hyperloop is. Praveen, first iteration of our Hyperloop, a mass of 200 kgs which will be capable of traveling at the speed of 150 kmph, and its dimensions are in width 0.5 meters and in length 2.4 meters and in height 0.6 meters. Further, I would like to tell you about our team history. In 2018, our team was found and we had 60 creative minds with us. Also, we participated in tunnel boring competition in 2020 and we got a massive achievement in 2 years. We were amongst the top 50 teams out of 400, and we participated in European Hyperloop Week competition remotely, and we were among the top 18 teams. Currently, we have completed our research and we are in manufacturing phase, and we also participated in Canadian Hyperloop conference, and we presented the aero shell domain in virtually. I would also like to tell you about the competitions. European Hyperloop Week. It is the most esteemed global level competition for Hyperloop, and we were amongst the top 4 in Asia which participated in this competition. Canadian Hyperloop Conference, a virtual conference which happens each year, and we presented the aeroshell domain. We are also in collaboration with national and international teams where we discuss about the issues which we face in the technical teams, and we try to solve those issues with the meetings. About the technical domains, first is the aerodynamics domain. The main purpose of the aerodynamics domain is to reduce the drag as much as possible, and this is done by using the Bezier curves. First we did the 2D simulations, and then we finalized the design, and after that we did the velocity profile or transient analysis to know the velocity drag which will be induced in the pod at low speeds. And after that we did 3D analysis considering all the constraints which will be like dimensions of the electronic systems and battery subsystems, and we finalized our fairing. The dimensions of our fairing is in length 2.8 meters and in width 0.5 and in height 0.46. We will be using carbon fiber as a material with different orientations for our fairing. For our control system, we are relying on the PLC for the transfer of data from sensors to the off-site terminal, and for the control of actuators and linear induction motors. We are using AXCF2152 up to 63 AXIO modules and 2 Ethernet interfaces with fast response time of 0.1 seconds. For sensor positioning on the front side, IMU, camera, laser distance sensors and pressure sensors will be there, and in the middle part, IMU at the center of gravity and temperature sensors will be used, and in the rear part, retroreflective sensors, IMU and laser distance sensors will be placed. For the braking system, our team is relying on the frictional brakes since it uses less current, The force which it will be generating will be around 2500 newtons, and it will be able to deaccelerate the pod by 1.125 g. And the material which we are using is aluminium because of its lightweight and good mechanical properties. The dimensions of the braking system are on the screen. In length 100 mm, in width 120, and in height 298. We are using 2 independent braking systems for our pod. For chassis. So this is the main structure on which all the subsystems will be mounted. We are using C-section since it provides more strength, and we are using a sandwich structure of carbon fiber and aluminium together. The length, in length it will be around 2.4 meters, and in width 0.42, and in height it will be around 0.25. Since there will be a track irregularities and there will be a vibrations which will be caused in the pod due to during the acceleration and deceleration phases, we are using vertical suspension system and lateral suspension system. Lateral suspension systems are used to maintain the uniformity between the tracks, and it will avoid the collision between the subsystems which will be placed near the I-beam structure. For the dimensions of the vertical suspension system are in length 0.38 meters, and in width 0.112, and in height 0.1 meters. Since our pod will be controlled by an off-site terminal, we will be using this graphical user interface where all the data from the sensors will be transferred and it will be controlled. The main, we will be using DSLIM for control of the propulsion system, and first we did the 2D analysis of 24, we are relying on the 24 slots. In length it will be around 600 mm and in width 180 mm. After that, we did the 3D analysis and we considered the following parameters in voltage 240 volts and in current 200 amperes. And we got the speed profile of 22.27 meters per second. We also made a scaled down prototype of 9 slots, and this is the first linear induction motor which you can see on the screen on the right side. And we got the successful results, and this is the first linear induction motor in Mumbai. Further will be continued by my teammate on the system. Thank you, everyone. Further will be continuing with the sustainability, which is our main aim of our today's presentation. That is connecting 2 cities by carbon neutral way. Moving to next. Yeah. As we all know, starting from Mumbai to Ahmedabad is one of the busiest route in India. So we had come up with some solution like as it connects major cities starting from Mumbai, Vapi, Surat, Vadodara, and Ahmedabad, traveling approximately about 40,000 people on a daily basis. So we had did analysis like what can be just I guess what can I say? Parameters which we had analysis, and we have proposed this route for our first phase implementation between the route starting from RA to Ahmedabad. And problem statement was mass carbon emission due to the transportation sector and how we can overcome with the Hyperloop and how it can be game changer, right? So we had did certain calculations and research on existing routes starting from airways, roadways, railways. So we had come we had got the numerical value approximately about carbon emission of 210.24 in kg for airways, and for roadways it was about 102.85 kgs. When it compares to the railway, it was about 106.356 kgs. Right. So solution to be find out for the carbon emission caused by the current existing transportation system. So we had did analysis and we had come up with the results like carbon Hyperloop will be a completely carbon neutral, and the energy which we will be generating on board traveling from Mumbai to Ahmedabad will be approximately about 500 megawatt, and the fuel consumption in terms of kilowatt will be about megawatt, will be about 450, and the remaining amount of energy we can provide to the nearby villages or to the station for their operations. Coming to the next one. Yeah, catalyzing the Hyperloop ecosystem in India. Yeah. Proposed ideology. Yeah, so we had talked about building Hyperloop in India, and like as we had mentioned, at a research level, starting from a research work in India, research field had been started, but we need to scale up for up to like a 3 to 4 meter, where we can start putting people in a pod and developing a basic Maglev technology for initial phases of operation, so we can prove our technology in real world. After that, we can do some industrial collaboration where prototyping with making a real magnet, right, for can say for a real world, and to regulate or to validate our results in a real world with some industrial collaboration. As you can see there is a Birmingham International Maglev Train, which was back in 1980, which was proposal ideology was Germans, and they had started with this kind of Maglev proposal, and then they had come up with the Hyperloop, as term is developing in that institute. Yeah, talking about industrial collaboration, potential companies in India, we had found out Titagra Wagons and BEML also in India, and Bombardier India, which has a quite huge experience in making metro service, metro trains and intercities trains in India, and so we can collaborate with them and come up with some prototyping, initial sales. As you can see that South Korean Lichtenstein Airport Maglev technology, we can develop some certain kind of that Maglev in reality in India, and we can put into that real world and just take just see if the things are working properly as our predictions or with our calculations or not. And after that, putting at a public service at a huge scale, as you can see the South Korean Lincoln Airport, Maglev, we can put into tier 2 or tier 3 cities for our initial phase of operation if we see that things are working at our predictions or not. At the end, it is a simultaneous development of Hyperloop infra, stretch vacuum, vacuum of and control system, etc. Yeah, concluding the ideology, as we all know, India, we've yet to receive our first high-speed railway infrastructure, and we are talking about here Hyperloop, which is good, but we need to come down to reality. Instead of focusing directly on building on a Hyperloop infra, right? We need to split that task into two. First, we need to develop a basic Maglev technology which we can put in a real world and implement and observe how the things are working as perfect as our predictions or not. And the second is developing a whole Hyperloop infra, which we will be doing simultaneously at institute level, which we are doing currently right now, right? At various institutes, it has been started. Moving to next point, India can have its first functional Maglev technology, which is the base. As we know, as we value with the concept that Hyperloop need is what basic Maglev, and when we put that Maglev into a vacuum environment, we get the Hyperloop, right? So once we will be having a Maglev technology in reality in India, because in India we didn't have Maglev technology currently running at any level. So first we need to develop a Maglev technology in India, which can be put on a tier 2, tier 3 system, for initial phase of operation. If we validate those results, and we can come up with the we had validated this kind of technology, and we are ready to be putting this technology into vacuum environment, and we are good to go for Hyperloop, right? So the next step will be putting that Maglev technology into Hyperloop, vacuum environment, and that's how India will have its basic Hyperloop, right? Yeah, we would like to thank our current sponsors who had helped us to reach at this stage, starting from electronics to aeroshell. We had got everything from them. This is our team. Thank you.
Thank you, Ayush, and thank you, for a very different take on the Hyperloop technology, I must say. Thank you. Please take your seats. And now, going south, we would like to invite the Hyperloop India team from BITS Pilani. Please come. Hyperloop India Group was formed in 2014 and is composed of students from all the 3 Indian campuses of BITS Pilani. It was the only Indian team to reach the world finals of SpaceX inaugural Hyperloop competition in 2015-17. The team's current objective is to design and fabricate a prototype of the Hyperloop pod that can reach speeds up to 150 kmph in less than 4 seconds. Through a unique and optimized design of linear induction motor and an eddy current based braking and levitation mechanism and an efficient aerodynamic design to minimize the drag. May I welcome the presenters. So with me I have Pranshu Vyas, who is the overall team lead of Hyperloop India. Raghav Dubey leads the braking and levitation subsystem, and Karandeep Singh leads the propulsion subsystem. Ladies and gentlemen, let's hear it for Hyperloop India team. Over to you.
So firstly, I'd like to thank Professor Hemant Karkar for inviting us to this conference and giving us the opportunity to interact with other stakeholders in the Hyperloop domain in India. And I'll give a brief introduction about myself and the team. So Hyperloop India is a team composed of students from all 3 Indian campuses of BITS Pilani, and that includes undergraduates and higher degree students. And I am Pranshu Vyas, a 3rd year undergraduate in the mechanical engineering branch. So coming to the first question that would come to everyone's mind is, what is Hyperloop? To give a good picture of what is Hyperloop, you can imagine a maglev train being put in a vacuum tunnel or a partially vacuum tunnel, and that sort of removes all the air friction and the friction due to the wheels that we have talked about in earlier presentations as well. And because of virtually no friction, we can speed the pod up to speeds like 1200 kmph using propulsion techniques like linear induction motors. So this graph by Hyperloop 1 is a good representation of where Hyperloop stands when compared to other modes of transportation. So on the top right corner of the graph, you can see that the supersonic passenger jet Concorde, which had the highest velocity but also had a very, very high energy consumption. So in general, this trend shows that the more velocity you aim for, the higher energy you'll have to consume. Whereas Hyperloop can be something that is away from this trend, wherein we can get a speed of a jet while consuming much lesser energy levels. So to give you a picture of how a Hyperloop route would look like in India, this was the route that we had proposed in 2016 for the Hyperloop 1 Global Challenge, and this route was awarded as the winning route. And the cities we had connected were Mumbai to Chennai, and you can see the timings that it takes for traveling from Mumbai to Bangalore, which is around 45 minutes, and Mumbai to Chennai, which is just over an hour. So living in Pune and having your office in Mumbai might just be the reality with the Hyperloop implemented in India. Coming to the rationale that we had while planning this corridor, firstly, it should integrate well with the existing projects, the existing railway lines and the existing road transport plans and highways. Secondly, it should connect cities such that passenger and cargo transport is maximized. And for that to happen, it'll have to connect cities with high potential markets and growing economies. And another factor is the tube should be in a minimal seismic activity zone, so to minimize any chances of earthquakes or any other natural disasters. Coming to the tech that can make all of this possible, I'd like to hand it over to Karandeep.
Good afternoon, everyone. Before I start explaining about the propulsion, I would like to introduce myself. I am Karandeep Singh, a third-year mechanical engineering student at BITS Pilani, Hyderabad campus. I've been part of the team and have been working on the propulsion subsystem, and I'm currently leading the team. So let's start. Let me ask you what comes to your mind when you talk about propulsion. Propulsion is basically the force you require to move something forward. So to get these forces on a Hyperloop pod, we are using electromagnetic devices like linear synchronous motor or linear induction motor. Though we have decided to use a linear induction motor in our pod because though a synchronous motor can be more efficient, we have decided to use a linear induction motor because keeping in mind various parameters like power consumption, the cost, and most important, the simplicity of designing it. Since I have told you that we will be using a linear induction motor, I'll be explaining the basic physics behind working of a linear induction motor. So, what is a LIM? A linear induction motor can be thought of as slicing a rotary motor along its radial direction and unrolling it. It uses a three-phase AC current, and this three-phase AC current on the pod creates a varying magnetic field. And due to these varying magnetic fields and phase lag in the inputs of the signals, there is a linear moving magnetic field produced. And due to this moving magnetic field, there is a flux change in the track. And due to this flux change, the eddy currents are induced on the track. And due to these eddy currents, again a magnetic field is induced, and this magnetic field is always trying to chase the magnetic field of the primary. And due to this, this difference in the speed of the primary magnetic field and the secondary magnetic field is known as slip. So as you can see in the image, as you can see in the image, the strength of the magnetic field was plotted, and you can see at different time steps, and you can see the pink current graph which is moving with time. So this is how the magnetic field is moving. So at zero slip, the thrust becomes zero because there is no change in flux in the secondary, and due to this, no eddy currents are induced. So this is basically how an LIM works. So as I've told, we'll be creating a linearly moving magnetic field. But how is this achieved? This is achieved using polyphase excitation. So what is polyphase excitation? Polyphase excitation can be thought of splitting the signal into of equal amplitudes and frequencies, but with a phase lag. As you can see in the image, this is a rotary motor which is using a three-phase AC current with a phase lag of 120 degrees. And due to this, the coils are excited at different times, and due to this, a rotating magnetic field is produced. As I have already told, the working principle of rotating magnetic field and rotating motor and a linear induction motor is quite similar. So similarly, using this concept, a linearly moving magnetic field can be produced in an LIM. So this is the physics behind it. Now coming up with the design we have come up with. So, as we are planning to take part in the European Hyperloop League, so it has a track length of 100 meters this time. So, and we are trying to achieve a speed of 150 km per hour. So, keeping all these constraints in mind and keeping in mind the passengers' comfort and safety, we have first thing to design a motor, we need to know the thrust required from the motor. So, keeping in mind all these parameters, we came up with a thrust around 1.2 kilonewton would be required. We would be using a double-sided linear induction motor configuration to obtain this thrust. So I would like to conclude the propulsion subsystem by just showing you the simulation results. So on the left corner you can see the mesh details of a motor. It is an 18-slot motor, and we have tried to keep the magnetic flux density below 2 Teslas because above 2 Teslas overheating might take place, and due to this the efficiency of the motors can be reduced. And the graph on the right hand side, which is the supply frequency force versus the supply frequency graph, and this was done in the frequency domain. So you can see we have achieved the force of 1.2 kilonewtons, which was which was the thrust we aimed for. Thank you. And now to explain about the braking, I would like Raghav to.
So good afternoon, everyone. My name is Raghav Dubey, and I am a third-year mechanical engineering student. And I will be giving you a brief overview about some of the subsystems of our pod. So firstly, I will go through the braking subsystem. So braking is an important subsystem of the pod as there are minimal opposing forces acting on the pod. So due to the magnetic levitation, there is no frictional force which is opposing the pod, and due to the vacuum chamber, there is considerably less aerodynamic drag force. So the main objectives of our braking system is to produce a decelerating force as and when required, and in case of an emergency stop, and to provide an emergency stop in case of a power failure. So keeping in mind the passenger comfort, we aim to design a system to deliver a maximum braking force of 2.2 G in case of an emergency stop. So how will we produce a braking force? So a negative thrust will be produced by reversing the current in the linear induction motor, which can also be thought as regenerative braking, which will contribute to a total part of the braking force. Another part of the braking force will be produced by using eddy current braking, as other teams have also explained about the use of eddy current brakings. So we can use both permanent magnets and electromagnets for this process. So basically, our design of the pod uses permanent magnets as they will work even in case of power failure. So now I will be discussing about the permanent magnet braking system. So a Hallback array. So I will be now describing what an Hallback array is. So an Hallback array is a configuration of permanent magnets where the magnetic field is amplified in one direction and it is cancelled out in the other direction. So we will be using this configuration consistently in our braking as well as levitation modules. So on the top left side, you can see a schematic of a simulated Hallback array in consoles. So as you can see, the magnetic field has been amplified in the bottom direction and being cancelled out at the top. So the cancelling out of the magnetic field is also an important phenomenon, as in the pod, passenger will be located and other also important sensors will be located which are sensitive to magnetic fields. So cancelling out of the magnetic field is also important. So for our braking module, we will be using Hallback arrays on either side of the rail to maximize the drag forces on the side of the rail and cancel out the lift forces. So now I will be talking about our design and mechanism proposed for braking. So for braking, we will produce one module on the front of the pod and one module on the rear of the pod to cancel out any of the inertia effects. So our design will consist of two C-like structures that can be seen in the top left illustration. So two C-like structures will be placed on either side of the rail, and they will be actuated in close proximity and away from the rail as per when required. To actuate the brakes, we will use a rack and pinion mechanism that has been demonstrated in the bottom left schematic. One rack and pinion is used at the front of the pod and one at the rear of the pod. And to actuate this rack and pinion mechanism, we will be running a stepper motor. So these are some results from our FEM simulation. So on the left side, you can see the drag forces which are varying with air gap. So from this graph, you can infer that as we reduce the air gap, the drag force will substantially increase. So we have to optimize this drag force as per our requirements by optimizing the air gap. So and the forces are known from the right side of the screen, you can see we can generate a velocity profile under braking of the pod by solving a simple linear differential equation. So now I'll be explaining about the levitation subsystem used by us. So one of the key features of a Hyperloop pod is the maglev technology. So to eliminate the energy loss due to the frictional force, between the track and the pod, magnetic levitation is used. So levitation is achieved by producing magnetic fields below the pod, which will subsequently produce eddy currents in the rail, thus producing a negative repulsive force, which will produce a lift force on the pod. So on the bottom left, you can see Holbach array, and the rail has been given a velocity and console. So you can see the magnetic fields that have been produced by the Holbach array. On the top, you can see a schematic of a levitation system which can be used in a Hyperloop system. So for the levitating mechanism, different systems can be used. So there are basically major three systems that can be used for levitation. The first is the air bearings, the second is the EMS, which is electromagnetic suspension, and the third one is the EDS, electrodynamic suspension. So basically our design focuses on the electrodynamic suspension as it uses permanent magnets and it is a fail-proof for levitation. So these are some of the results from our FEM simulations. So on the left side we can see the geometry and the mesh which has been produced for the levitation simulation. And on the right we can see results from our FEM simulation. The blue profile here is the lift force which has been produced by the Holbach array. And the green one is the induced drag force. So in case of levitation, an induced drag force also acts on the pod. So we can see that it maximizes at some velocity and it substantially then reduces and assumes a constant profile after some point. So now I'll be talking about the stability of the pod. So stability is also an important aspect of the pod, keeping in mind the passenger comfort. To make the ride as smooth as possible for the passengers, we need to isolate the pod from vibrations due to the external effects as much as possible. So to counter these effects, we will connect the levitation modules to the pod via spring damper system. We aim to imitate the suspension system of a car by using this kind of setup. So now I will be talking brief about the aerodynamics. So some of you might even ask, why is the aerodynamic analysis even important if there is a vacuum chamber present? So as we know that complete vacuum is not possible. So even if you reduce the density of the air by 100, so if you assume that the density of the air inside the vacuum chamber is 1% of the atmospheric density, then also there will be some drag force which will act on the pod as drag is directly proportional to the density and it is proportional to the square of velocity. So at high speeds, which is close to the speed of sound, substantial drag force may act on the pod, and thus an aerodynamic analysis needs to be conducted to minimize the drag force by optimizing the drag coefficient of the pod. And also another important factor that needs to be considered while doing the aerodynamic analysis is, as the speeds of the pod can be reached greater than 0.3 Mach, a compressible flow analysis needs to be done. So for our aerodynamic analysis, various numerical analysis and CFD methods, which is computational fluid dynamics method, has been used. And on the right side, we can see some of the pressure contours that have been plotted by us. So by using the aerodynamic analysis, we hope to optimize the shape of the pod by using various based techniques like the genetic algorithm. Now I will re-invite Pranchal to explain about the electrical and software subsystem.
So all the mechanical subsystems that were earlier discussed have to be controlled using onboard microcontrollers, and the feedback for the control system can be given by sensors. So all of that comes into our electrical software, electronics and communication subsystem. And this subsystem is broadly categorized into three parts. The first is the sensor and interfacing, where we decide what aspects do we want to measure of the pod and place the sensors accordingly on the pod, and take important feedback from those sensors and act accordingly. The second is the inverter, BMS and the battery pack part of this subsystem, where as Karandeep explained, the LIM takes in a 3-phase AC current for that, and we have DC current stored on the pod in the battery pack. So we need an inverter that can convert it from DC to a 3-phase AC and use it in our LAM. And a BMS is also important to keep in check to monitor the battery pack and shut down power if there is any anomalies in the battery pack. Another important aspect of this subsystem is the communication module. Since there has to be continuous monitoring of Hyperloop pod, at least in the initial phases of the development, wherein the pod during its run has to give continuous feedback to a ground station, so that in case of any emergency, a manual override can be given from the ground station to the pod. Now I'll be talking about our previous research work and what our future targets are with Hyperloop research in India. So in 2017, we had built the Orca pod, and we were the only Indian team to qualify for the SpaceX World Finals, where we ranked 15th among the 24 finalist teams. The pod we had designed was India's first indigenous subscale pod that had capabilities to reach up to 0.3 Mach. It was highly appreciated at the competition for being a very cost-effective design, and we had spent almost half of what the other finalist teams had spent on their design. These are some of the pictures, the manufactured parts of the Orca pod. In 2018 and 2019, we worked on bettering the designs of the first Orca pod by implementing different strategies for the structures and for the propulsion mechanism. And after that, we shifted into a research phase wherein our goal was to come up with innovative methods to make Hyperloop a more feasible concept and increase the efficiency of Hyperloop pods in general. And we have published various research works in journals, and our research work spans across suspension of the Hyperloop to onboard electrical and electronics, and then it also includes the aerodynamics analysis and the optimization of the aerodynamic shell of the Hyperloop. So our future endeavor, currently we are working on a pod for the European Hyperloop week next year, wherein we are designing a pod that can reach up to 150 kmph in under 4 seconds. This speed is obviously in an open environment since the competition does not have a vacuum tunnel, nor do we have an access to it at the moment. This will be done using an optimized design of the linear induction motor and novel control techniques, and a no-contact braking system, or a braking system that is based on eddy current braking. And even the levitation mechanism would be based on permanent magnets, as we have discussed earlier. We'll continue pushing for research work in this field with aims to implement novel ML techniques for the aerodynamic development of the shell mainly, and also to research in areas, to research and come up with techniques so that we can obtain parameters of LIM in a much better way that will eventually be useful for designing control systems relevant to the LIM. Another important goal for us in the long run is to establish a vacuum test track at Vizpilani that can help us perform physical testing, and we can get real-time data from those tests, and that can help us in improving our designs. Coming to the support we need, so all of this obviously cannot be possible without any support from external bodies, be it professors or any industrial companies. So we require industry level expertise and guidance who can help us with our engineering approach, advise us with different design ideas and validate our simulation results. And another important aspect of this project is funds, and securing them also helps us in bringing our innovative ideas to physical reality, and it will eventually help in getting the fifth mode of transportation to India. And we'll also require support in development and establishing the testing facilities on campus. As I talked earlier about the vacuum test track, there are other smaller testing facilities that we plan on building and establishing on campus. And access to a shareholder network for further insights and mentorship. And that is the reason we are here in the conference today. And I think that is why these conferences should be held more frequently, because it allows us to network with other research groups, and that is really beneficial for everyone. At the end, I'd like to conclude by Vikram Sarabhai's quote that says that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society. In short, we have no time and we must lead from it. Thank you.
Thank you, Pranshu. Thank you, Raghav, and thank you, Karandeep, for an excellent presentation and what a noble thought. We have no time, but we must lead from Vikram Sarabhai, our pioneer from the Indian Space Center. And now, ladies and gentlemen, I would wish to introduce a group of professionals who are neither a research group and neither industry, but are quite passionate about Hyperloop technology and its proliferation in India. The group is called Indian Hyperloop Committee. It's based out of Pune, and they have requested me to give them an opportunity on this platform to air their views about how passionately they feel about India and Hyperloop. May I request the representatives from Indian Hyperloop Committee to please come up on the stage. So while they load the presentation, let me tell you something about the Indian Hyperloop Committee. It's a group of individuals who believe that India can, ladies and gentlemen, please note, India can and should be the pioneer of Hyperloop technology, set forth to remove every obstacle and fill in every gap that will be in the way of Indian teams to do pioneering Hyperloop technology work. Excellent thoughts and excellent execution, I must say. Are you ready? Okay. So with me, I have Ms. Shivani Singh, who is the founder president of Indian Hyperloop Committee, and with her is Purnesh Jain, who is the chief operating officer and co-founder, and also the captain of Megapod Hyperloop. So over to you, Shivani and Purnesh. Let's see what are you doing.
Good afternoon, everyone. We are Indian Hyperloop Community. So we were established 2 months back in October 2022, and our group of eager students set out with the sole purpose of fostering India's Hyperloop community by contributing to India's Hyperloop community in all means possible. Before walking you through letting you know more about us, I would like to walk you through some of the major problems that research groups of India are facing while designing their technical prototypes.
So what are the problems that technical teams are currently facing? First of it is lack of financial support. Lack of investments, lack of investors to fund their projects is one of the major problems that is stopping any research team to work. This is because another problem of lack of awareness. Many of us Indians don't know the sole purpose of Hyperloop and what Hyperloop is. Because of the lack of awareness, they regret or they think twice before actually investing or spending their money into such a project. Third problem that we face commonly is there is no platform on which we can easily discuss problems, we can easily discuss and come up with solutions, we can showcase our work, we can come up with different ideas and approach for solving various problems. Last is lack of knowledge transfer. The teams that have been already established past 3 to 4 years have already accumulated a lot of knowledge. So this knowledge has to be transferred to other and tender young teams so that they can grow and learn faster and easily. So at IHC, we plan to solve these problems and come up with some solutions so that it becomes easier for us to bring Hyperloop technology into a reality in India first. So how do we go about this and how do we solve these problems? So our vision and our mission is to educate, collaborate, inspire and support every technical team as well as every organization that is working in the domain of Hyperloop. We would start first by educating, by spreading awareness about what Hyperloop technology is, how Hyperloop technology can bring benefits to our country, how can it support us, and all the various advantages that Hyperloop technology brings along with it. Collaborate. So there are teams which lack some resources and there are teams which are abundant in resources, which in some mediums, for example, we will be having testing facilities in IIT Madras with their vacuum tube, and we will be having some other team building a good vacuum compatible pod. So we can collaborate and we can have facilities that any team can come and collaborate and make their work easier. Third thing is inspire. So to bring more and more people on this platform and to encourage people and young minds to work in this domain, read about Hyperloop, learn about Hyperloop and contribute as much as they can in this domain, it is very important to inspire people. We can do this by organizing various seminars, conferences and various other competitions, as a competitive mindset can lead to some drastic innovations. Support, so asking technical supports from industry leaders, connecting industry leaders with Hyperloop Hyperloop teams and sharing knowledge with them. So this is some of the aspects where industries can support these teams and help bring Hyperloop into a reality as soon as possible.
To do all these things, we have planned out some of the events for all of you and our general public as well, so that we can spread as much as of Hyperloop and make it a reality for India. So beginning with our first program, that is Hyperloop team networking sessions. So for that we have planned of making a team meetup, as one of the members of Hyperloop India said right now that we should have frequent meetups for all the Hyperloop teams of India so that we can come together, discuss our ideas and share as much knowledge as we can with each other. For that we have a team meetup planned upcoming in January 2nd week, and followed by that we have a conference just like our NIAD organized for us. After that, one of the main points that Purnesh mentioned right now is awareness about Hyperloop in India. The general public and can say the upcoming generation of India don't know much about what Hyperloop actually is. So this is the main problem why our technical teams lag with funds actually. Because people, when they don't know about technology, they hesitate in funding such projects. So for that we have started something called as Hyperloop Technology Awareness Programs, where we will be organizing webinars for school students and university students to let them know about what Hyperloop is and how they can come together. We can inspire them and ask them to like build, do studies and contribute towards the Hyperloop technology. Similar kind of event that is upcoming in the January last week is Know the Loop, where we will be inviting the major Hyperloop technical geeks from all over the globe to speak about the Hyperloop technology and make the general public aware of that. Engage the next generation. This is one of our major programs where we will be going from school to schools awareing our upcoming generation about the Hyperloop technologies and ask them to do a basic study of what Hyperloop is and giving them a platform to present their ideas and things so that our upcoming generation is also in the loop, and after we leave the stage, they'll be here to take over us and make Hyperloop a reality as soon as possible. The major and the giant event, that is the Indian Hyperloop Summit, that is one of the most important part of Indian Hyperloop Committee that we are going to put forth in upcoming April 2022. Yeah. So this will be a big Hyperloop festival where we'll have a number of events lined up for a week, but some of the main agendas of this event are mentioned here. So we'll have the technical presentations and demonstrations of our research groups that have already worked on that, so that we can let everyone know about what they have designed till now and can share their knowledge as much as possible. The second one is the public awareness programs. Like we will be organizing programs like skits and cultural activities all together with our technical teams going out in the public and telling people about what Hyperloop is, so that we can make people aware of Hyperloop technology. Third one is public panel discussions, where we'll allow the general public and the students from schools and engineering students to allow question our technical experts, our team leaders and industry leaders about Hyperloop technology, and so that it will lead to their increase their curiosity and sort doubts about Hyperloops. Like there are a number of myths about Hyperloops spreading around in India, like as of that it's not safe or it's not possible. So yeah, we all have to do it and let them know, yeah, it is possible and we can do it. The final one, that is the knowledge transfer session. This is the most important part of Indian Hyperloop Summit, as that's our main agenda, to bring, to collaborate and bring Hyperloop technology in India. So yeah, as we have always heard of this thing, that a stack of wood is tough and harder to break when compared to a single stick. So this is what Indian Hyperloop Committee thinks of. That if we'll work on Hyperloop technology as individuals, we'll be stuck somewhere like doing the same thing, all the groups doing the same things. But if we come together onto a stage and work together on building up the Hyperloop technology, India can achieve a lot. As we all know that Indian minds are great at ideas, but because of lack of support, let it be financial or technical, they lack in executing those ideas. So this is what we don't want, and that's why we are here to help and support our technical teams, so that they'll be able to execute their ideas, and so that India will be the leader this time on putting up the Hyperloop technology. So yeah, as I mentioned that Indian Hyperloop community wants to contribute to Hyperloop community of India by all means. So other than providing all of our teams and research groups a platform, we are also working on some of technical and commercial researches that we have just initiated as we were established 2 months back.
So these research domains are we've just noted a few of the research domains that we will be conducting, but they are not limited to these. So starting and giving the glimpse of some of them is effective vacuum maintenance and creation. So how can an effective vacuum be created, or what are the possible ways that you all can prevent the leakages, or how can you all ensure that perfect vacuum is maintained all around the tube. Second thing is feasibility of Hyperloop between major cities of India. Where all the corridors are necessary, what should be the frequency, how should it be planned, business model of Hyperloop technologies. If we are planning to build any Hyperloop corridor or any track between any two major cities, then how should the business model be? What should be the frequency of the pod? How many passengers should be carried around the route in one pod? And so all the questions can be solved. Energy consumption studies. How much energy will a vacuum technology consume? What is the percentage of energy consumed by the propulsion system, the levitation system? How much energy is actually necessary? What amount of energy is required for the stations to run? All these questions can be answered through research and development. And these domains are not only limited by IHC. In fact, anybody can join IHC and contribute and choose any research domains and start working in a collaborative way. Continuing the further research domains, what are the safety parameters required in an Hyperloop? As Professor Chakravarti stated earlier, that it is similar to Hyperloop is similar to any transportation medium in space. So that brings along quite a lot of risks. So how to mitigate these risks, how to solve these problems, how to come up with innovative solutions so that this process becomes much more easier is something that we should focus on. Infrastructure feasibility. So what are the parameters that decide that what should be the infrastructure like? So these are some of the domains as well. Standardizations of various parameters and geographical challenges are some other research domains as well. But these research domains are not limited, and we are free to add more and more research domains and give as much as possible to this Hyperloop technology. And as I'm repeating it on and on, that it is a collaborative platform. So I suggest, and in fact I believe that everybody present here who is willing to give some contribution to this Hyperloop technology should surely join IHC and contribute towards this technology and make sure that India becomes one of the first countries to bring up Hyperloop technology and benefit to all the Indians. But how to join this community? I would like Shivangi to explain the further process of how anyone can become a member of this community.
Okay, so beginning with the campus ambassador programs, or what we can call them as campus representatives. This is for all the engineering colleges. So we are here open for this thing, and it is just like you will be the representative of the campus at IHC or Hyperloop. Your role will be to explain and spread awareness about Hyperloop in your college and city or state, whatever you feel is like more beneficial. These are some of the contact points where you all can contact us. And I'd like to tell you all that Hyperloop IHC is an open platform and it's open for anyone and everyone. Thank you. Let's make Hyperloop a reality.
What an excellent idea, and what unbounded passion. Ladies and gentlemen, please put your hands together once again for Indian Hyperloop Committee. With these, ladies and gentlemen, we conclude the second session, wherein the research groups of the educational institutes presented their research on Hyperloop systems. Ladies and gentlemen, may I request you to please give a round of applause to our young and bright engineers who had come all the way, who are really working hard. I know some of you are having your exams, some semester exams or something like that, and despite of that, you could come here, and we really are honored by your presence. Pranshu just mentioned that it is most of the people don't know about Hyperloop. Pranshu and ladies and gentlemen, I would like to inform you that we in Indian Railways are aware of Hyperloop, although in separate words. We are quite hyper, and we know how to send things in loop. The only thing is that connected together, we are on a new trajectory here. So we break, ladies and gentlemen, we break now for lunch. We meet back at 2:30 sharp, and when we come back, we will be starting our third session, wherein we will be knowing about the Indian Railway initiatives for Hyperloop technology. For my non-railway friends, the lunch will be served at the officers' mess, which is, as you go out, is on the left side of this auditorium. Thank you, and let's break for a leisurely lunch. Thank you.
Hello, check.
Yeah, it is basically. Good afternoon, friends. I call this house to order. Please settle down. We are ready to start the third session of this conference. Ladies and gentlemen, this is the conference on Hyperloop Transport System and Indian Perspective. You are in the National Academy of Indian Railways and this is Sardar Patel Sabhagaya. Welcome back from lunch. I hope you enjoyed Naya's hospitality.
Yes, sir.
Thank you. So before going to break, we had the keynote address of Dr. S.R. Chakravarti, wherein he elucidated the finer points of Hyperloop technology, as well as what exactly is required in terms of passenger and freight transportation through Hyperloop. Then we had our young and bright engineers telling us about their research and how India can become a superpower in the next decade or so with this indigenous research about the Hyperloop technology. And now we are ready to start our third session. And the third session is all about the Indian Railway initiatives for Hyperloop. May I invite Shri Sudeep Srivastava, Executive Director, Signal and Telecommunication, Gati Shakti Directorate, Railway Board, to please come up on the stage and deliver his address. Shri Sudeep Srivastava is a 2000 batch IRSSE officers. For the uninitiated, it is Indian Railway Service of Signal Engineers and Signal and Telecom Engineers, and currently posted as Executive Director Gati Shakti Signal and Telecom in the Railway Board. Is part of a technical committee of Railway Board dealing with Hyperloop. So he is the person. He has wide experience of dealing with technical and financial aspects of the Indian Railway projects. He was instrumental in commissioning a huge route relay interlocking, that is 550 routes in Nagpur in a block of just 2.5 hours. Ladies and gentlemen, that's a record. And for which he was given the MR Minister of Railway Award. During deputation to Health Ministry, he has dealt with new AIMS project under Pradhan Mantri Swasth Suraksha Yojana. He has undergone training and collaborated leadership of OPM and health financing in World Bank US. And today, we shall be hearing from him about the Indian Railway initiatives and what Indian Railway thinks about Hyperloop technology. So welcome Sudeep, over to you.
Thank you, sir. Good afternoon, everybody. I do empathize with you that you have to bear with a presentation immediately after lunch. I bear the testimony when I was sitting on the other side of the stage on earlier occasions in this Sabhagaya. But I will try to make it unassuming and interesting at the same time. So, how many have you have watched the movie Jurassic World Dominion? Any? Oh, good, few. So that was the movie in which they showed a Hyperloop. And Hyperloop was shown in that movie on multiple occasions. So movies basically reflect either something from the past or something from the future apart from the contemporary. And so this Jurassic World Dominion showed how Hyperloop was working in that Jurassic world. Now coming back to the real world, this is the structure of my presentation. Just a concept that has been discussed quite in a comprehensive manner during the morning. The background, comparison with other modes, technical components of Hyperloop, current status of Hyperloop, Indian scenario, the initiatives by Railway, and most important, the future roadmap. I would be failing in my duty if I don't mention that my colleague from Railway Board, Mr. Prashant, electrical engineer, has been very helpful in this entire exercise with me. So the credit should go to him. Coming to the Hyperloop, a lot of these things have been said in the morning, so I would like to be brief on this. It's expected to be the 5th mode of transportation the future requirement in view of globalization will depend a lot on similar technologies. The carbon footprints are going to be less. Someone showed very beautifully through a curve that this is an area where we can actually improvise. The time setting in fast growing economy, safe and convenient journey, economical benefits, and it will help you connecting at a far off places within a reasonable time span so that the commuting becomes easier, and that will change the economy of that region. But all this is not only futuristic, it is also aspirational to begin with. As a concept, we all know that there are two major problems that are faced when a transport moves. One is friction and other is air drag. Friction reduces substantially when you use something like a maglev. It doesn't exist because there is no contact. But air drag becomes a major component when you are having speeds of more than 300 kmph. So Elon Musk came up with this idea that if we can move a maglev-like thing in a vacuum, we will be overcoming the issue of friction as well as the air drag. So this concept basically talks that in low pressure tubes we are moving a pod at a very high speed, and those pods are moving through levitation, and the low pressure ensures that the air drag is quite less. These tubes can be on pillars, but it is not necessary, they can be underground also. For example, when we were studying the Swiss example, 70% of their proposed Hyperloop is going to be underground, only 30% will be above. And Alpha paper was the one which was released by Mr. Elon Musk, and when he released that paper, he was not exactly talking of electromagnetic suspension or electrodynamic suspension. He had some other ideas, he talked of air bearings in his presentation basically. But things have evolved a lot since then. And the last line is an important one. It's in a developmental stage. We are yet to do what is known as proof of concept. Now coming to the background, as I was saying that Elon Musk gave this idea. Thereafter his SpaceX started this competition in 2015, and some of the participants of those competition are here with us. And we saw their presentations in the first half. Virgin Hyperloop then completed the first trials in 2020 in the deserts of Nevada in US. But that was at a speed of just 172 kmph. When we talk and think of this Hyperloop, we are talking of max speed. Now what is the max speed? It is the speed of the sound. So that is more than 700 miles per hour or almost 1200 kilometers per hour. But anyway, even if they are working at 1/3 the speed or say 400 kmph, it is going to be a substantial improvement from the speeds that we have at present. So these two passengers are the only travelers of Hyperloop till date, and attempts are being made to have a speed of Mach so that we are able to move very fast. Now this is comparison with the other modes of the Hyperloop, the airline and the metro rail. So here the two advantages that you can see is that unlike an air or a metro rail, you don't have to wait for the trains. The waiting time for the passenger, which is the second last point row in this slide, is going to be substantially less for Hyperloop compared to the air travel. Similarly, the departure uncertainty is going to be very low because here you will be dealing with a fixed control settings. It won't be depending on weather or any other thing. So the uncertainty component will be less once the system is totally functional. So apart from that, most of the airports are far away from city, and in case of Hyperloop, the very concept that it's a small pod that is there, so it can be in the heart of the city. So you can be quite close to your last mile when you have got a Hyperloop setup. So this is one area where you will have distinct advantages compared to a big railway station or a big airport. Now, if we compare the technologies, this is TGV is basically the French high-speed train, and this is the theoretical speed of Hyperloop that we are talking. As far as the construction cost is concerned, construction cost, few of the Hyperloop startup have claimed that it will be 1/3 of what is required for a high-speed rail. But again, this is a theoretical thing because we are not very sure of the cost. That will be known only when the technology element of Hyperloop are frozen and some POC is conducted on them. So As of now, based on claims, it is presumed that it is going to be 1/3 the rate of a high-speed train. And maglev cost is slightly more as compared to a high-speed train. The operating cost definitely will be lower in case of Hyperloop because of the very nature of its working, that there is going to be very little wear and tear. Though obviously you need some aero bridge for ingress and egress at the stations of Hyperloop, but in that scenario also, the requirement of for maintenance is going to be quite less. So O&M costs are going to be less. Energy consumption is going to be less because once you give some force to something and it starts moving, as Professor Chakravarti was saying, the first motion of Newton, you give a force, it will move and it will continue to move. So there is very little friction or air drag that is opposing it. Safety for this is at a concept stage, and land consumption in this will be less. So since it is going to be on pillars with a schedule of dimensions that are going to be less, the requirement will be less. Even in case of high speed, when I went to Ahmedabad and saw that, I found that since it was being done on a viaduct, so the requirement of land was less even in a high speed train. For a proposed Hyperloop, it will be still lower because of the schedule of dimensions will be lower. Now coming to the key technical components: levitation, propulsion, pod design, guidance system. Guidance system is in a way linked to the propulsion, in a way to the levitation. The data sensor communication, command system at high speeds, because it is you are inside a tube and you have to communicate in a real-time basis with minimum latency to the control center, because a fraction of a second delay or an error can wreak havoc in such scenario. Having vacuum is going to be a challenge. Safety will be a challenge, and route switching. Now, if you are planning to have a high-speed Hyperloop, you have to switch route at a very high speed. Till now, one of the companies in Norway has claimed that they can do route switching at 1000 kmph per hour. If they are able to do it, it's a wow for them. But it is something that is yet to be demonstrated. And then the terminal design. So then it can be an inside-out design. You first design the pod and then you design the infrastructure, or it can be an outside-in design. You first design the infrastructure and you design the pod accordingly. So all these are technical components that needs to be decided. Current status, I think this slide was there in one of the presentations in the morning. So these are the various foreign companies that are working in this field, and they have taken various initiatives. It is largely based in Europe, in US to a small extent, and of course South Korea and Japan are also thinking on those lines, but still now South Korea has done some developmental work. Now one thing that becomes very important whenever we are talking of something like Hyperloop is the regulation, the standardizations, and of course, these things are very important because without them you cannot run a product. You need to have some specifications. For example, in railways, for software embedded system, we have got something which is known as SIL 4, Safety Integrity Level 4, where the possibility of a hazardous failure per function per hour is less than 10 to the power minus 8. So this is a definition, the specification given by Senlec. For Hyperloop also we will need similar regulations, and work has already started in this regard both in Europe and in America. So for regulations they have got a European Commission and they have raised Euro-Rail joint union. For standardization they have got the SEN, Senlec and JATC Joint Technical Committee 20, which is going to be the nodal standard making committee for the Hyperloop in Europe. And then they are also incorporating the industry participation standards and the best practices. So these things will also be required because ultimately it will be the industry that will drive this product once it is proven. So these are the safety guidelines which have been issued by the US agency, TUV-SUD. And this is already adopted by the Hyperloop Transportation Technology, which is a US-based Hyperloop vendor. So it's a development agency, not a vendor. So this standards have been made. It is available on net also. So basically this will be a draft of the safety standard that will be adopted in US. For Europe, as I said, that joint technical committee, it was constituted in February 2020. Interestingly, our GNSR, which is the Railways Bible for Safety, was also written in month of February, though it was 1976. CEN, which is European Committee for Standardization, and European Committee for Electrotechnical Standardization, CENLEC, both these committees define, establish and standardize the methodology and framework of regulated hyperloops. So for that they have made a JTC, and this JTC will be adopted by the various European players in this game of Hyperloop. This is their roadmap, how they are going to prepare those standardizations. So the process started in 2021 with the setting up of the JTC. Now the preliminary drafts are already being discussed between the various stakeholders, and the final amendments of draft and verification will be done by 23, and by 24 it is presumed that the final standards will be issued, and they have made working groups, one for the operations and services and other for the systems and architecture. And India should also keep in mind that whatever product we are going to develop should be a world-class product. We should be making not only for us, but we should also be making with the purpose of exporting it to other countries. So you can export a product to other countries when the standards and specifications are as per the global benchmarks. So we need to have some collaboration with JTC at some level so that we are able to keep our product as per the global benchmarks. Now coming to the Indian scenario, to have the first mover's advantage, it was decided that Niti Aayog will set up a committee under its member, Dr. V.K. Saraswat, one of the renowned figures, to study this Hyperloop technology. And then this committee had set up certain committees, and the recommendations of those committees are under finalization. Then Maharashtra government decided to have a Mumbai-Pune Hyperloop project as a separate exercise, not linked to the Niti Aayog one. And this product they gave to Virgin Hyperloop. Also a feasibility study for Hyperloop from Bangalore airport to Bangalore city. Also is also being contemplated, and it has been said that this is one of the areas where we can have the pilot projects of Hyperloop. Other likely or prospective place can be the Jewar Airport to Indira Gandhi Airport in Delhi. So these are in the feasibility study stage. Then of course the Avishkar team made the presentation, and Professor Chakravarti is here. So this is a student project of IIT Madras, and Railway has been keenly watching this work. So obviously these dimensions which I have mentioned, actually the credit goes to the people from the team who are sitting in front of me. They made a wonderful presentation the first time. So when we talk of the Indian perspective on Hyperloop, first thing we want to know whether this technology is reasonably mature today. So as I told that Niti Aayog has constituted a committee, and that is deliberating on all these matters. Very soon it is likely to have those reports with the recommendations made public. Now, Government of India would like to involve the private sector in this, because private-public partnership is going to be a key component of such modern technologies. Atmanirbhar Bharat is theme of this government. So whatever we will do, we will definitely have focus on the Make in India component. And that is why we are encouraging our local startups, our institutions to come up with indigenous solutions that are at par with the global benchmark, so that we can take things forward. So the first project then can be thought of as something which can showcase the project, a tech demonstrator, and also to show whether this is going to be economically viable. So now the question comes, why Hyperloop technology should be in domain of Indian Railways? Of course, civil aviation can stake its claim, highway authority can stake a claim, but railway is more suited for such a thing. For example, we have got the experience and expertise in safe transportation. How many road accidents happen in India every day? A large number. But if you look at the railway accident that caused fatality, hardly any. apart from the safety record that Indian Railways have, we also have got ample land. So this land can be used for the pilot projects and for testing the technology for the various components. Then Railway is one rare organization where we have got experts from almost every field. You have got expert of civil from infrastructure, for logistics you have got operating people, for traction you have got electrical people, for vacuum you have got mechanical people, for communication you have got signaling and telecommunication people. So you have that entire bouquet of experts available in one organization who can take this thing forward. Then we have got an institutional setup for safety standards and regulations. For safety, we have got something like Commissioner Railway Safety, who sits in the office of civil aviation, but he is well aware of how safety matters are to be dealt. For standards, we have got our RDSO, which has been dealing with the new technologies and existing technologies for a transportation system. And for regulations, we have got various codes and manuals, and they have been quite effective. So we have got experience. And almost a repetition of the third line, that we have got the technical manpower. Railway's biggest strength is its technical manpower. And once this Hyperloop technology evolves, Railway will be the best ministry to actually deal with it. So, keeping in line with what I said on the previous slide, there are certain initiatives that have already been taken by Indian Railways. A project of 5,000 crore was sanctioned in 22-23 for developing energy efficient transport system, and it included the Hyperloop system. Our Honorable Minister for Railways is very proactive in these matters, and I think he also visited IIT Madras campus and met with the team of the Avishkar. Then Railway has constituted three technical groups, one technical of which I am a member, one operational group of which Prashant is a member, and there is one more group which has been constituted. We have also conducted discussion with various players in this field who have done some developmental work. We have tried to understand what they are doing or what they intend to do. Then Railway, through its own manpower, has developed in the TKD loco shed a linear induction based trolley. So this is something which Railway has developed in-house, as Railway has got some core competence in this area, I was saying. We have collaborated with IIT Madras. Now, since IIT Madras had made an early start, they were the early bird in this entire Hyperloop thing. So we have decided to set up a center of excellence there, and we have also decided that we will be giving 8.34 crore to IIT Madras for this project. And MOU has been signed between IIT Madras and RDSO in this regard, and I am very sure that this is going to come up in a very nice way. One of the presentations, I think the second last one, talked that there can be a collaboration that is very important in this. So it is not necessary that all technical components achieve their maturity at one center of excellence. We can have multiple center of excellence in various institutes and places. And in line with that, an MOU with IIT BHU is being planned, which will be developing linear induction motor based for the future transportation system. So it is under process. And so we look forward wherever we can develop. If say some IIT has got very good system or setup of aerodynamics that can be put to use, or if they have got some expertization in levitation systems or propulsion systems, so there can be multiple things. But as of now, IIT Madras has started ahead of others, so we have already tied up with them and MOU has been signed. Some salient features of these MOUs are here. So this is going to be our test bed, and the proof of concept on this technology is being planned by 2023. Because this is the first step if you want to actually develop a thing. First, have a scalable technology in mind, go for a proof of concept. Once the proof of concept is done, do a pilot project. Then after a pilot project, have some sort of integrity safety assessor or ISA checkup for that. And once all that is fine, you can have a commercial rollout of your product. Now the deliverables of MOU are stated here: to provide a detailed design document, to provide detailed testing and performance data, provide Railway with Hyperloop track as a testing platform for development of pod technology, and provide training to railway personnel in Hyperloop technology. Now coming to the challenges. As I said, we cannot talk of cost till we have frozen the technology. Now, freezing technology is not going to be easy. For example, if we talk of propulsion, someone say we should go for linear synchronous motor, someone will say we should go for linear induction motor. Most of the people here are going for linear induction motor, but then the question will come, what will be the end effects for a linear induction motor? How will you deal with that? So there is going to be an issue. Now when we talk of levitation, it can be active levitation or a passive levitation. I think people have gone for passive levitation here. Some of people were there telling in the presentation. But the passive levitation, you need to acquire a speed of 30 kmph before the levitation actually starts. So to achieve that speed, you will definitely be needing something. So that decision will have to be taken because there are advantages of both the technologies. Then I was talking about inside out or outside in design. That is also a decision that will need to be taken. What type of communication we will go for? Because as of now, inside a tunnel, we go for a leaky coaxial cable to communicate. Obviously, now with 5G coming and next year FRMCS, which is the next generation of the transport mobile communication systems, are going to be launched. So we will have to decide what technology to adopt because communicating on a real-time basis with a latency of 10 or 100 milliseconds with a control center is going to be a challenge. Then there are going to be operational issues. Thermal heating is something that needs to be addressed because whatever discussion I had or our team had with people, they are saying it's a challenge, we are working on it. Then route switching. I told Hearth of Norway has claimed that they can do route switching at 1000 kmph, but they haven't demonstrated it. In a lab, it is one thing to test something, and it is totally different to actually show it in a practical or a real-time situation. Communication I had discussed. Now, headway is going to be very important. You see, pods will move in a serial manner. So you need to maintain a certain minimum distance between them. In railway or in transportation, it is defined as the time interval gap between the two consecutive trains. Here it is going to be two consecutive pods. So how you will achieve that headway here? In metros, they have got something CBTC or the communication-based train control. But that will be a challenge here, how we will go. Then maintenance of vacuum. 100% vacuum anyway is not going to be possible. But a very low pressure will also be a challenge to maintain because with that low pressure, you have to give your aero brakes so that there at stations there can be ingress and egress of passengers. Then in case something goes wrong, what should be the distance between the vacuum pumps, other things? These are genuine operational issues that needs to be addressed before we come up with a solution. The standards, safety standards are going to be very important. And once we have worked out or frozen our technology element, the cost analysis is also going to be very, very important. Whatever product we are going, there is something called the cost of capital or opportunity cost. We cannot ignore it. So if we are developing Hyperloop and we are developing it at a rate costlier than we are developing a high-speed rail or a maglev train, despite its advantage, its financial viability will be questioned. Regulatory framework. So here, right now, Railway Act does not envisages that Hyperloop will be part of railways. So there may be an amendment to the Railway Act that may be required if we want to make Hyperloop as a part of Indian Railways, or it is possible that a separate legislation may be brought all together, just as people have got that NHAI for the road sector. Some sort of legislation will be required to have a proper authority for Hyperloop. Now the future roadmap. So as I have repeated earlier also, that the technology elements to be frozen is going to be the most critical and important criteria when we go ahead in this road for Hyperloop. Scalability is going to be a very, very important thing. If a project cannot be scaled up, then it is of no use. It can be a good research purpose project, but its research will hardly yield result if it is not scalable. Then Railway can be made a nodal agency to develop standards, regulatory frameworks, certification mechanism by adopting the global best practices. In fact, once railway is given the mandate to proceed with the Hyperloop, we can have discussions with the JTC and others so that our standards are as per the global benchmarks. Then railway has already started setting up center of excellence, and as I said, the collaboration can extend over more than one institute to have a more broad-based mechanism in this regard. And then railway may take up a pilot project. We have got quite large resources available for that. So we can identify and take up a pilot project, and that pilot project can be a tech demonstrator, and it can also be used for your scalable project testing. So these are the key future roadmap things that we have to keep in mind. So thank you very much for your patience hearing. If there are any questions, you can shoot them.
Thank you, Sudeep. Thank you for a very insightful lecture and what Indian Railways thinks. I feel that this will give really a good hope for a lot of people here, that Indian Railways is quite keen on Hyperloop technology. Thank you. We'll save the questions for the plenary session. And now moving on to our fourth session, let us hear from one of the most important stakeholders in this entire scenario, the Hyperloop industry. And we are fortunate here to have representatives of 3 industries which are currently working in Hyperloop in India, and I would invite them for sharing their thoughts. So first of all, may I invite the representatives of Messrs. Quintrans Hyperloop Pune. Please come on the stage. Quintrans Hyperloop is a private venture based out of Pune, aiming to develop the most affordable and efficient indigenous Hyperloop technology across India. The firm is involved in building novel designs in infrastructure and pod development for implementation of Hyperloop. Today we have with us Shri Pranay Lunia, who is the CEO and co-founder of Quintrans Hyperloop Pune. He established Megaport Hyperloop in 2018 as one of the early Hyperloop research units in India and has a strong background in strategic project management and development. Pranay also worked with DRDO in composite research and development for over more than a year. Then we have from Quintrans again, Dr. Bala Bhardwaj, who is the VP of Engineering and Development at Quintrans, formerly the chairman at SAE India and MD at Boeing India. Dr. Bala has more than 30 years of experience in the aerospace and mobility sector and more than 20 years of institutional faculty experience. We also have from Quintrans Mr. Prasanna Kedambi, who is the CTO and co-founder at Quintrans. Prior to Quintrans, his stint included contributions in automotive product development and homologation and compliance research at dispatch vehicles. So Pranay, welcome to this forum, and we are ready to hear from you. Thank you.
Thank you so much, sir, for the introduction. Good afternoon, ladies and gentlemen. I am Pranay Lunia, the CEO and co-founder of Quintrans Hyperloop. So I feel very honored to be kicking off the industry section for the conference today.
View, go to view.
Thank you so much. So before beginning the presentation, I will go back in 2018 to begin with my journey. So I started Megaport Hyperloop, the guys gave presentation early in the morning, with an idea to research and develop around Hyperloop and the relevant systems. Then we begin with Quintrans with a vision that we wanted to build the most affordable and efficient Hyperloop technology in the world. Now one question that often comes across or we are often asked upon is that why Hyperloop in India, or does Hyperloop need to be established in India? And to answer this question, we have three basic challenges that we as a country face in terms of transportation. Number one is rapid urbanization. In the past decade, we have seen that the tier 2 and tier 3 cities in India have grown exponentially. And this expansion has happened at an horizontal level, that is, the cities are expanding. So it is absolutely necessary that we accommodate or we account for such expansion at initial stage itself. The second challenge is the supply chain issues or the supply chain challenges. And it is not surprising that whenever there's a weather-induced delay, there are traffic congestions, the supply chain takes the biggest hit in India. In India, we account for around $37 to $38 billion annually just in supply chain due to the inefficiencies in the transportation sector. And hence, it is necessary that we have something like Hyperloop, which can go from A to B in extremely rapid speeds. With Hyperloop, we can prioritize the cargo in the supply chain industry. Cargo like cold chain logistics, semiconductors can be prioritized, and hence we can have those inefficiencies solved overall. Third and the most important challenge, I think, is the emphasis on public transport. You see, with the growing concerns of climate change, it is very necessary that we have some kind of a public or a mass transport which is completely green. And although we are adopting at the new EVs, the two-wheeler electric vehicles or four-wheeler electric vehicles, this adoption doesn't solve the issues of traffic congestion and delays. And something like Hyperloop, which can be adopted at mass scale, which can move people at rapid speeds, will solve this issue as well. So Hyperloop at a glance. Now I understand a lot of people have come here and given the idea of Hyperloop. But with this slide, I will be focusing on technologies which do not come across, or the advantages of Hyperloop that do not come across very often. It is a tube transport system which has electromagnetic motors with vacuum assist. The second is it is a destination-based travel with no intermediate stops. So I think early in the morning someone asked a question that whether it will have intermediate stops or not. So I'll give you an example. Let's say you have to go from Vadodara to Mumbai in a train. Now a typical train, let's say, has 10 bogies and around 700 passengers. So when you go from Vadodara to Mumbai, you are stopping at Surat, you are stopping at Vapi, probably Thane, Kalyan before going to Mumbai. And let's say if 100 passengers have to stop at Surat, because of them, around 600 passengers also have to stop at Surat because of them. And this is a huge inefficiency. Now Hyperloop solves this by having a point-to-point specialized pods or vehicles. So for example, if you want to go from Vadodara to Mumbai, you have a specific pod. If you want to go from Vadodara to Surat, you have a specific pod. So you can imagine this, that there is a straight line and there are branches coming out at various stations across that line. Followed by this, you have departure on demand with fully flexible schedules, similar to like metros. Again, a lot of people mentioned early that you come onto the station, you have pods every 2 and 5 minutes, and hence you don't have to wait along. It has pod or vehicle which can transport people or cargo and can travel up to speeds of 600 to 1000 km per hour. And one more advantage is that it can be built at an elevated corridor or on-ground structure or even an underground structure. So you can accommodate to the topography in the region. As a result, the land acquisition, the land hassle part becomes very easier compared to other modes. The anatomy of Hyperloop. If we try to classify Hyperloop overall, we can divide it into 3 parts. That is the primary, the secondary infrastructure and the Hyperloop part. Now the primary infrastructure are the core technologies of the Hyperloop, starting with the tube. The tube is one of the most critical element of Hyperloop. At the same time, it is also one of the costliest element of Hyperloop. It is viable to have a tube which can have a partial vacuum. At the same time, it also keeps the weather, the problems outside the weather, so that we can have a clear movement of the pods within the tube. The second is the track. Now the track has multiple components or proponents. It can include linear induction motor, the levitation magnets, the guideways made up of aluminum or iron core, etc. Third is the power grid infrastructure. Obviously, to power the electromagnetic motors, to give power at such a huge scale, you need to have such integrated infrastructure that takes electricity from the grid or some other sources. Next, we have electromagnetic systems. So this also can be divided in 3 basic parts. So you have electromagnetic or the linear synchronous motors, which give you stability in the Z direction, you can say. You have levitation, which give you the stability in the Y direction, and then you have the lateral stability systems, which give you stability in the Z direction. And all of this have to be developed using an electromagnetic perspective. The secondary infrastructure consists of support. Now, depending upon what type of topography the region has, it can be pylons, it can be the tunneling on the underground structure, and safety exits, etc. Next is the vacuum. Again, vacuum is a very critical or important piece of the technology, and you have integrated vacuum systems placed at regular intervals, and these integrated systems monitor those intervals to maintain vacuum at a particular level. Finally, we have station, which would be in order to integrate environment wherein the passengers can onboard the pod safely, and you can create a vacuum within those tubes for fast and rapid traveling. Next, we have Hyperloop pods, mainly consist of the pod or the vehicle itself. Now, this is something that has to be built up on ground, and a lot of student teams today propose the various designs of pods and prototypes that they have built upon. These pods are not typically very standardized, but the inspiration or a lot of the technology has been inspired from an aircraft fuselage. So it also has to have the similar pressurized cabin, and at the same time we are taking it at speeds similar to aircraft. The other parts of the Hyperloop pod consist of communication, controls and navigation. Again, as this entire system will be completely autonomous, it is necessary that all critical components of the technology are communicating with each other. So for example, let's say within a tube at any given point of time there are 5 pods. So all these 5 pods have to be communicated with each other. These pods also have to be communicated with the station A and at the same time with the station B. So in case of any emergency, all these pods or all these stations can be communicated with each other and bring all the pods to a safety. So the technology at Quintrans and what we are developing. So we are developing this proprietary technology around Hyperloop itself. Our specialization includes the long tubular sections making the tubes around Hyperloop, the electromagnetic track which consists of the linear synchronous motor that we are developing, and a customized pod vehicle depending whether it's a cargo pod or a passenger pod. So what have been our growth till now? We designed and tested India's first linear induction motor back in 2018, which was around 3 to 4 kilowatt in power. Since then we have had multiple development and iterations of linear synchronous motor going up to 12-13 kilowatts. We developed the fastest Hyperloop prototype Bose. We tested it at a speed of 75 km per hour on on-air test track which we developed at our university. Both of these the team gave a good presentation today. Currently we are developing a novel composite concrete based Hyperloop tube which will help us in reducing the cost and the speed of development. As Satya sir mentioned today early in the presentation that it is very important we reduce the cost of tubes, and with our main goal with the concrete tube was to decrease the porosity of the tube and at the same time to reduce the cost as well. So the core value proposition of all this technology that with the composite concrete tubes we have reduction of infrastructure cost by 40% as compared to steel tubes that the global counterparts are using. We are developing a linear synchronous motor which has a very high efficiency which will help us in having a complete contactless movement, and our pod design consists of a passenger capacity of around 30 to 40 passengers with 10 tons of cargo and a specialized cargo pod which can house a 20 feet or a 40 feet standard shipping container. Now with all this we offer Hyperloop as a stack of solution, making it a very cost effective solution by reducing the capital expenditure required as well as the operational costs. Now we'll go back to the evolution of high-speed transport and how it has come up globally. So the original concept started in the early 20th century in 1909 and 1940 when Robert H. Goddard started the idea of maglev as well as the vac train concept. Then Eric Lathwaite developed the first ever full-scale model of a linear induction motor to propel these ideas. Finally, this led on to in the 1960s and 80s, countries like Japan, US and Germany started to carry out the feasibility studies and seeing the implications of having a high-speed railway network within their country. And finally, in 1990 and early to the 21st century, we had commercial operating maglevs, bullet trains in Japan, in China and even in Europe. Now coming on to Hyperloop, in 2013 Elon Musk proposed the white paper. The technology was very different in the white paper and we have come way ahead of that. And in terms of other countries, US recognized Hyperloop in their infrastructure bill. They have a standardization committee. Sir mentioned the European Union is already developing and has a timeline for 2024 to complete the standardization. So with this graph, what we can infer is that we do not need to go 40 years back and start seeing the feasibility of high-speed railway networks in India. This was established by the other countries way back, and what we can do as a country is we can develop on this. So we take ideas, we take what these countries learn from their mistakes, and we can develop our own indigenous systems on that. So what should be our objective? Our objective should be to develop an indigenous Hyperloop system for India. And I can be pretty confident by seeing the presentations of all the industries, the research units, that we ourselves can develop this, and we do not need someone from the European Union or the US to come and establish a pilot setup or a proof of concept setup. And in order for this to happen, we need to develop a central or a nodal agency for Hyperloop, maybe something under Ministry of Railways. This will help us create a robust ecosystem which will majorly consist of 4 players. That is the government, the institutions, the industry and the investors. And all these 4 players will have a specific role. So for example, institutions or the research units will probably be involved in optimizing the technology, giving us the best suitable option. Industries like us will have the role to implement this and implement it as fast as possible. Investors will obviously be responsible to finance such kind of huge projects. And in the end, the government or the central agency their role will be to create an environment, a safe environment where all of these ecosystems can be developed. So with this collaboration, we can solve challenges and skip pitfalls. And this is something that we can specifically learn from ISRO in how they developed InSpacey, and they brought in startups for the space sector. And now we can see how far they are pushing. From this, we can learn the developments that we have earlier in terms of research unit, industry itself. And finally, this committee itself can help us in establishing a standardization and a monitoring institution. Now, one more question that also comes up is position of Hyperloop, or how do we put Hyperloop in the current infrastructure or the current transport infrastructure of India. So Hyperloop doesn't come here to disrupt any other modes of transportation, be it railways or airways. Hyperloop will be a complementary solution to short-haul people and cargo movement. Now we'll take both of these considered from an example of a freight as well as a passenger point of view. Let us consider a freight point of view. So let's say we want to transport goods from point A in one city to point B in another city. Now a conventional method will include a trucking module wherein the truck gets those goods from that point A in the city, and it stops at a particular place, traveling some distance, putting it in some warehouse, and similar steps till it goes till point B in the second city. Now this entire process involves 2 to 3 days of traveling. It involves inventory management of different warehouses, and as a result you can see the inefficiencies in the entire process. Now if we replace this with Hyperloop, so a truck comes, takes the goods and put it into a Hyperloop station, transports it within a day, within 1 hour, 2 hours to the other part of the city, and it is in the other warehouse maybe in 2 to 3 hours within a day. So currently how our freight industry works is that we work in the predictive consolidation of inventory management. That is, we see what is the demand in the market for a particular good, and on that basis we manage to see that supply for that demand has been catered to. Now talking about passenger, so this will be an alternative to short haul flight for cities situated 100 to 500 kilometers apart. Pardon me for that mistake. Now this will allow for flexible living and workplace choice. Now getting back to the first slide where I mentioned that the tier 2 and tier 3 cities are expanding rapidly. And this is because that a mass number of people are flocking from these regions to get into the cities for growth opportunities and job opportunities. But with Hyperloop, we might not have to do this. People can stay in tier 3 cities, get onto Hyperloop and come into tier 2 cities for jobs or for other opportunities. And hence this decreases the load on urban resources that these cities have, because at this stage we are at the limit that we cannot expand the tier 1 cities of the country anymore. So this will be an ideal combination of air and rail travel, wherein you have the comfort of railways and the easiness of the railways, while at the same time you are traveling at the speed of airways. So the part 2 realization, or how we see Hyperloop should be implemented. This is an overall brief, not getting very deep into it. So after the 2013 white paper, in 2015 a lot of startups started popping up across Europe and US. In 2018 we tested our first LIM motor for Hyperloop prototype. We developed a subscale prototype model in 2020. We tested it and also presented it at some competitions. By the end of next year, we are targeting to develop a 100-meter full-scale pilot setup around 3.2 meters in diameter, which will act as a POC in order to showcase our technologies. And by 2026, early 2026, we are targeting a small pilot demonstrator around 10 to 12 kilometers, which can showcase the cargo handling and movement of containers. So in between these two milestones, we are assuming, or we are at least considering, that a Hyperloop standardization committee will be in place, and this committee will till then have placed a good amount of regulation and standardization, so that by 2030 we can have India's first full-scale passenger Hyperloop demonstrator, which can connect cities 100-200 kilometers set apart. By 2040, we have the first regional Hyperloop corridor. In the image you can see is the proposal that we have given to the government of Maharashtra, wherein we can connect the cities within the state. And by 2050, we can have a Hyperloop network across India, which I'll be coming on to the next slide. So the pilot setup that we are developing will be a 100-meter vacuum tube track infrastructure. It will deploy all the commercial technologies that I mentioned, which includes the LSM, the semi-active levitation, the pod, and the vehicle itself. It will showcase the feasibility of full-scale and implementation, because at this stage it is also necessary that we showcase the technology of Hyperloop at a full scale, that is 1:1. And this can act as a benchmark structure for standardization and compliances for our country. And not to mention, this will also be the world's first full-scale cargo Hyperloop track, as in with a diameter of 3.2 meters, this will be one of the biggest Hyperloop pilot setup in the world. So the Hyperloop for India, or the global vision, the full-scale vision for 2050 that we have. In the image you can see that we have connected up around 28 Tier 1, Tier 2 and Tier 3 cities. This could be 11,000 kilometers of Hyperloop network, and the infrastructure cost to develop this would be close to $220 billion. With this kind of a network, we can expect a 54.6% reduction in the cargo logistic cost, and around 481 million passengers can be supported by this network annually. Now, to give you a comparison, the domestic aircraft industry currently supports 300 million in our country. So this is far more than that as well. With this network, we can have employment opportunities for more than 1.5 lakh people, that is active and inactive. And the decrease in average travel time between two cities will be by a huge 78%. Now, talking about the core team who are behind this, I myself am the Chief Executive Officer and the co-founder of the company. I am a BTech in Mechanical Engineering. I have an MBA in Financial Management. I worked for DRDO over a year in the Composite Research and Development as well. I've been working in the Hyperloop industry for the past 5 years as a research unit, now as an industry. Karthik Kulkarni is the Chief Operating Officer of the company. He's a BTech in Civil Engineering. He has a Master's in Advanced Construction Management. He also he has worked with the Pune Metro project, which is ongoing right now. Anirudh Atigre is the Chief Technology Officer, specializing in electromagnetic development for the team. He was responsible for developing multiple linear, synchronous and linear induction motors for the team. Kadambi Prasanna, he's present here. He's the Chief Technology Officer of the company. He's also a mechanical engineer and is responsible in working with various automotive companies for two-wheeler electric vehicle development. Now, in terms of advisors, we have Dr. Bala Bharadwaj. He is the VP of Engineering and Development for us at Quintrans. He has more than 40 years of experience in aerospace and mobility. He was the former president at SAE India, Society of Automotive Engineers, and he was also the former MD at Boeing Technical Center India. He is also present here with us today. We have Dr. Srinivas Mantrala. He is the VP of AFCON's infrastructure, and he has more than 30 years of experience in infrastructure, especially in railways. I think some of you might be knowing him. He was also involved with the Chenab bridge that was under construction. We also have Mr. Joel Michael. He is currently the head of business strategy for us. Joel was the former MD of Hyperloop Transportation Technologies. He worked with them for around 5 years. He was responsible for the Abu Dhabi-Dubai Hyperloop that was signed between the government and HDD. Currently, he is also seeing and helping us to expand globally and see in which other countries we can use this technology. And lastly, we have Dr. Prasad Khandekar. He is the Dean at MIT. So we set out with the vision and mission to develop a network of Hyperloop in India, get the first cargo Hyperloop running on a 10-12 kilometer pilot setup by end of 2025, early 2026, and get the first passenger pod running by 2030. So this is it from my side. Thank you so much for hearing me. I would also take this opportunity to thank Dr. Hemant Kabra for initiating such a huge conference, and I think this is something that we should be doing more often. Thank you so much, sir.
Thank you, Pranay. And Thank you for airing your views about what exactly Quintrans is all about and what are the aspirations and requirements of the nascent Hyperloop industry which is just taking shape in India. Thank you. As usual, we'll save the questions for the plenary session. And now we have our second speaker of this afternoon, Mr. R. Balaji from Messrs. Tutor Hyperloop Chennai. Mr. Balaji, would you please come on the stage? Messrs. Tutor Hyperloop is incubated at the Indian Institute of Technology, Madras, and works out of ITM Research Park. The company's endeavor is to provide customers with fast and reliable on-demand transport that is both affordable and greener in comparison with other modes of transport. And to this end, it seeks to develop Hyperloop technologies for deployment across the globe. The founding team has significant experience in automotive and aerospace technologies and has a proven track record of building and scaling businesses. Talking of Mr. Balaji, Mr. R. Balaji is the CEO of Messrs. Tutor Hyperloop. Also, he is a partner with Social Venture Partners, SVP, a platform for hands-on individual philanthropy. Prior to joining Tutor, he headed the merger and acquisition function, lead investments, strategy and marketing functions of all the financial services business of Mahindra Group at the Mahindra Finance. Before joining the Mahindra Group, he has been associated with sales and marketing roles in the consumer goods industry across ITC, Agrotech and Nestle. So over to you, Mr. Balaji.
Thank you, Dr. Kagra. A very warm good afternoon to all of you. And this morning when I was listening to all the presentations, right, all the student teams were very audacious in their thinking, and it made us wonder whether we were under-imagining the potential of what we could do. Very warm applause to each and every one of you for your ability to envision the future. So in light of what Professor Satya had spoken, he laid out what Hyperloop technology is, plus in what you have presented, right? It would be very futile for me to attempt to say this is the technology and this is what we are seeking to do. So therefore I would attempt to take a step back and share with you all what is it that we are envisaging, not in the technical sense, but in a holistic sense, and set out a couple of things that we all can do together. So Tutor, all of you might be wondering, right, what is the name Tutor? We are a bunch of old people, so we are not very creative. So we said, let's make it a virtue out of a necessity. Tutor is a short form for tube transport. Since a pod is going to travel inside a tube, so let's crunch it and call it Tutor. So the reason why is, basically since the evolution of human beings, mobility has always been increasing, and in the last 70 years it's increased by more than 40 times. Today, for example, when we were growing up, which was much before when most of you guys in the room were born, there was a thing like an apple season, a grape season, an orange season. We never had kiwi fruits, any of such things. But today you can get apple 12 months of the year, you can get all the fruits all of the year. This is because communication has made things possible. It's easy to get goods from all parts of the world, and more so if you want to travel anywhere, it's easier to travel. But what does it mean? It's the age of instant gratification, and here I think the same point has been covered by the Hyperloop India team of BRICS. When they say, right, the faster you go, the more pollution you cause, etc. Not only is it more expensive, but it's also more polluting. The cheapest form of transportation, that is ocean-based or water-based transportation, is also the slowest, whereas the air transportation, while being fast, it's also the most polluting. Second thing, as we go faster, sometimes if you want a slightly less polluting option, we lose the flexibility in terms of travel per se. And therefore, what is it that we can do to do it? And this is what Professor Satya spoke about it. This is a slide, albeit in a slightly different colors per se. So this Hyperloop is better because there's no energy loss due to wheel friction and also due to no reduced energy loss due to air drag. So this is what we're setting out to do. It's self-evident, but I would like to lay emphasis on few keywords. It's on demand, and on demand is very, very important. Because currently in India, right, we are embarking on a new slew of infrastructure initiatives. High-speed rail is one. And if we actually compare the system capacity of a high-speed rail vis-a-vis Hyperloop corridor, the system capacity would more or less be similar. Then we may wonder, right, why do we require a new sort of technology? The fact is, if you take, say, for example, Mumbai to Ahmedabad in 2026 or 27, if you miss the 8 o'clock train, you'll have to wait for an hour or two for the next train. But whereas in the Hyperloop, since a pod comes every 2 minutes, it's on demand. That's very, very important. Two, it is good for the planet. It is possibly the most energy efficient form of surface transportation. It will be close to 1/5 to 1/6 of road transportation and half of rail transportation. And it's good for the pocket. When I say good for the pocket, right, comparable to similar forms of transportation. It's very grandiose to say, right, we can travel from Mumbai to Ahmedabad in 30 minutes or Mumbai to Pune in 20 minutes. But most of us go to work for everyday living. I come from Mumbai, and I'm not sure how many of you are from Mumbai, but if you want to take a taxi, for example, from Thane to BKC, it's a distance of 26-27 kilometers, and it takes 1.5 hours if you're lucky. Sometimes it may take 2 hours. And just on fuel, you'll be spending close to 2.5 to 3 liters of fuel. You'll be spending close to 250 to 300 bucks on fuel. Just imagine, you don't have to go for very high speeds. Even if you're able to have a lower speed of starting with 150 kilometers per hour, in 15 minutes, you'll be able to reach that. And for the price of less than $1 of your fuel. That's what makes this much more appealing. And this is what we are seeking to do. And one other thing which makes it very important and interesting is it's autonomous. And why is autonomous very important in a country like India, you might be asking. Because India is a country where there's a lot of youth and we need to create jobs, but why is that? But if you look at it paradoxically in the transportation sector, which is required to move goods and move people, right? The availability of manpower is reduced. If you take heavy commercial vehicles, in 1985, for every one heavy commercial vehicle, there were 1.3 drivers. Today, for every single heavy commercial vehicle, is only 0.9 drivers. There's an acute shortage of manpower to do physical activities. And that's what, if having an autonomous form of transportation, it would help you to ensure that the operations work, function 24/7, 365 days of a year. So this is the founding team. So I'm the only non-doctorate in the founding team. Professor Satya, as you see, is one of the founding members. The other founding member who's not is Dr. Arvind Bharadwaj. He was earlier the Chief Technology Officer of, again, Mahindra and Mahindra, but that had nothing to do with this. I knew him personally and Satya also knew him personally. He was also an executive director with Ashok Leyland, and before that, he was at General Motors Research Center in the US. So the three of us got together and have been working on it for the last 14.5 to 15 months. Now, any new technology is very fascinating and interesting. So, initially when I was speaking to one of the industry leaders, he said, are you guys working on a technology that is in search of a solution, or are you going to focus on solving a relevant real world problem? So we said, well, technology aspect is that, let's go out to the outside world and understand what the customers or the users of various industries are requiring. We spoke to the ports. And today if you look at it, right, the average turnaround time for a ship at the Indian port is close to 2.7 days. The global average is less than 0.9 days. It's 3 times the global average. And if you compare, the most efficient ports are in Japan, where the average turnaround time for a ship is 0.35 days. The best in class Indian port comes to close to a day. Now there's a lot of inefficiencies, and there's also a physical problem. The problem is because the loading and unloading takes a huge amount of time. Now if you take some of the older ports, right, the Chennai port or the Mumbai port or the Kolkata port, the city has grown around the port and there is no space for the port to expand. Nearly 80% of the space inside the port is occupied by the goods either waiting to be loaded onto a ship or after being unloaded, waiting to be taken out. Now the issues in the hands of the port official is, How can I move the goods fast? Because currently there are two modes by which goods are moved out of a port or moved into a port. Through a rail, in which case a goods train where 70 to 80 wagons are loaded. Therefore, the loading process itself takes a huge amount of time. Or sometimes if it's loaded onto a trucks, right? They load multiple trucks and a convoy of trucks goes out. How it would be if one container could be moved at a time? So therefore, then the problem becomes slightly different. Transportation is only one part of the problem. How do you load multiple containers in a very fast manner so that we are able to move out? And we did some modeling studies, and we believe, at least one of the ports whom we are speaking to, right, we can achieve a 40% improvement in productivity. Therefore, the proposition to them is, currently you are spending 2.7 days to turn around the ship. We can bring it down to 1.5 to 1.6 days. That makes sense. Mining, cement. If you buy a bag of cement in anywhere away from the risk, the single biggest cost you pay in a bag of cement is the logistics cost. So how could in such a low value commodity a Hyperloop corridor become important, or even the other minings? Mining is a polluting activity, and most of the mines are situated in ecologically sensitive areas. There are few things that could be done to reduce pollution at source. But then from the mine to the processing plant, when goods needs to be transported, right, there will be impact on the wildlife and the impact on the ecologically sensitive areas. So if you have a closed corridor, the impact on the flora and fauna would be very minimal, and this would make sense. Yes, there is going to be an incremental cost involved on top compared to the other modes of existing modes of transportation. But the benefit that you get is twofold. One, the environmental approvals would come in a much faster manner. So instead of waiting for 3 years for an approval, it would come in 1.5 or 2 years. And therefore the cash flow starts coming faster, therefore it makes it easier, project becomes more viable. And two, more importantly, since you are much cleaner, you are seen as a very important environment conscious organization. Today ESG objectives are becoming more and more important. Then three, we spoke to exporters, garment exporters, auto components exporters, horticultural exporters. Each of them are actually bemused by the lack of predictability in terms of the supply chain. How can we make things move faster in a more predictable manner? If you take Hyundai for example, they export a lot of cars from the Chennai port, and the cars from the factory to the port travels a distance of 65 odd kilometers. Normally it takes 3.5 to 4 hours. In a few instances it takes 13 to 14 hours, they get stuck in a jam. How could the transportation be seamless so that the entire supply chain could be managed more efficiently? This led us to think, okay, there are a lot of significant problems and this seems to be good to work. So here when we say, right, let's take a step back and see how the railways evolve. Today when we think of railways, obviously I'm in a railway institute, I hope I'm not carrying coal to Newcastle, but when we look at how the railways function, right, it's like an engine or a prime mover transporting a slew of coaches either carrying people or cargo. The first railways were in the late 18th century, 1770, 1780. Garages were traveling on tracks, but they were pulled by horses, not by any mechanical device. They were pulled by horses. So that's how then slowly we got into the engines per se. In fact, when the first railway, commercial railway operations, right, Robert Stephenson's sprocket was introduced, when it was going on its first line, it was functioning, right, a horseman used to ride in front of the train, warning people to get out of the way that's coming. And this is a scene from the US, a depiction. In 1830, there was a race between a locomotive pulling carriage, people, and a horse-drawn carriage. And guess who won? The horse-drawn carriage was more faster compared to the locomotive. Why am I saying this? Hyperloop is similarly in a nascent form of technology. Based on the product performance compared to the other alternate modes of transportation, we cannot draw any conclusion saying this is not efficient or this is not feasible for this. We need to give it time for this technology to mature. Otherwise, it'll be like throwing out the baby with the bathwater. So what we are doing, right, is nothing very fancy. We are going to focus on goods transportation initially. Here again, why goods transportation? Why not people? People transportation is a sexier part of transportation. It's more glamorous, more salient, and more importantly, earns more revenue per kilometer compared to passenger transportation, Indian Railways excluded. The reason is, if you take TGV, right? TGV made its debut in 1992 in Europe. But almost all the technologies were developed and ready for commercialization as early as early 60s. It took them close to 3 decades to get the regulator to give them approval, for them to convince the regulator that it's a safe form of transportation. So now we cannot wait for this time, and COVID has shown that the time to develop a new vaccine can be reduced. So how can we reduce the time taken for development to convince the regulator? 2 things we could do. One is ensure that the functional performance is appropriate. The product is safe functionally. It does not endanger the immediate surroundings, etc. That is one. 2, it is reliable. So let's focus on cargo transportation. As long as it's reliable, the customers should be happy. And even in the unfortunate event that a pod gets stuck, it's not going to create page 3 or page 1 news anyway. So we said let's focus on cargo transportation. And another fundamental thing, right, compared to cargo transportation, compared to human transportation, for passenger transportation, the alternate modes of transportation are very highly developed. If I want to go from point A to point B, I can take a car, it's very convenient. On a highway I can go today the quality of the highways has improved, 80 to 100 kilometers per hour, and all these things are there. So therefore for Hyperloop to compete effectively with other forms of transportation, we require speeds of at least 300 to 400 kilometers per hour. And the initial stages it would be very, very tough. But if you're going the product development cycle, for cargo transportation, even when the initial speeds are as low as 150 kilometers per hour, it's value accretive for the customer. Today the average speeds on the highway, despite very good roads, GST therefore lot of checkpoints removed, it's only 35 to 40 kilometers per hour. An average truck in India even today does not cover in an 8-hour cycle 350 kilometers per hour, in a 350 kilometers. So if we can start with the lower performance and demonstrate reliability, demonstrate safety, and move on to the passenger subsequently. So what we are doing, like what Professor Satya said and Mr. Sudhir Srivastava also alluded to, Indian Railways has given a grant to IIT Madras, so there a 400 to 500 meter tube is going to be constructed. Proof of concept tube. This would be ready by December of next year. In parallel, we have started work on designing a 10 kilometer one for a cargo. And this we are using for a use case where it can solve a real life problem. We are talking to a couple of ports so that we can work on to it. Because who wants to spend so many crores of money in just developing technology? We are not the Ambanis or the Adanis where we can put some 1,500 crores into development and that returns do not matter. So this is what we are going to do. And once we do this, right, by 2026, then the market opens up. And then we can use it for other similar corridors for transportation or get into newer use cases. And finally, as the technology matures and we are able to showcase performance, safety and reliability, then we can get into human transportation. The way we see it, right, this decade, that is till 2030, is primarily going to be a decade of product development. We are going to ensure that the product development happens properly and have some 1 or 2 pilot corridors to show that not only is the product technologically feasible, there are also some economic feasibility with this technology. And then once the technology is done, right, we are all small startups. Ultimately, all the Hyperloop startups in the country are small. We do not have the wherewithal to implement large projects. Just to put it right, when Pranay was presenting, this corridor, one could assume that, see from the slides, that it costs approximately $20 million per kilometer. And if you want to put 150 kilometers between Mumbai to Pune, it's going to cost close to 3,000 million or $3 billion. Who's going to have such money? And two, developing technology is one, developing technology is 0 to 1, but implementing on the ground is from 1 to n or 1 to infinity. So who's going to have that capacity? We do not have the capacity to implement large-scale projects. So the best way is to become a technology provider, license out that technology. L&T can construct it on the ground for you, Mitchell overseas, or Tata projects. Lots of people are there. So become a technology provider. That's the primary thing. Second, fundamentally what we are doing in this quest to develop the fifth mode of transportation is, we are solving a whole host of engineering problems. And these problems would find resonance in different parts of the industry, and therefore you want to be able to generate a lot of IP and then want to be able to leverage it or monetize it. So this is the proof of concept tube, and for this tube, which will take around 10 kilometers for a real life use case, we expect it to cost some 1,500 crore rupees. That's what we're trying to do. And our use case is the tube should cost to be able to transport a 20-foot container having a cargo of 20 tons. That's the average weight transported by a 20-foot container. And then we'll be moving on to other things progressively. Now while we are there, right, Dr. Kagra's initiative is that how do we further the development of Hyperloop technologies in the country? There are 2 or 3 key issues, at least to our limited understanding. One, it's a long gestation as far as technology is concerned. We need to start thinking in very long time frame. I remember in last November, I and Dr. Arvind were meeting one of the industry leaders. So he looks at us and says, okay, fine, I understand what you're attempting to do. When do you think you will make money? We thought, okay, fine, we're being very, very realistic and said, not for the next 6-7 years. He looks at it and says, I think you're underestimating. You must understand for the next 20 years you will not make money. And I think that's the reality. If somebody thinks that we can start coming in and start moving out next few years, it's not going to work. We are at the cusp of a new technology development. And here, I would like to share an example from the renewable energy. In 1992, the first global convention on climate change was held at Paris. In 1992, the contribution of fossil fuel to the total energy usage in the globe was 86.7%. Since then, lot of song and dance has been made on climate change, focus on renewable energy, and people have grown. In 2017, 25 years after 1992, the share of fossil fuels in total energy global consumption was 85.2%. In 25 years, 1.5% reduction in fossil fuels. Despite the fact in the same period, the global energy consumption increased by more than 17%. So similarly, right, if you want to look at Hyperloop development, this will be the decade till 2030, decade for product development. 30s to 40s will be initial small corridors, so that we show that it's economically feasible, assuage public concerns, both real and perceptual on safety and other parameters. And finally, after 2040s, when there will be mass scale adoption of it from 40, 50, 60 onwards. Therefore, one must be prepared to play for the long term. If that's the case, investors would be saying, right, it's very capital intensive, very long drawn out. What is my exit option? I'm stuck, right? I've put in a pot of money, and what is it? And from the customer's viewpoint, right, the implementation. When I say customers, I'm using it in a very, very broad sense. It could be the governments, it could be the landowners whose land is taken for right of way, the end users, the business players if you're getting into cargo transportation. That's a different sort of thing. So to do it, right, one of the first way, if you have to look at technology, right, stronger industry and academic partnership, it's very, very important. What we have been doing, at least, we are a small startup. We are housed within IIT Madras. We are fortunate for that, so we got a lot of access. But more importantly, what we have done in the last 5-6 months, we established a working dialogue with the other Hyperloop startups around the world, with Virgin or Hyperloop One, with ART and with Eurotube, etc. We recognize sharing is caring. Sharing reduces the risk of failure at a later stage. That's what we are trying to do. And we agree that it might not be everybody might not be willing to share what are they exactly doing and what are they working on, what are the successes, but we agreed to share that what are our failures. This is because it's not like, for example, Tutor is going to compete with Twin Strands or with Hyperloop One or Heart or anybody else. It's the entire Hyperloop industry competing with other forms of mobility. It's nothing like the David versus a Goliath. They're not even a David. They're an infant David versus a big Goliath. And therefore, the better that everybody collaborates with each other, shares the information, shares their learning, so that they're able to increase the probability of success. The second thing, right, this technology is very nascent. And if it's nascent technology with high risk of failure, the financial investor is not going to be very, very interested. So therefore, there has to be increased access to grants. And that's something today in the entire ecosystem, things are evolving, and that's what grant capital will propel the growth of this industry. And for example, IIT Madras, right, Indian Railways is a big supporter of this, and when the Railway Minister came to IIT Madras, he spoke about how in this year's budget they allocated 5,000 crores for new technologies, something which Mr. Sudhir Srivastava also mentioned about it. And there are such grants that people should collaborate, work on to further the cause of technology. Play for the long term, don't play for 6 months or 1 year. How do we ensure sustainability? And finally, create a viable policy framework. And that's very, very important. And today again, I'm not sure whether this slide was made before and wrote onto this laptop. Mr. Sudhir Srivastava also spoke about it, right? From Railway Act probably needs to be amended before Hyperloop comes under this. So there should be no ambiguity out there. But in the shorter term, ambiguity could actually benefit all the startups in this place, whether it be student teams or academic institutions or this, because you can have more people to give you funds, etc. That we can go out to them and get support, etc. So this is what I wanted to share. But only thing I would like to end with saying is, bringing this technology into life is like climbing a tall mountain peak, and one is not even at the base camp sort of a thing. One has at this point of time made a decision, okay, I'm going to attempt to go on this, climb Mount Everest or something. Now one needs to get the preparation and then subsequently get onto the base camp and then go up subsequently. So it's going to be a long and interesting journey, and wish all of you an exciting way forward. Thank you.
Thank you, Mr. Balaji, for an interesting take on the road ahead and letting us know what exactly Tutor is all about and what Tutor is expecting out of the Hyperloop. Our next speaker is Shri Pramod Rao from Bangalore International Airport Limited, Bangalore. Unfortunately, due to a last moment engagement, he was not able to come physically, but he has kindly consented to be able to speak to us through video conferencing. Hello Pramod, how are you?
Hi, I'm fine. Can you hear me?
Yeah, we can hear you loud and clear. And welcome to this conference on Hyperloop and transport system, an Indian perspective. First, let me introduce you. Bangalore International Airport Limited, as you all know, is a public limited company formed to build, own and operate Bangaluru's greenfield, private sector-owned and operated airport, the Kampagoda International Airport, Bangalore. The airport was constructed through a public-private partnership, a first for airports in India. Shri Pramod Rao is the head of customer experience and terminal operations at Bangalore International Airport. He has more than 13 years of experience of industry and consulting across functions working with the C-suite. He has previously worked with BIL on building a world-class infrastructure, a customer-centric organization, a technologically advanced airport. So over to you, Pramod, and we are eager to listen to you. Please start sharing your slide.
Thank you, Dr. Hemant, and thank you to all the speakers. I was just listening to Balaji, at his best, and also at the end of the presentation, you'll also see many of our thoughts echo. So thank you, everyone, and very good evening. I have been fortunate to be part of the Hyperloop ecosystem. I'm kind of managing the Hyperloop program that we have at BIL. So what I'll do is I'll quickly try to take you through what we believe is the Hyperloop industry and the way forward in India. Can you see my tech now?
Yes.
Perfect. So I'll try to keep it as simple and focused as possible. So the entire agenda is split into just 3 parts. The first is the new India, the dream of our Honorable Prime Minister and how the dream is coming to be a reality and what those realities entail. The second is how Hyperloop fits into that new India dream. And finally, what I'll conclude by talking about what we as BIL are doing to enable that transition, or let's say creating the Hyperloop industry in India. So if you would have already heard quite a few times that we are aiming to be a $5 trillion economy, and that is very much feasible. We see that happening sooner than later, and that means that 70% of the new employment that's going to happen in India will be in cities. Now just to compare that figure, the total population of just these cities in India will be twice that of the entire US, and India will have 68 cities with more than 1 million population. And that compares to only 35 in the entire Europe today. Europe, as you know, is one of the most developed ecosystems. It has the most number of cities. Every country has so many cities that you would visit. And India alone will have 68 cities with more than 1 million population, whereas the entire Europe has only 35 today. Now, all this development will come at a cost. That cost is estimated to be, so this entire data is from a report from McKinsey. And this entire cost to enable this growth will be estimated around $1.2 trillion. And all of that is capital investment alone. Operating expenses is separate. Now, if you look at where that expenditure is largely going to go, it is going into commercial, and apart from commercial and residential landscape area, 2.5 billion square meters of roads and 7,400 kilometers of metros and railways. So as you see, mass transit and transportation infrastructure is the key focus of this entire, key thing that will enable this entire growth in India. Now, moving on, so how does this expenditure break up into? So if you look at it, this 1.2 trillion is broken up into these categories here, as you can see. So around 600 billion of this investment which is around 50% of all that investment is going to be focused on mass transit and roads. So that is the kind of focus that transportation infrastructure is going to have in terms of enabling this growth for India. So if you further look at in this slide, if you focus on the left side, so today the focus is largely to develop the existing cities. If you see, the maximum spend today is happening in existing 4 or 5 or 6 metro cities that we have. However, the research and history shows us that the current level of gap that you have between demand and supply of basic services like water, sewage, solid waste, roads, etc. is only going to widen with the cities growing further. So that is what is shown in the leftmost side of this slide. In the middle, what you see is that capital spending required in tier 1 cities is much higher than the capital spending required in T2 cities to maintain the same level of service. Which means if you spend $1 in a tier 2 city, it will reap far more benefits than you spend that $1 in a tier 1 city. Now that is evident historically as well. That is what is captured in the rightmost slide, part of the slide, which means for a tier 1 city, the per capita per annum, which means per annum what the government spends on the city per person is around $130. And that has resulted in a growth of 8.3% growth for that during that duration of 99 to 2006. At the same time, a tier 2 city, the spend was 1/4, close to $40. And an equivalent growth or even higher growth of 8.4% was achieved, which means from a government and state perspective, investing in tier 2 cities gives you far better returns than investing in tier 1 cities today. So let's take Bangalore for example. So Bangalore is bursting at its seams. So the image you see on the left is all red already. This is from 2006, this is government data. Today if you look at it, it will be entirely red. Now, if you look at the table above, the population density of Bangalore is almost 10 times that of Bangalore rural and Mysore. But at the same time, the per capita income is almost okay, but the contribution to GDP is much lower from these regions. The main reason why is that although some people are still staying there and working in these cities, the connectivity and productivity loss of movement between these regions causes people not to stay there, and hence everyone stays in cities and the cost of living in cities goes up. So there is significant scope to improve the connectivity between these regions and enhance the growth of cities and states. So if you just conclude, if there are 5 focus areas for states and cities today, one is to decongest the city, second is to enhance productivity, third is to spur economic activity, fourth is to develop more cities, which is convert tier 2 towns into cities, and provide affordability to more. And Hyperloop beautifully sits into this requirement of states and cities. So I'll just show you how. So before we move on in terms of looking at how Hyperloop serves this need, these are examples. If you look at it across the world, high-speed rail and connectivity has really helped the development of certain cities. These are just few examples of those. Entire Europe is an example of how the entire region is connected within a 2 to 3 hour connectivity, enabling people to stay in one place and work in another, and thus creating it's a multi-city system rather than isolated cities in themselves. So that for us to learn from these cities for us in India. India is an ideal test bed and product market fit for Hyperloop. So now let's come to Hyperloop, how Hyperloop fits into all of this. So the present generation's need are 3 S's: speed, safety and sustainability. And Hyperloop being on demand, high speed, point to point and high capacity, and at the same time being sustainable because of lower carbon footprint by the very nature of its technology, perfectly fits into this demand. And hence Hyperloop also, while there is much to be achieved between now and actually having a commercial product in place, Hyperloop was already called as the 5th mode of transportation because these inherent nature of this transportation promise caters perfectly well to the demand that we have across the world today. So now let's look at where Hyperloop industry is today. So various companies, various geographies across the world, the need is established, a concept has been developed, and product market fit, like I just explained, is perfectly there. The MVP also, the minimum viable product, is also built in various parts of the country. In the US, you have 2 or 3 in Europe, etc. Now this entire industry is currently at a stage where different companies have taken different strategies on how to move forward and how to implement this. So have governments and states and the rest of the industry. So everybody is thinking about how to move this forward, how to get this running, how do we all contribute and be part of this. And there is only one way, which is where I also repeat what Balaji was saying, that collaboration is key in terms of taking this forward. And not just collaboration, it has to be focused. If we all have to come to a mutual agreement on how we can make India really an export bed for Hyperloop, and also use Hyperloop to get to that 5 trillion economy sooner than before. Now, what does that mean? So, according to us, there are 3 C's that are important that can help fast-tracking Hyperloop implementation in India, or let's say first C is clarity, and this is fundamental, right? And within clarity, the first thing is regulatory. So government and leading institutes have to come together along with the rest of the industry which is already there to define the regulation for Hyperloop to become a reality. Today we are still figuring out which ministry will do what should aviation rules apply, aviation safety rules, security rules apply to Hyperloop, or should it be rail rules and policies that should apply. So we now have to converge together in terms of identifying what that regulatory philosophy is, and we need to do this fast. Today it's a sort of a chicken and egg story that first let's figure out what the product is, let's implement something and then figure out the regulatory. But on the other side, the industry is not clear. If I implement something today and regulation turns out to be something else, my entire investments go for a toss. So regulatory clarity is key. Second is technology clarity, and this is where I think Hyperloop companies, we have several companies today. However, the technology of each company seems to be different. So from an industry perspective, what we would really want to see is that if I choose a tutor to be my implementation partner, tomorrow I should have the ability to use, let's say, an Avishkar or Quintrans in the same system. It shouldn't be that the interoperability is key for Hyperloop to really progress and make industry feel comfortable to support and take this forward. So technology clarity is also another key aspect. Third is business clarity, and this is where all of us will have to also work together to make sure that we understand the costs involved. India is a highly price sensitive market. So Hyperloop, whether it's for cargo or passenger, has to meet certain levels of commercial viability. And to achieve that, there is the other 2 aspects, which is the regulatory and technology clarity, which also means the regulatory and technology costs that will lead to these business cases. So clarity is the first aspect, and the second C is certainty. And when it comes to certainty, I split it into from the perspective of 3 different parties. So first is the first mover. Whoever is the first mover in this entire making Hyperloop a reality, they need risk mitigation. So if someone is taking that onus of building the last Hyperloop, they must also have a risk mitigation support by the government in terms of either subsidies or protecting from downsides, basically. So someone is putting money, which is all, let's say, shareholder money into a project, the downsides have to be protected. And to that effect, governments will have to play a role in ensuring this risk mitigation certainty for the implementers and the industry. Second is commercial certainty. Now let's say we do a POC or MVP is built again after spending a lot of money on it. What happens then? So there must be some certainty to the investor and sponsor or the government on benefits by supporting a pilot project. For example, we are supporting a POC project as we speak. How will that further benefit the industry or the person who is sponsoring it? That has to be clear, and here again the role of governments and the investors and the Hyperloop companies will play a major role. The third certainty is timelines. Like all projects, timelines are always a concern. Having said that, for any industry person or the government or an investor to come and put money in it, project timelines and certainty of product development roadmap is very important. And today slightly that is lacking, and which is a second important aspect in certainty that needs to be sorted. Third C is commitment. Now, once clarity and certainty is established, we need commitment from the government first to support and enable a pilot project, which means the first commercial project to make it happen. Because we have certain processes, Swiss challenge or whatever, those have to be clear from the government side, and that commitment has to be there. Otherwise, there is no, let's say, commercial benefit from the investor or the industry's perspective to go ahead with a POC project. So POC, if it is a standalone project, doesn't mean anything. It's basically a cost thing. So it has to convert into a larger pilot or an actual commercial project. And the examples today are in Canada. What they're doing is they have a plan to build a connectivity between the airport and the city and a second airport finally. But they're starting with a POC. So that POC, once it is proven successful, the company that is investing in that POC also gets to build this entire project. So that is what I mean by commitment from the government to enable or incentivize those pilot POCs. Second is commitment from investors, that today investors are investing just in technology. So we need also investors to come together and believe and invest in projects, because technology is one aspect. Technology will not see the light of the day till an actual project hits the ground. So we need investors to really back up these technologies and trust in these new startups that have come together with a promise, and help them implement these projects. And finally, the technology providers, that the commitment to converge on technology and share the pie is also very critical. Now, I'll close by taking you through what we are doing at VIN. So today we are, as we speak, we have decided to do a POC. Now, in doing a POC, we really look forward to this collaborative way of coming together. So what we have decided to do is to bring together an ecosystem partners to implement the Hyperloop program. Now, when I say ecosystem partners, it is the Hyperloop technology provider, it is the EPC companies who will build the infrastructure, whether it is automotive or aerospace companies that can build the pods, companies who do the signaling, fleet management, etc., to come and build the, let's say, the control systems behind it, investors. So all these companies are what come under the ambit of ecosystem partners. So all of us come together as consortium. What's in it for each of this company? You become the first mover in the space, and you get a guarantee from the government or whoever it is to build a larger project. So that is what in it for the people who come and participate. And what this will help is three things. One, it helps to create the Hyperloop ecosystem in India, which also helps us to scale this up anywhere in India and outside. And it de-risks investment by just one agency, because here the risk is spread out. Every party will bring their own money, have the risk and reward for what they bring in. And that will enable also the government to have more confidence, saying that, okay, these are all the large things that come together, and hence I have more confidence in this happening, so let me also back it up by providing them assurance of a long-term project if this becomes successful. This also enables the regulatory and commercial construct to be proven through this POC. So the way we envision this is for an advisory board to how to go about this, the academia to come together in terms of advising on making this cost effective, to make it technology, simple technology, interoperable technology, cost effective, etc. Bring in the partner ecosystem and the funders and investors, all of this becoming the Hyperloop launchpad for India. So that is what we are currently working on. And as you see, a lot is dependent on how the industry sees it, the rest of the industry. This is the way we see it. Now, it all depends upon how the rest of the industry sees it, and for the government to look at it and support it. So, with that, I think I'll close and open the floor for questions if any. Thank you, Dr. Hemant.
And since Sri Pramod Rao would not be available for the plenary session, we can take questions pertaining to him. Any questions for him? Are you not wondering what a airport is doing for Hyperloop? Okay, so no questions. That means two things: either people are very skeptical, or they are really convinced. So thank you, Pramod.
No problem. Anybody can reach me on LinkedIn. Very much active there. So if you have any questions, any ideas to share, happy to share.
Okay, thank you. Thank you, Pramod, for joining us through VC.
Thank you, everyone. Thank you. Thank you for the invitation, and I hope you had a brilliant conference. I think the onus is on all of us to make sure India is a leader in Hyperloop, so let's make it happen.
Thank you. Yes. Thank you. With these, ladies and gentlemen, we conclude our fourth session that was pertaining to the requirements and aspirations of Hyperloop industry in India. And we listened to the representatives from Messrs. Quintrans, Messrs. Tutor Hyperloop, and Pramod Rao from BIAL. And now we'll have a short coffee break. We meet again at 6:45. I'm sorry, 16:45. That's 4:45. May I tell you? So we meet at 4:45, wherein we will be having our final and concluding plenary session.
कहाँ है रेड वाला कर दिया मोड मोड आपने किया डेमो मोड मैंने कहा डेमो मोड हाँ सर डब्लू से बड़ा होगा ना हाँ हल्का सा कर बड़ा 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 अरे छोटा कर रहा है तो उल्टा समझता है बस नहीं 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 फिर वो नहीं देख मैं बताता हूँ उसमें देख
Good afternoon, ladies and gentlemen. Please settle down. After the before going for coffee break, we were discussing the requirements and aspirations of Hyperloop industry in India. And after the coffee break, we are now on towards our final session, that is the plenary session, Hyperloop in India, the road ahead. And as Dr. Satya was just mentioning, instead of the word road, we should say the Hyperloop ahead. May I request Dr. S.R. Chakravarti, Professor IIT Madras, Shri Sudeep Srivastava, Executive Director S&T Gati Shakti Railway Board. From Messrs Quintrans, I would like to request Dr. Bala Bhardwaj and Kadambi Prasanna. Then I have Shri R. Balaji from Messrs Tutor Hyperloop Chennai. And then from Indian Hyperloop Committee, I have Purnesh Jain. Okay, sir. So, may I request you all, as the plenary session is all about that, it is about the road ahead. So, what do we think about? What are your views? What should be done now after this session? What should be done now? A lot of awareness has come in. So, what do we think? What are your views on this? We will start with Dr. Chakravarti.
Thank you very much. I think as I was saying just before we started, we want to see if we can synthesize all those roadmaps that we have seen through the day. I think all of us are pretty much talking about the same thing in different languages. So to me it seems like we need to focus on a minimum like a 10-kilometer track, right? And preferably it should have some bends, right? So that's the nature of the track that we should look for. That's the first thing that that comes to my mind. If we are able to actually get a 10-kilometer track going, we can do a lot of tests to the point of getting it up to passenger quality. But prior to that, we can actually test a lot of freight and dummy payloads and all that stuff. Now, the challenge there is who is going to actually build that CAT, right? So there are 2 or 3 ways of doing it. One, let's say, for example, the railways takes it up, and then they say, we just want to spend the money no matter what it is. And I will find a straight corridor with 1 or 2 bends, and we can put the money there, and then we get this tube. And typically this could be a railway line that is hardly getting used by any other train. It's not a busy corridor, which essentially means that this Hyperloop track will be a white elephant over time. Or it is designated as a test track that you keep on improving and evolving in technological means, and essentially put a board in front of it saying that this is the Global Hyperloop Development Center and so on. So dedicated, right? That means that you're not looking for getting any revenues out of that, but primarily for the technology development. However, if you now look at what Tutor is trying to do, or what Quintrans would try to do and so on, they are trying to take a little bit of a realistic path. That is, they want to pitch this as something that can generate some intermediate revenues so that they can get investor interest. So obviously then we have to actually do this particularly for freight. And that has to be some very specific niche freight corridors. Like for example, debottlenecking a port when a ship comes and then docks, and when you're trying to depot material, these containers will have to actually move away from that place. Or how do you actually move cars from the Chennai, the car manufacturers' parking lots onto the ships ASAP. So all of these kinds of specific problems require a Hyperloop type solution. It's not exactly Hyperloop, right? You may not require going at about 600 km/h. It may be sufficient to go at about 100 to 150 km/h. What is important is a dedicated corridor, secure corridor, that kind of thing. So the people who will actually put money into it may say, why do I want to bother about a Hyperloop? All I need is like a railway line, and I probably need bogies that are very similar to your train 18. There is, you have the drive attached to the wheels of every bogie, and you don't have to interconnect the bogies anymore. They are all independent. So you put a car or a container, and then it just keeps moving, right? So you don't have to wait for all the bogies to get filled up and all that stuff. So it's a different solution, and similarly, I think the airport solution, right? So we have talked to Bangalore Airport. They basically say, let's actually have a corridor from the city to the airport where we can first move baggage, and then we can think about moving passengers. We have talked to Cochin Airport. They have a similar problem. The airport is outside Kochi. It is somewhere near Kaladi. So how do you actually get people to check in the city and then take a bus or something like that? But all these things are actually somewhat contrived. What are the point in actually having the baggage arrive there early and then getting into the plane when the passengers are actually taking a bus, wading through crowded traffic, right, and then arriving later, and still have to go through a security check and all that. So it's not very clear what that particular use case would be. So to me, it seems like, as Balaji was saying, are we actually trying to find a problem for the solution in order to actually get some intermediate revenues and getting stuck doing this? Or is there a way by which we can pump prime this by, say, we will dump the money, don't worry about the revenue generation, get the technology up and going. If we get to a certain level of maturity that is good for freight, then we actually start implementing it for freight, and then keep pushing the technology further to get the safety standards required for humans. Then we will actually implement it for humans in realistic corridors. Right? That's a more academic way of doing it. And when I say academic, it means academics normally don't bother about where the money comes from. so if you take that approach, it's actually very clean. But unfortunately, I think there is a lack of clarity on how that 10 kilometer has to actually happen. If you are able to hammer that out, I think we have cracked the problem.
Thank you. So, Dr. Mata, do you think any challenges you would be facing in capturing the customers, as Dr. Satya has pointed out?
I think so. Yeah, sure. I think I have spent a very significant part of my life chasing technologies and connecting that technology to somebody who will pay. And usually the people who pay definitely look for something, right? It is not a donation to the technology developer. So in my mind, we are all in a great hurry these days. There was a time, even 2-3 decades ago, when we said, oh, we'll develop the technology, and people have given examples. Technology was developed, was sitting on the shelf for a long time, and then it took a very long time before it got implemented. I don't think we have that kind of patience anymore. So in my mind, the technology development should happen in some kind of a collaborative manner, where the potential customer is also involved. This is, in the US we have a word, I think Balaji used a similar word. We have something called the BHAG. It is the big, hairy, audacious goal, right? And I think this fits in that category. Absolutely. It is, the outcome when if it comes out, is wonderful. But then before you get to that point, you still have to go to the base camp, you have to climb the Mount Everest, and many people who try to go to the Everest never make it, right? They either come back or some of them even die along the way. So in order to deal with a big, hairy, audacious goal, you have to put our resources together. And when I say resources, I don't just mean money. I think we have a lot of enthusiasm here from the young people. We also have people who have matured thinking. They are asking the right questions about how do you take this technology and take it from a low level of maturity to a usable level of maturity. So the option that Satya just talked about, can you do development along the way? This is what software people do. Agile way of developing, right? Maybe we have to do that, because then the user feels like, hey, something is coming out of this and I can actually use it. May not be for the end result, but it is something I can use, and if I'm an investor, I may say, well, my first few millions produce something, so I'm comfortable investing a few more millions. And definitely, we have talked about regulatory aspect and those kinds of challenges. So this is not a university project. This is not an industry-only project at this point. I think it has to be a collaborative effort. I'm almost in sync with what Pramod Rao shared. You need those multiple players to come together. Now, when you take industry and say you come and collaborate, first thing they will say, hey, why should I give up something I have developed to somebody else?
Absolutely.
So there has to be a framework. We have done this, I come from the aerospace background. We have done this in aerospace. You will see regularly Boeing and Lockheed are competitors in many areas. But Boeing and Lockheed also collaborate and they have produced projects together. So you almost need a co-opetition kind of a scenario here, where you take the best ideas available in different places, bring them together. Now it's easier said than done, I know that. But I think if we put the will, and maybe railways is a good forum that can help us to do. I was very encouraged when Sudeep said we are open to creating more COEs and we really want to make this happen. So I think that will has to be there. Somebody like Sudeep has to hold all the stakeholders and say, hey, let's make this happen. This is how I can help. This is what you need to contribute. Timelines are important. So I think we have to think about this a little different. Not the usual, I have an idea, I'm going to take it from cradle to, full maturity. I think we have to say this problem is large enough, complex enough that let us put our minds together. I know it's not the normal thing that we all are trained to do, but I feel in this scenario it is probably a necessity.
So, co-option rather than collaboration, that should be the key effort which should be done.
That's how I look at it. It's collaboration, and I wrote down something else. Co-opetition. So it is, collaboration and competition together. So it's really, you need some kind of a consortium approach. So you bring the appropriate people together, frame from rules of engagement, so that everybody feels like they are getting something out of it. And collaboration by definition is that. I cannot come and collaborate with you where you get all the benefit and I lose.
Absolutely.
It has to be a win-win. The only thing is, if you have 4 people participating, it has to be a win-win-win-win. Every group should feel like I get more. It's like 2 plus 2 is more than 4. That's kind of what we're doing.
It has to be 22.
Yeah.
So Balaji, if I may ask you, what low-hanging fruits do you envisage in this journey ahead? Like when Dr. Bala is speaking about customer-orientedness, low-hanging, what we can achieve? That's the agile way of doing it. Like, you get whatever you take and then you move out to your BHAGs, like big, hairy, audacious goals.
Well, the way we see it, right, it's going to be a very long drawn-out process, and if we need to succeed, it's like a pyramid approach. First, the apex would be the successful corridor which actually works, and if we need to achieve that, then we need to have a lot of development projects going on, working on different aspects of technology. But to make that happen, there are 2 key elements, which will be the low-hanging fruit. One is what I would call the enablers. When I say enablers, in the morning one of the teams also spoke about it. Winston Streams also spoke about it. We have been speaking. Is defining standards. This is very, very important. Because what we need to understand, right, there are 3 broad areas where Hyperloop development is taking place. Europe is at the forefront, to a limited extent US and in India. And US and India are the only 2 geographies which can have its own standard and make it work. They got the size and got the market also. And therefore this is a unique opportunity for us to work together, evolve a common set of standards, so that whichever Hyperloop startup is working on, right, they don't need to bother upon
what are these things? Some certain things are fixed, so the constraints are getting reduced. That's one. Second thing, for lack of a better word, I would call P plus P. What we require is more participants. Today we got a few colleges. Possibly if we have 1 year down the line, there should be at least teams from 100 colleges. The more students participate on more institutions, there will be greater interest. That's one. And two, we require greater number of patrons. Indian Railways is one. But forget Indian Railways, right? There are a lot of PSUs. For example, wagon manufacturing things, they can make pods. So other PSUs are there, even private sector. For example, we are speaking to a leading metals company. For them, the tubes could be an area of attractive business opportunity. So they are collaborating with us on that. Get more patrons to either actively participate with you or support you through the CSR. So these are the low-hanging fruits. More students to participate, more college participants and corporate sponsors or PSUs or governmental agencies. For example, this is something which the Indian Railways could possibly consider. Like the Defence Ministry is giving up defence challenges, where startups will be given 1.5 crores or even up to 10 crores in terms of projects, etc. Now, if you can, it depends upon how you define the problem per se. So if you can have certain problem definitions, right? And I'm not saying give it to tutor or give it to Quintrans or somebody else. There can be multiple things, because if the finance ministers agreed to the railway minister's request and allocated 5,000 crores, we need to see how much of those 5,000 crores is getting spent. Yes. And if we are doing it in the right manner, it will give us benefits. And the earliest thing, it might take 1 year, not just among the startups, but dialogue along with Indian Railways or National Highway Authorities, automotive associations, so that we develop a cogent set of workable standards for Hyperloop. That is going to be very, very critical. That is priority number 0.
Okay. So before I come to Sudeep, to you regarding the patronship with Indian Railways or without Indian Railways, I think let's hear from IHC, because that is what participation is all about, and I think that was your mainstay of your presentation. So how do you think you will be able to, assimilate a large number of colleges, as what Balaji is mentioning now, and proliferation of the technology research rather down the line, and engaging more number of educational institutes and research institutes for this?
Yes, IHC's one of the important goals is to collaborate with academia and connect it with industries as well. So one of the ways in which we can achieve is that engineering is incomplete without actual practical hands-on experience, working on some projects, having some problem statements to solve upon. So as Balaji sir rightly said, that we can have a problem statements list which can be given to academia as well, which they can solve upon and then give up solutions and have discussions upon them as well. And apart from that, we can have various competitions. Like currently there is no competition being held in India for these Hyperloop projects. So we need to go to Europe, we need to go to Canada and various other countries. So we can have a competitive environment here in India itself, so that more people and more universities who cannot afford to go to these international countries can come here and share their knowledge and get excited and use their innovative young minds to contribute to this technology.
Okay, so Sudeep, how do you take that, the mentorship of the Hyperloop projects by Indian Railways, or sort of startups, as what Balaji is mentioning, and more specifically, can we see Indian Railways down the line sponsoring Indian Hyperloop Week?
Well, as in my presentation I stated that Indian Railways is very keen on this new technology, and once we are mandated to take it forward, definitely we will be undertaking various activities that are required to take these things to the logical conclusion. So we are already operating a Center of Excellence at IIT Chennai, where we have contributed 8.34 crores. And our Honorable Minister has also been very passionate in the advancement of technology, and he has himself taken a lot of interest in this field. But when we move ahead, we also have to be very clear about the roadmap. So there are 4 key things as far as I can see based on the thought-provoking presentations that were made today. One is the technology. The technical elements need to be frozen. So for that, consultation between various stakeholders, between the academics, industry and the requirement, the end users, that has to take place. So whether we have to go for a linear induction motor or a linear synchronous motor, whether we have to go for passive levitation or active levitation, inside out infra development or outside in infra development, all these things needs to be taken care of, and we need to freeze the technology. Once the technology is frozen, we have to do the proof of concept. Second thing which I see as a challenge is the legal part of it. Apart from the legislation that will be required to bring Hyperloop in Indian Railways, because right now we own everything that is on a rail path. For bringing Hyperloop, maybe we need to bring all those things which are on a guided path. So with this, apart from that, lot of bylaws, the regulations, the standards, the specifications, all these things need to be frozen as per the global standards, so that whatever product ultimately we come up with is of global standards. We not only make it for India, we make it for the world. And apart from that, in Vision 2047 that is currently being made, definitely a thought is being given in this direction that India should be a leader in such technologies. The third point that is very important is the commercial aspect or the cost part. Of course, for development, you need to spend. Nowhere a great research has happened without the support of the government, world over. Government has to fund it. And apart from funding, what is required is that those who are investing in it will look forward to some assured business at the end of the day. Absolutely. Because if someone is investing, they would be expecting that at the end of the day they will be assured that they will be getting this much business so that they can sell their product after it is ready. So this thing and the cost or the technology that we adopt, it was very heartening when I saw Professor Chakrabarty's presentation when he said that our Hyperloop will be quite cheap compared to the Hyperloop being offered by other countries. And I wish him all the well for that. But this cost component has to be kept in a domain that it makes sense, because public transport is not going to be a profit-able business. So you have to be very careful about the cost of the capital. And apart from the technical, legal and the commercial angle that I have talked, one last aspect would be that we need to identify the pilot project sort of thing. So once we have identified, we have done the POC, addressed the first 3 concerns, undertake a pilot project as a tech demonstrator, and then after that pilot project we can have a large scale rollout. So with these 4 things, definitely things can move, and Indian Railways is definitely willing to be part of this story.
Kudos to Indian Railways. Before I open the house for to questions from the audience, I just quick input from you, Prasanna. How do you think the startups like Qtrans and Tutor would be able to address the technological, the huge technological input which they are expected to make Hyperloop in India possible?
Yeah, first of all, that's a very good question, to be honest. What I see startup differentiating from academia or something like a ministry or an organization is the connect to the customer. And the connect to customer is something that is very much important for us in order to identify the pieces of technology that are necessary. So, like rightly Mr. Balaji said as well, and Dr. Satya Chakrabarty said as well, that we have been in conversation with multiple customers to identify what sort of end usage they want. Because the problem is here is right now we have the solution, we have to identify the right piece of problem that needs to be connected to it. So identifying that problem will be first gauged upon multiple factors. That will be the first will be the the business case out of it. So if you are developing, say, a Hyperloop corridor for, say, like a industry like a mining or something like a port industry, for mining, entire cost structure in logistics have been standardized for ages as of now. So how much cost you can draw at each stage of loading, unloading, then getting it to the warehouse and then distributing it to channel partners. It has been, a rate has been set up for a very long time as of now. And when you introduce a new piece of technology, there will be disturbances. So how does a technology developed by TUTR or a Quintrans will be able to stabilize that? That will be very important first. The second would be the period of return. So once you have developed Hyperloop as a mode of transport, so there will be multiple stakeholders involved into this who will put their investment. So the period of return would be very crucial to them. So there are two fronts at which we are trying to solve the problem. So that will be very crucial for a startup like us in order to work on this technology. And we as a startup itself, we are promoting that we can see different segments of startups which will be coming onto the future once this has been taken into commercial consideration. So each and every startup will bring that different pieces of technology. So if TUT or Quintrans are the first wave, so the second wave, third wave of startups will bring together very much optimized technology, and we'll be able to bring that bracket of price to a very nominal value as well, and we'll be able to achieve the vision of the most cheaper and affordable version of transport in the future. Yeah.
So stability and rate of return rather would be the key factor here. I open the house for questions. The audience may ask questions. Yes, sir.
Based on what we just heard from many panelists here, as well as some of the remarks earlier, I want to draw parallels to what's happening in other sectors in the country, and then see if we can try to imbibe on this. In space, that's happening in the space sector is one example of how the government can catalyze private participation in space activities, right? That they have actually done that. This was part of the Atmanirbhar Bharat initiative that happened in May 2020, just a couple of months after the pandemic, when the finance minister announced what we call as the measures for improving the economy. This was actually done as part of that. The second thing where I think maybe a direct parallel here is what has happened in the drone sector. So the country basically made up its mind that we want to unleash the potential of drones here and try to rival what China is doing and so on. And then there was this thing, something called the Drone Federation of India. So the Drone Federation of India was recognized as something that would champion this with the Ministry of Civil Aviation and develop draft drone rules that were actually issued as a gazette notification in August 2021. So a lot of these things actually require some level of legislation, and there must be a champion body that pushes this and gets the attention of the government and pilots this through, because this will require maybe even parliamentary involvement and so on. So there must be a lot of drumming up of support outside of just, let's say, some particular ministry's bureaucracy, right? And that's something that we have to keep in mind.
Thank you, sir. Questions from the audience? Yes, please. Mic here. Gentleman in the front. Here.
So my question is actually to anybody who can answer, but I guess Quintrans and Tutor can answer it better. So today we talked a lot about two things. One was low-hanging fruit, and second thing was the regulations and all that. So what I wanted to ask is, whenever we end up creating a Hyperloop system, which is the dream system we want to create, I don't know when that will happen. But until that, we also discussed that India is transforming into a urban population, and mass urban transport systems are on the rise. So do you think that we can take some aspects of the Hyperloop technology and make them test them on a trial basis on these new urban transit systems like our metros or the whatever high-speed urban transit systems we are making. Thank you.
Dr. Bala, would you take?
Yeah, thanks for that question. My short answer is yes. I can't suddenly say that, okay, let's go to so-and-so metro and introduce a Hyperloop there. The reason I say yes is I think in terms of an application, in terms of this idea of the low-hanging fruit, meaning near-term application. Not tell somebody that please wait for 15 years before this thing will be ready. No investor will come forward. Even the government will become very skeptic because no government knows if they will be in power 15 years from now, and when a technologist or a group of people go and tell somebody it will give me 15 years, it's as good as saying forget about it. So I think our jobs, not just the TUTR and Quintrans type people, but anybody who's interested in developing this kind of a system, we should be looking for what are reasonable applications. It doesn't have to be the highly evacuated tube with pods shuttling at 1,000 kilometers per hour. But if there are mechanisms which are, one, useful to somebody, useful meaning that they would be willing to pay. They would be willing to pay to use that service. At the same time, it demonstrates one or more parts of the technology, one or more critical parts of the technology. I think to me that would be progress. Because if you are able to show that this technology is working, it is advancing the growth of your ultimate goal, but at the same time it is bringing other people in to believe that yes, this is working, therefore I would be more favorably inclined when I want to fund a more complex thing. So that is my short answer.
So the proof of the pudding is in eating it. Absolutely. Next question, please. Yes, please. Uday. I would request the participants to please just give a short introduction, like name, etc., and then ask the question.
I am Uday Bobate, CMG Western Railway. My question is related to his question only. Like, what is the forecast of actual use of this technology for commercial purpose? Like, you must draw something deadline, like freezing of technology. How much time it will take? 1 year, 2 years. Then after you want to construct one 10-kilometer track that will be dedicated for freight traffic, not for passenger. Then how much time you want to run to prove that concept? What is the estimate and actual use, when it will come? After 5 years, 10 years, what is the timeline? Whether you have calculated that?
Dr. Satya, will you please take? Just a rough estimate.
My estimate for, my best estimate for passenger happening is 10 years minimum.
10 years, a decade.
Yeah.
Any other question?
Yeah, so I am Sanjay Tiwardkar. I am from Megapod Hyperloop. My question is, recently when we went to the European Hyperloop week, there was a topic which no one could conclude about. Like even the European startups, maybe Zeleros Hyperloop or Heart Hyperloop. So that was that your standards for European for Hyperloop have not been come out, although the European Commission in their 2023 report has tried to include some of the basic standards for development of Hyperloop in India. So what standards can we expect in India so that all these competitors, maybe it be startups or numerous startups that might come after this, they should work hand in hand and rather not head to head with each other in order to make Hyperloop a reality in India?
So can you please throw some light on this?
As far as the standardization is concerned, in my presentation I talked about the joint technical committee that has been constituted in Europe on this. And they are having a combination of SEN and SENLEC standards. Organizations like Indian Railways have been adopting SENLEC standards for their various safety systems, the safety integrity levels and all those things. So it needs to be considered, or rather it is desirable to be considered, that we may try to have some interaction with the JT, the Joint Technical Committee that has been constituted, so that our standards are at par with those standards.
I would like to add, I think my views are slightly, I digress from what Mr. Sudeep Srivastava is saying, because Europe is going towards developing its own standards, but this is for the first time in the history of mobility, India has got a chance, an opportunity to be a standard setter rather than a standard taker. And the Europeans, and therefore, because of two things. One, if the technology is in infancy, and two, if the market is large, people, the development would be faster, we can be able to gravitate. But coming to your query, which is very, very important, there's a lot of conflict in Europe because everybody has been progressing for 3-4 years and they made some development and nobody wants to give up on the progress they have achieved. And therefore, this is the right opportune time for Indian startups because we are still at a lower stage of development compared to them to get together, work along with the policy makers and other agencies so that we take the best of what others have got, at the same time incorporate our understanding of what the market would require and set it. Because for the sake of discussion at this point of time, if European startups are going to focus upon setting standards which would take for 1,000 kilometers per hour, I don't think in India we're trying to look at 1,000 kilometers per hour for the next 10 or 15 odd years. It will be relevant technology, relevant thing. Therefore, we should approach it from an Indian perspective and take judiciously what is there in the rest of the world so that we're able to do. That's my view.
Dr. Bas.
I didn't complete it, so I think there was a misinterpretation. When I said we need to engage with the Joint Technical Committee, it was not about copying their standard, but knowing their standards, taking the best practices, and then having a dialogue so that we establish the standards and they become part of the global standards. So we should no doubt be the leader in putting them in place, but at the same time we must engage with others so that what we are doing is not done in isolation. For example, Japanese train protection system is one of the best in the world, but no one purchases it. It's just become an island. So that scenario we should avoid, so we should engage with them, we should have our standards, we should be open about getting the best practices and standards from others, and then we can have a sort of agreement that these are the standards best suited for this type of transportation and adopt them globally.
So just a quick word from Dr. Bala before I come to you.
I think we are violently agreeing here. I just want to add...
That's the beauty of discussion, sir.
Correct. I just want to add a couple of thoughts. Earlier when we talked about a consortium or collaboration, I think this standard setting is a very, very important part where we need to collaborate. Imagine that TUTR is developing something which is completely different from what Quintrans is developing. At some future point in time, we will have one meter gauge running up to Mumbai, and then people have to get off of this, go to the other one, which is a broad gauge. We have lived through that in India, and we have decided that we will get rid of all the meter gauge and go to broad gauge. So one, we need one common standard for India, but speakers have already talked about, the idea that we are not developing this only for India. We want to be in a position to take this technology, offer this technology and the manufacturing and everything that goes with it to other players in the world. And that will only happen if you have a standard that is applicable globally, not just within my state or my country. And there is a very good mechanism to do this. I used to be president of a group called SAE India. In fact, Arvind Bharadwaj, who is one of the co-founders of TUTR, is also a former president of SAE India. He and I have discussed this. And one of the things that we agree is that SAE India could be the forum where this kind of a standard is evolved, because SAE India is connected with SAE International, where they have, SAE International is a storehouse of thousands of standards applying to the automobile industry, to the aerospace industry, I think some to the railway industry as well. So there is an opportunity here. Here is where Balaji and I completely agree. We have an opportunity to do things differently and create something, be the leaders, or at least be one of the leaders who create something that is applicable worldwide.
Dr. Saket, your take.
No, I don't have any take. I just want to add a point here. But before I say what I say, I think I just want to synthesize what everybody is saying. I think what Dr. Bala is saying is that all of us are actually in agreement. And wanted to emphasize that by saying that I think a lot of these things will happen when we actually start acting faster. If we are the ones who are taking concrete steps faster in a very coherent manner, unlike what the European startups have done, which is to, as Balaji said, develop things independently up to some point, and they don't want to give up on some ground that they have gotten to independently. Instead, if we actually coherently take very fast steps quickly, we will be faced with this requirement that we need to develop standards, borrow upon what's been done, as what Sudeep was saying, and go farther from there, and then inform the international community, hey, this is the standards that we are setting, take it or leave it, come along with us or you're lost, right? You actually can set the, the standards for the standard setting, right? That is the point I think we should get to. So I think that there, the emphasis is action, right? So is there a way by which you can get into some kind of a mode of action very fast? That's what will force us to get into the standards. That's the first point I want to make in synthesizing what everybody is saying. But my specific point was very different, which is this requires us to actually look at standards borrowed from 4 different realms. It's not just railways, but also maybe automobile, aviation, and space, right? And each of these different sectors have their own sets of standards. And like, for example, there could be ISO standards in one case, there could be SAE standards in another case, and all that stuff. Right? So the question is, how do you synthesize across all of these things? Because we don't want to reinvent the wheel, we want to lean on these different technologies and their standards, and in synthesizing the standard. So in my opinion, in India, we should actually look at not just railways, but also maybe bring in some people from ISRO, if required, right, to say what they have to say, and maybe some aviation standards will have to be looked at, and so on. So it is going to be a bit more interdisciplinary than what meets the eye.
Absolutely, sir. It makes sense, and in fact, we should have a regulatory body which has members from various industries, various supportive industries, probably startups and the business community, so that not only the standards, but the financial part of it is also standardized, and academics, not to forget. Another question, sir. Mr. Lalit.
I am Lalit Mansukhani. I am OSD of Center of Excellence for Modern Signaling of Railways. In fact, I had picked up the mic, but my query is already answered. I was just wanting to know, we should have the development of technology in such a manner to keep in mind that multi-vendor interoperability is there. Quintrans and Tutor product should be interoperable, and as Sudeep has rightly told, that we should, keep on visiting the global standards also. Then only it would have export potential, and we would be leader in the technology. Of course, that was my query, but already answered. But you people can just supplement or substantiate something else. And before concluding my query, I just would like to mention that Sudeep has already brought out why Indian Railways is the right choice to pilot this. And in my opinion, right now the person, Mr. Sudeep, I know him personally, is the right choice. And he should. We should take his help to set the path, because initial setting of the path is very important, which will lead us to proper direction. So that's what. Thank you.
Thank you, Lalit. Any other question? Yes, please.
As a railway engineer and just having no idea about what Hyperloop is just 24 hours ago, and after attending today's presentations, it is almost convincing, but 2-3 queries are there which are mainly related to technology. First of all, the business model, as nicely indicated in his presentation by Mr. Balaji, but that is only an indicative thing. The right business model is, I think, yet to be established. But before establishing the business model, we need to finalize the cost model, and before the cost model, we need to finalize the technology model. So, regarding the technology, a few things are there. I was talking a few months ago with, I got the opportunity to talk to Chief Commissioner Railway Safety, Mr. Pathak. He said that the key of high-speed train operation is track geometry. Now, when we are planning to run a shuttle or pod at a speed of 1,000 km/h, the track geometry needs to be very, very perfectly straight. So, as has been already shown in Professor Chakravarti's presentation, the 70% cost component is track. But no more detail was available about how a perfectly straight track connecting two cities will be built. And the second query was how we are planning to do the VAC, that is ventilation and air conditioning inside the saloon. That was the second question. And third is, as Mr. Balaji has shown in his presentation, that our first target should be towards the freight component instead of passenger component. But even the maximum acceleration and deceleration that can be permitted for consignment transportation, that there may be a limiting value, because even there may be some consignment which can be destroyed or damaged at a very high acceleration or deceleration rate. So these are the three things I want to know.
Perfectly straight track actually is of two kinds, two levels. One is, are we actually talking about not having any turns or not, versus is it okay to actually have any deformities on the track, right? Both of them are actually okay. So first of all, I think it's okay to have turns. It's not as if like it has to be exactly straight from point A to point B. We have to negotiate these turns. Typically, as the speed is higher, the turning radius has to be larger, and the banking may be more, and so we have to actually figure out how to do this. So what we would expect is that the turns will have to be milder when compared to a typical railway track or whatever it is. For let's say steep turns, so you may be requiring like additional land acquisition to cut across when you have like a turning that's almost like a 90-degree bend. So these are as far as the turns is concerned. It's not as if like turns are a big no-no. It has to be accepted, and we have to negotiate it. I think as far as the perfect track is concerned, that's what I think I mentioned in the morning. Hyperloop, I think, is a hugely hardening technology. So one of the things that the Avishkar team did not show was a video on the levitation where they physically perturb the levitation and then show that it comes back to the original position. So you can work out what's called the stability of levitation, and in a stable configuration, if you have undulations on the track, it will essentially mean that you will have a slight push up and down of the pod, but it will actually come back to its original position. So the stability essentially means that you don't need to necessarily have something that is very, very exactly straight, right? So which is something also is bringing down the cost. If you have to do something extremely perfect, it will be much more expensive than compared to if it is okay to do something not so perfect. So that's the reason why we think that the cost will actually come down. So this is the answer. This is a two-part answer to the first question. What is the second question? Always ready. Yeah, the air conditioning and ventilation part is very similar to what happens in an aircraft. right? So this is a solved problem in an aircraft. All of us actually go in aircraft, and there is a cabin pressure, and there is the air recirculation. All of that stuff is actually taken care of. So I think it's a very similar thing. And the third question?
The limiting value of acceleration and deceleration.
Correct. Okay. So what I would do if I were actually running a program on developing Hyperloop is to actually look at what is safe for human beings, because to me most of the cargo will actually probably withstand the kind of accelerations that human beings can withstand, particularly normal human beings. We're not talking about like fighter pilots being able to take like much more G levels and all that stuff. For example, if I'm looking at vertical takeoff in helicopters and all that stuff, typically human beings cannot take more than about 0.3 or 0.35 G, right? So can I keep my accelerations within that level? The answer is not for the pod, but for the cabin. So you should be able to distinguish the cabin that's inside from the pod, and then have spring-loaded mechanisms where it's very similar to these very high-speed lifts for very high-rise buildings. A 100-story building will have a lift that will actually take you in about 1 or 2 minutes, and it actually raises very, very fast, and it doesn't still let you know that you're actually taking that kind of lift. Otherwise, you will feel a huge load on your body, right? And the reason why that happens is that the lift is actually in suspension. So it has an inertia. When it actually accelerates, you will go down and then slowly climb back, right? But the main pod is actually accelerating, but the cabin accelerates a little less. So we can do all these kinds of things. And similarly, that can also be added to a two-dimensional way of handling turns, or besides banking, to essentially soften the load on humans. And if you are able to do that, I think the cargo will also take it. It should not be a problem.
Yes, sir.
Okay. Quick one. Some of these things that Dr. Satya just said, they are engineering problems. They are not technology problems. So there are certain things that are technology to be developed and validated, and some of the points that you were asking are really engineering design problems, which other industries, other situations we have handled. In fact, we have situations where the seat itself is controlled, independent of what the cabin is doing. The seat also can be controlled where the person is sitting. So there are different ways of handling this, but good engineering solutions have to be developed.
Balaji.
I think Bala answered most of I wanted to say. But just to provide a simple perspective, if we want a quick and dirty solution which works, we know that all of us have traveled by flights, and even goods are transported by flights. We know what is the acceleration, what's the deceleration, and at least for the first 5-7 years, no Hyperloop would cross those limits. Therefore, there's a slave area for you to work with.
Yes, please. And at the back. Please use the mic.
Good evening to all, sir. I respect the podium who has given me this opportunity. Few things what I want to ask just now, Professor actually asked, and the answers I could have got. So one of these, I think, is which he missed or somebody missed. What will be the capacity of the maximum capacity of the each pod? Secondly, since the status of the project is in the at present, it is in the mother's womb, and we are thinking the road ahead of this project after 10 to 15 years. Since we never thought of bullet train in India, but after 2014, it is coming true that we are going to have bullet train. So, could this project is going to be sustainable with the radical development of technology and infrastructure with the current speed of India development? Secondly, there may be a very chance of getting high success of the superconductivity. Would it be challengeable to this project? Please explain, sir. Thank you.
It's more of a question from economic point of view. Dr. Bala, review.
Yeah, I can write it down. Okay. Yeah, I noted down 3 points. You asked about pod capacity. In my mind, at least, there is no fixed capacity for the pod. We have talked about different presenters here. They have talked about something that can carry 20 tons, for example, for a cargo pod, or you can put X number of passengers. And there is no hard and fast rule about the number of passengers in my mind. It can range from like an SUV, which can carry 6 to 8 passengers, all the way up to a minibus or something. Because one of the reasons we want, one of the advantages this technology provides you is that ability to go there and get that personalized travel route. So the bigger you make the capacity, the more difficult that becomes. So you have to kind of bring the capacity, the number of passengers down to accomplish that. Now you asked about, many things are developing, and in the context of many other developments that are going on, will this be sustainable? I think yes. In fact, this is a great opportunity and a perfect time to plan this in such a way that when somebody goes by a Hyperloop, station that I can think of, you get off of that and either get into the unmanned vehicle that Satya was talking about earlier this morning, or get into some other transportation, like create a transportation hub where the Hyperloop is one of the elements of that hub. So if we are developing something for the future, you don't develop it and then figure out how to fit it in. The right way of doing it is you envision the bigger thing ahead of time. Even if all of them are not going to develop simultaneously, you factor for that and leave the space and all the interconnections available so that at some point in time, 10, 12, whatever number of years later, everything works seamlessly. In the scheme of things for a country, 10 years is nothing. Okay? I mean, many of us will remember how India was 10 years ago, and lots of things have changed. 10 years from now, if things get better, we should be able to leverage that. Third one, you were asking about superconductivity. Superconductivity would be a wonderful thing. It will require even less energy than we are talking about. And maybe our magnets will get even better, so you will be able to do things, more efficiently than, people are imagining now. See, the thing is, we had a couple of presenters talked about putting solar panels, generating electricity and all that. There is a whole another parallel set of technologies that are being developed to create more electrical energy in this country. Whether it is hydrogen-based, solar-based, whatever other mechanism, this technology will simply use the electricity. And if you are able to generate that electricity in a smart way, we can use it. So we should think of this as a holistic, big picture thing, rather than, somebody is going to come and compete and make this useless. I think it's all part of an integrated whole in a positive way. That's how I look at it.
Quickly, last question. We are running short of time.
Hello. I am Chief Engineer, Metro Railway, Calcutta, Devendra Kumar. As my colleague has pointed out about the rail track geometry, so that particular model which Hyperloop has been discussed, it is on the straight or level track. My colleague was actually referring to that how to negotiate the curves, gradient and all these things, for which actually in railways we do carry out rail wheel interaction study. So this type of study is also actually required to optimize and design the track. So my question is that actually has the civil team is also being onboarded in the development stage of this Hyperloop system? The second question is that Hyperloop system, as you have told, it is a tube type of system. Now that tube has to be supported if it is to be constructed over the ground, some sort of on the pylon, right? And if it is to be driven under the ground, then it has to be bored, just like we do in the tunnel boring machine. Okay. Now, as far as the cost of the construction is concerned, in case of pylon, in case of metro railway, actually cost of construction over pylon varying from 100 crore to 150 or say 200 crore per kilometer. And in case of tunnel boring machine, it varies from 300 to 500 per kilometer. So Mr. Satya has covered about the cost aspect of the construction. So which you have mentioned, have you included this cost aspect in your calculation? Because you have mentioned that it is cheaper than that your high-speed track or metro. The second question is that. Third question is that you have demonstrated that this Hyperloop system on that perfectly level or secluded place. Now, while constructing in the commercial sense or practical sense, say in the city area, where all the cities are nowadays congested, it is very difficult to find actually land for construction or say space for the construction, or methodology has to be devised for the construction. Because construction in the actual traffic scenario is very, very difficult. In the running traffic, we'll have to seclude, isolate that portion or say stop that traffic or divert that traffic. Then cost also increases in that case. So have you all considered all these aspects in the calculation? These are the three questions. And what is the effect of this Hyperloop? Because Hyperloop, which you have told that it will run at a speed of say 400 kmph or say 1000 kmph, it will have actually a lot of effect on the design of the civil structures also. Because as the speed increases, then its dynamic impact also has to be taken care of in the design of the civil structures. So are you taking all these aspects into the design of civil structures? My point is that because I'm concerned with civil structures. Thank you very much.
So you are the technology man here.
So which means that I'm responsible for everything, I guess. Okay, a quick answer to all your questions is yes. No, I think we are in a very, very infancy stage at the moment, right? So we are still talking about straight tracks to be done to begin with. But I think I pointed out that turns is actually the next big challenge that we have to look at.
Curves and gradients and
Yeah, same. I mean, whatever you're talking about. You use turns, I use turns, you use curves, same, different English words. So we have to do that, right? I think what Elon Musk has done is to dismantle his 1 mile long tube, and then he's now looking at a curved tube to be done, because that's actually the next big challenge that they're looking at. And definitely we will have to look at that as well. And there'll be lots of issues there.
actually that has a lot of impact on the design of Hyperloop per se also.
Understood. Yeah, I mean, I'm not a civil person, but I'm assuming that the civil engineers who get involved in it will take into account all of those things. And the costing, we have not actually taken into account the land acquisition cost. Okay, so the land acquisition is actually a huge problem, particularly in cities where the land value is huge. Particularly if you're looking at elevated tracks, land acquisition is a huge problem. On the other hand, if you're looking at underground metros, tunnel boring actually is very, very expensive. So both ways, actually, there is a cost component over there. What we have talked about is more like a BOM cost and not exactly including the land acquisition. So the underlying assumption here is that Hyperloop definitely requires a right-of-way, and today right-of-way exists with railways and typically, let's say NHAI, National Highways Authority of India. So whoever already has a right-of-way, is it possible for us to piggyback right on them with some real estate that they can accommodate Hyperloop on? So that we don't have to actually go and try to find like land acquisition and all those things. Otherwise, it will completely derail the whole idea. So, and assuming that that land is actually available for free of cost, right? That is fundamental assumption there. So what cost we have put is actually more of a BOM cost rather than including the land acquisition and so on. The third part is about negotiating congested areas like cities. The answer again is like what railways does. Right, so if I have a Chennai railway station and then there are like at least about, I mean, you step out of Chennai railway station, you will find like at least about 100 tracks that are out of there. Where do you guys get the land? Okay, so we will piggyback right on them. That's it. So why was it?
So just to add or to reply to some of the parts that pertain to railways was, civil engineering is a very integral part of all the teams. Actually, Mansukhani sir was giving credit to me. It is not at all mine. There is a team headed by PED Jain sir who is looking after this project. There are 3 teams, technical, operation and project, and there is a civil engineer in each of the teams. As far as the other aspects that you talked about regarding whether it will be good in a congested area or the land acquisition will be required, actually that is one of the benefits of the Hyperloop. Recently I was in Ahmedabad and I looked at that high-speed railway. So the CMD was telling that because of the usage of the viaduct, the land acquisition has reduced substantially in the high-speed railway. So this will be also on the pillars or pillions, what you say, and the land acquisition will be minimal, as Chakravarti sir has rightly said, that right of way is with railway, and that is why we also said that since we have all those things, we are a suitable candidate to actually pilot India's or to lead India's effort in the field of mobility. So from that angle, the right of way of railway or NHAI can be utilized for this purpose. And advantage of Hyperloop is that it can be in the heart of the city because the infrastructure requirement is quite minimum in this case. Lastly, as far as someone was saying the sustainability thing is concerned, India has to be a zero carbon emission country by 2070. That is the commitment that Honorable Prime Minister has given in international forum. So if that has to be achieved, then we need technologies like Hyperloop to be in place. Indian Railways anyway is going to be carbon emission free by 2030. Already a lot of steps are being undertaken in that regard. Hydrogen trains are also being tried. But if you want India to be a zero carbon emitting country by 2070, you need to work on technologies like Hyperloop. Thank you.
Prasanna, your take.
Yeah, so it was a really good question, to be honest. So the first aspect is while we talk about viaducts in metro, while we talk about viaducts in HSR as well, the shape of the pier caps or shape of the pylons entirely depends upon how the load transmission is taking place from the viaducts to the pillars. Now, in cases of Hyperloop of a tube of the order of say 4.2 meters or 4 meters, the comparative weight of these 2 tubes which are mounted on the piers will be much less as compared to what we have for HSR as of now. So the shape of the pylons, the cross section of the pylons reduces very greatly. So the land acquisition part is definitely more easier as compared to if you take in consideration other elevated modes of transport that you have. The second point that comes into consideration is the noise and elimination of noise and vibration. So since the entire mode of transport is contactless, you are hovering over say a gap of around 5 to 10 mm, there is very much less vibration that is acting upon the entire structure. And the second part is also the noise, which is very much less generated. So whenever land acquisition comes into consideration for elevated projects, most of the land that is taken in is mainly by the farmland which is taken up, or the nearby agricultural land is taken up, and the people living nearby to these kind of land have to move out or have to evacuate from that space because they cannot live in such kind of noisy conditions because of the infrastructure that is, or the mode of transport that is traveling over there. This is a very huge benefit in comparison. There is no noise that is absolutely being generated. So you have much, can say, susceptibility to live near to the infrastructure as well, and at the same time utilize the infrastructure as well for your agricultural needs. So that is a huge benefit that Hyperloop offers as compared to other modes of transport, even though they are secondary, but it will reap better results in future. Yeah, thank you.
Very well put, Prasanna. And now we are okay. We'll take just quick question. Just a quick answer, Sanjeev.
Yeah, good evening. I am Sanjay Rao, professor here. My question kind of mass rapid transportation system, if you look at, that's what I feel India needs. With the kind of population we have, 140 crore people. Even if you get the freight as well, what kind of capacity you look in when you look into these technologies, right? In place in future, let's say, how many people you can haul, how much freight you can haul. Is it only we are driving away with the technology? It's all to have achieve experience and doing of transportation, whether public transportation or freight. Is it going to be a substitute for the the current modes of efficient transport systems?
Yes, sir.
There's definitely going to be a very good answer to passenger transport on capacity. I think I showed some numbers where the current number of people that are traveling between Chennai and Bangalore is about 32,000. If you look at the upper class compartments, all the flights that are happening and the fancy buses and so on. Whereas if you were to actually run, I think something like 38 pods, 2.5 minutes, 18 hours, something that I think had shown, we could actually move about 64,000 people, double that. So this is assuming a certain speed of about 600 km per hour. The good thing about Hyperloop is that the same infrastructure, as technology improves, power levels come down, superconducting magnets, whatever it is, allow for these things to improve, the speeds will improve. So if you now go from a 600 to 1000 or 1200, the capacity will actually double, right? So what is going to be 64,000 people will actually now become like 1,28,000 people. So the capacity for people movement definitely will improve. And I believe that people are the ones who actually value their time when compared to goods. Goods are actually something that we put a value on that time. That kind of goods are actually very, very specific. Not all goods need to actually go in a hurry. So not sure whether even if we can actually create the capacity for goods movement at very, very high rates, who is going to pay for it will actually determine whether that capacity is utilized or not. But capacity development can be made, but capacity utilization on goods I'm not very sure. But people definitely, yes, I think the answer is positive.
Just to add to that, you wanted some data. So there is some international study which says that by 2050, 800 million people will be staying in urban population in India. And with a system like Hyperloop, if 403 million commutes through it, then the carbon emission would be reduced to a great extent. So there is some study on this which is available.
Just to add on to that, right? If you take US, where a lot of data is available, for the last 50 odd years, this is data ending till 2016 or 17, the average kilometers traveled by people has grown at a compounded rate of 7% per annum, where the population has grown only by 2%. People travel more continuously, and it's just like supply creates its own demand, so that automatically as more and more new channels come in, people start traveling more, they take the option that is more comfortable to them and affordable to them. It will actually, this new mode of transportation will take a share of the existing population whose demands are increasing. So that's what it would happen. If you look into it, right, even before wheel was invented, human beings were walking, they're still walking, then cycle, then auto rickshaws, cars, all the modes of transportation are existing. We'll use the one that is most convenient and most relevant to us. So that's my humble submission.
Thank you, Bharati. So just to summarize, we have discussed the development of technology, and we have discussed that indigenous way is the best way of going about it. We have discussed the funding models, and we have also discussed that there is absolute need of a regulatory body which is to be set up right now, and it should be comprising of the members from the various industries who are the important stakeholders. We have also discussed the business models, and we have also discussed the need for capacity building in terms of training, in terms of development, in terms of research, in terms of industry incentives. And then finally, we also discussed the role of government, and the government should be a leading hand, leading all of us towards a carbon neutral, bright future. Thank you, gentlemen. But before we conclude this plenary session, a parting shot, sir, starting from you, Dr. Satya.
My parting shot will be actually to encourage all of us to dream. It's important for each of us to actually dream of a fabulous future for ourselves. So the 10-year period that I actually talked about, it's important for us to commit ourselves to say, let's actually go ahead and do it. If we don't start today, it will not happen in 10 years. So is it possible for us to actually have the first passenger corridor in India within 10 years? I think that should be a goal that all of us should commit to dream about. That's my potential.
Thank you, sir. So, act and act fast. Sudeep?
Well, Professor Chakravarti rightly said we should dream, for if we will not dream, then how will the dreams come true? So we should dream and we should work to make those dreams come true. And Hyperloop is one of the technology that can be game-changing in days to come. India suffered a lot when we missed the industrial revolution in the 18th century. Then we caught up in the IT revolution in the early 21st century. It's high time we should be leading this technology change so that we are pioneers in it. Thank you.
One of our prime ministers, one of our earlier prime ministers that famously said, I am young and I have a dream. IT revolution started from that. Dr. Bala, your parting shot.
Okay, my dream is that we are actually collaborating better in some form of a consortium. I use that word because I've been part of consortiums before, which actually did lead to useful things. We have to think of this in an integrated manner. We are talking about making a big change, and when you are talking about a big change, you cannot think of it piecemeal. The group has to come together, like we said, group comprising of people with various backgrounds, various interests, but you have to think of it in an integrated, big manner, and then just like we have Make in India, let's have Move in India also.
Excellent. Prasanna?
It's pretty much summed up by everyone, but maybe I'll speak for the young mass who will present over here. So the parting note from my side would be perseverance. So many of us are in the stage who are working on the part of academia, working on different research projects as of now. Keep up at it, because this is the technology for future and we are the ones who will be taking this forward. So it is my grand request to all of you that keep up at it and keep going hard. Yeah, thank you.
Good. So next, engineer for the next Hyperloop. Balaji, your parting shot.
I think this is in its infancy. Therefore, the primary task is to enhance interest substantially. The more people talk about it, the more people will dabble in it. The more people dabble in it, more people will start working seriously in it. Therefore, the first and primary task is to increase the awareness about Hyperloop. So let's evangelize it. Each of us must be speaking to at least 3 people on a daily basis to others about Hyperloop, so that the entire this Hyperloop movement taking place across the entire country. And if possible, also send some contributions to us.
The new always needs friends, and friends are the people with whom we go forward. There's an African proverb which says that if you wish to go far, walk alone. If you wish to go fast, walk alone. But if you wish to go far, walk with people. And finally, our young engineer from Indian Hyperloop Committee, Purnesh, what's your parting shot?
My parting shot will be the line that I stated in our presentation as well. Divided we can do nothing, but united we can do much more. So I would like to request everybody present here that contribute as much as you all can. Every little contribution counts a lot, and unitedly we can make this Hyperloop a reality come true and have it in India.
Ladies and gentlemen, a big round of applause for the dignitaries. So with this, we finish off our plenary session. Gentlemen, please remain seated. Events such as this are held few and far between. And to keep the memories alive of such events, it is customary to present a memento so that you can always look back at it and remember the starting days of Hyperloop. May I request Shri Sanjay Kumar Pankaj to please arrive on the stage and please give the mementos. The first on the list is Dr. S.R. Chakravarti. Sir, please come. Sir, the memento has a picture of the Pratap Vilas Palace. So whenever you look at it, you will remember us and you will remember this conference. Then I would like to invite Shri Sudeep Shivastav. Dr. Bala from Quintrans Hyperloop. Shri R. Balaji from Twitter Hyperloop, Chennai. Purnesh Jain from Indian Hyperloop Committee. And now our young friends, Avishkar Hyperloop team. Keep the applause coming, ladies and gentlemen. These are the people from whose efforts you will be traveling in a Hyperloop 10 years hence. So please keep the applause coming. Team Megapod Hyperloop, MIT Pune. Dual role. Team Infinity Hyperloop, IIT Delhi. Team Nirman Hyperloop, Thakur College of Engineering and Technology, Mumbai. Team Hyperloop India, BITS Pilani, Hyderabad campus. Mr. Prasanna Kadambi from Quintrans Hyperloop Pune. Sir, I'm sorry. I would now request Dr. S.R. Chakravarti to please give a memento to Shri Sanjay Kumar Pankaj. Sir, please come. Sir, please come. A big round of applause, ladies and gentlemen. Sir has been the leader and force behind this conference. So, sir, it is apt for you to receive a memento from this conference. Thank you, gentlemen. Okay. Thank you, gentlemen. Please take your seats. In the valedictory session, it is time for the valedictory address. For this, may I request Shri Sanjay Kumar Pankaj, Chief of Faculty, Mechanical Engineering, National Academy of Indian Railways, to kindly arrive on the stage and deliver the valedictory address. Ladies and gentlemen, put your hands together for Shri Sanjay Kumar Pankaj.
I hope I am audible. Policy makers, senior officers from Indian Railways, faculty members from NAB, ladies and gentlemen. During the course of the day, we had the privilege of listening to a galaxy of academicians and experts enumerating the ongoing advances in Hyperloop technology and determined progress India is making on this front. I am sure, and all of you will agree, that the conference has been able to substantially fulfill its objective of evolving awareness about the Hyperloop technology in India. It has also been able to provide an effective forum to share the knowledge related to development and proliferation of indigenous Hyperloop transport systems in India. This conference was also able to flag various issues that need to be addressed to enhance the cause of Hyperloop in India. But this is just the beginning. And we will have to have many more such conferences and discussions in various forums to significantly establish Hyperloop technology in India in future. Ladies and gentlemen, Hyperloop being the latest technology will definitely prove to be a game changer in the transport sector in the years to come. It would be possible to offer low energy, long distance travel running on electricity and solar energy. On the roof of above ground Hyperloops could generate energy. The tubes could also store electricity with the help of batteries. Further, freight travel by Hyperloop would alleviate the high carbon emissions of other modes. I am therefore sure that it will prove to be sustainable and environment friendly with very low carbon footprints in future. True, there are many challenges ahead of us for the Hyperloop transport systems. This technology system is still in development, and the same is also true of the business models which are planning to support it. Safety of the passengers is a very critical issue which needs to be addressed. Evacuating a Hyperloop will be very difficult as the tubes are designed to have a limited number of exits. Capacity is another issue. It needs to be established that Hyperloop can be used for moving large mass of people so that it can replace the mass transit, rapid transit transport systems which are available today. Apart from many engineering challenges, like building the tubes strong enough to deal with the stresses of carrying the high-speed pods and finding energy and cost-efficient ways to keep them operating at low pressure. Providing communication in moving pods and tubes shall present a major challenge. Moving from a successful test model to a full commercial deployment with correct pricing strategy will be quite challenging. There are huge practical and psychological challenges too for the passengers, as we have discussed during the day. Therefore, Hyperloop technology will need to surmount technological and commercial challenges before it can become mainstream. And the system is open for passengers or freight or for passenger operation or for freight transportation. Human beings have surmounted many challenges in the past, which otherwise looked impossible. If I remember, when I was studying +2 or was an undergraduate student in IIT Delhi, we used to study a lot of science fiction novels and movies. And whatever we were studying and saw in those science fiction movies, all of them have proved to be true and have become a reality today. Therefore, I am very sure that whatever we are listening today will definitely become a full reality in near future. And therefore, not only hopeful but sure that if all stakeholders join hands, we could be able to move beyond initial testing and feasibility studies that we are discussing today to starting long distance trials and even more importantly, testing the service first with freight and then with passengers. And judging by the significant work being done by all the academicians, researchers and industry practitioners, I am sure that the day is not far when we will see the first indigenously developed Hyperloop transport system starting operations in India. It is a technology whose time has come, and Indian Railways has certainly played a significant role in this as a facilitator and supporter of the technology. Commitment of Indian Railways can be gauged from the fact that Honorable Minister of Railways personally visited IIT Madras to encourage the research team there and to support the establishment of Center of Excellence for Hyperloop Technology at IIT Madras. This is a revolutionary beginning and the dawn of a new era of transportation with a very bright future. And I am sure that all of you will share the same vision which I am sharing with you at this stage. Finally, I would like to express sincere appreciation and gratitude to all the speakers and participants for their very active and enlightening discussions which made this conference quite productive. I wish all the success to all of you in furthering the cause of Hyperloop technology in the years to come. A special words of appreciation for Dr. Hemant Kagra who conceptualized the event, and I think it deserves a round of applause for all of you. At the end, I would like to quote a few lines in Hindi for our young boys and girls who are from different institutions as part of the research teams. Although these lines apply to all of you who are furthering the cause of Hyperloop technology in India. कुछ परिंदे उड़ रहे आंधियों के सामने, उनमें ताकत न सही पर हौसला होगा जरूर. कुछ परिंदे उड़ रहे आंधियों के सामने, उनमें ताकत न सही पर हौसला होगा जरूर. इसी तरह बढ़ते रहे आगे तो देखना, इसी तरह बढ़ते रहे आगे तो देखना, समंदर का फासला एक दिन तय होगा जरूर. समंदर का फासला एक दिन तय होगा. धन्यवाद. जय हिंद, जय भारत.
Thank you, sir. Thank you for your very, very energetic words. And after a long and tiring day, it is now my onerous duty to present the vote of thanks. First and foremost, I would like to present a deep sense of appreciation for Srimati Chandralekha Mukherjee, Director General Nair, a leader extraordinaire and an administrator par excellence, for giving us this wonderful opportunity to organize this amazing conference and for her continuous encouragement in shaping this conference. Ladies and gentlemen, this conference has been possible only with ma'am's generous support and unstinted assistance. She has been quite busy, but still she took out time to address the conference. A big thank you to ma'am. It's my pleasure to thank Shri Sanjay Kumar Pankaj, Chief of Faculty Mechanical Engineering here in Nair, for his substantial help and valuable guidance in conceptualizing and organizing this conference. Sir has been a pillar of strength for the team and has really worked hard with us in making the conference a success. A big thank you to you, sir. Words are not enough to express our sincere gratitude to today's keynote speaker, Dr. S.R. Chakravarti, who despite his busy schedule, found time to come to Nair and deliver the keynote address. Whenever I spoke with him, I always found him very enthusiastic for the cause of Hyperloop. Thank you, sir, for your enlightening talk today. I would like to place on record a high sense of appreciation for the various speakers, Shri Sudeep Srivastav, Shri Pranay Lunia and Quintrans team, Shri R. Balaji and Tutor Hyperloop team, Shri Pramod Rao of BIAL for their exciting presentations and providing excellent learnings for the participants. All of you gentlemen are highly significant in your own rights, and your presence in this conference has provided an excellent opportunity to various stakeholders to understand the industry perspective, requirements and aspirations. Ladies and gentlemen, when I look in front of me, on one hand I see the experience, on the other hand I see young bright faces of our enigmatic engineers. And now it is time to thank the real energy behind this conference, our student research groups. So Avishkar Loop, Megaport Hyperloop team, Infinity Hyperloop team, Nirman Hyperloop team, and Hyperloop India team, and Indian Hyperloop Committee. Take a bow. Thank you. Ladies and gentlemen, a big round of applause for all the teams. There is a valuable contribution in furthering the cause of research on Hyperloop and shall go a long way in developing an indigenous Hyperloop system in India. So if we are traveling after 10 years in a Hyperloop, so we should thank them. I wish to convey deep regard and hearty thanks to the officers of Indian Railways, my colleagues, who have come from all corners of India and have participated quite enthusiastically in the conference. I am sure you take with you excellent learnings from this conference. And how can I not thank my fellow colleagues of Nair, who have always stood by us and are ever enthusiastic about such endeavors and have participated in a big way today in this conference. Thanks to all my dear faculty members. A big shout out to Shri Javed Mathar, Senior Professor Finance and Investment, for the wholehearted cooperation and support for this event. And thanks also to my former colleague Shri Manish Agarwal, ex-Senior Professor Mechanical Engineering, for the in-depth discussions we had on this topic. Ladies and gentlemen, an event of this dimension cannot happen overnight. The wheels started rolling months in advance. A lot of hard work has gone into presenting this conference in the excellent way in which you have experienced and seen it today. And my most profound thanks go to the very motivated and dedicated members of the organizing team, Shri Anurag Kumar, Shri Vishal Raghavan, Shri Rajesh Unyal, Campus Superintendent and his team, Shri Bhagat, SNT Supervisor and his team, Shri keep the following, these are the real angels behind this whatever you are seeing. Shri Vinayak IW and his team, Shri Lalit, Electrical Supervisor and his team, Shrimati Adhirata Sharma, MGS Transport and his team, Shri Dignesh Joshi, MGS Press Institute of Beautiful and Yummy Food. All the personal secretaries and clerical staff and the peons and the Group D staff who have toiled day and night behind the scenes and literally burned the midnight oil to make this conference a success. Team Nair, take a bow. You rock. Without you, all this event would not have been possible. Thanks are also due to our partners, Messrs. Bona Concept Computers, Messrs. Javanik Printers, Shri Pratik Patel, Ace Computers, and our transport partners for various arrangements in this conference. I really hope and wish that before 2025, the Indian Hyperloop scenario becomes so vibrant and so strong that research teams from European countries and Canada, etc., why to compete in the Indian Hyperloop week rather than the other round at present. And in these parting moments, I am reminded of an African fable. In the jungles of Africa, every morning when the sun rises, a gazelle awakes. And the only thought he has in his mind to be able to run faster than the fastest lion. Otherwise he will be eaten up. In the same jungle, when the sun rises, a lion awakes. And he has only one thought in his mind. To be able to run faster than the slowest gazelle, otherwise he will die of hunger. Ladies and gentlemen, whenever the sun rises, whether you are a lion or whether you are a gazelle, you have to start running. Once again, thanks to all of you for coming to National Academy of Indian Railways for this conference. Hoping to meet you again on any such forum. Till then, keep enjoying and keep learning and take very, very good care of yourself. Namaskar, Jai Hind. This is your host.
Thank you.